Hello, I'm Timothy Jordan, and you're watching the Google I/O 2016 livestream. The keynote is over, but there are many more developer sessions to come. Stay tuned on all 4 livestream channels throughout the next 3 days. We'll also be on the ground and behind the scenes finding the coolest and most innovative things to share with you right here on the livestream between sessions. Oh, and if you want us to track someone down with your question, use the hashtag AskDevShow.
Right, here we go. Mr. Lewis, how do you feel about roller coasters?
Oh, I like them. Roller coaster of love. Let's roll.
So, I've got a bone to pick with you.
Oh, that's unusual.
So
We normally get on just fine.
Well, because I've been watching you.
No,
and,
that's a bit weird.
I've noticed that you've been engaging in some degree of Babel activity.
Oh,
You've
thank
been
goodness
using
for
a bit
that.
of the
Okay.
bit of the ES6, ES7.
Not quite as terrifying as I thought it might have been this.
But you're the kind of person who says, and I've heard you say this, that you don't like writing code that isn't the code that ends up being executed in the browser.
Correct.
Like
Can't
you
stand
don't
it.
like
Don't
those
it.
little middle steps. You're kind of anti-transpiler.
I am sort of anti-transparent. I want to feel like the code I write is the code that runs,
Right.
and I'm happy for a little bit of wool to be pulled over my eyes, but I want to feel like I can back out of it. So I don't think that's changed. I think for me, when I look at something like Babel, or Babelify or any of that, one thing is I feel like I could switch it out for Tracer, or I could switch it out for something else.
Because it's an open standard. I guess
Yes.
there are independent implementations of that standard.
Exactly.
Oh, okay, yeah, that's fair
so it's like it feels like this is the JavaScript I'm going to be writing, right? So a while from now. So if it's like if it's going to get me there, then that's fine. I'm okay with that. And then the other thing is, if you look at the ES5 that it generates, it's like it makes sense. It's fine. And I feel like when you look at some other things, whether that I don't know CoffeeScript or TypeScript, something like that, you can never say that because it's like you're always going to be transpiling across.
Yeah, I had this issue actually. I was using a project, npm installing something, using it, and
Right.
there was a bug, and I thought, as a citizen of the internet, I am going to do a pull request. I'm going to try and fix that. And
gift.
and when I got onto GitHub and click, CoffeeScript.
Oh,
I was like,
okay,
well,
yeah, no. Bye
well,
bye.
Now step 1 of making this fix is learn CoffeeScript.
Yeah, and it's like unless I really, really care about fixing the bug, it's not. For me, it's like JavaScript becomes, ES6, ES7, ES whatever.
Mm-hmm.
But like you say, this kind of, let's learn TypeScript or CoffeeScript or anything else. It's just like I've got to really want to go off and do that for some reason, and I don't see what that reason is because JavaScript for me for everything is fine. I actually really liked Babel, if for no other reason than its source maps were just super. So even though I wasn't really sort of aiming for that, when I did get an error, it was like whatever .js line whatever, and it was like, yeah, that is the correct line. And
Well, so even if you're not using source maps with Babel, the output is actually pretty sensible for the most part.
Yes.
But as you say, source maps just make it completely transparent. It's almost like you're not using a transpiler at all.
exactly. So I'm happy with the illusion of it. I think that's probably what it comes down to. But as I say, you're right. If you look at the actual code it generates, for me, I was just like, yeah, that's not necessarily code I'd write, but that's okay. It's just about manageable and readable.
So go on then. What are your big hitters in ES6 and 7 world? What's your favies?
My faves.
Your faves.
Contentious one would be classes. I actually really like classes because people are like, "What's wrong with the prototype? You're
but you're
turning your back on prototypes."
You're still using a prototype. It's just sugar.
Yes, exactly.
Yeah.
But a nice sugar at that. Very nice.
Yeah, because I don't know. I always mess it
Refined
up.
sugar.
Like if I'm doing like something.prototype equals object.create the thing I'm extending, and I keep forgetting the .prototype on the end there.
But that's one of about
It's
11
really difficult. It's really awkward
It's-
compared to class thing extend thing.
And that's the one way you do it in ES6. Like with the ES5, you've got 11 billion ways of doing it, and not all of them are good necessarily, or readable, or what you want to see if you're looking at your own code 6 months from now or somebody else's code. So it kind of felt like it was more like the code I want to write, more like the code I want to read. It's where we're going. It's a feature. It's not like somebody just went off piste and did something that they wanted to do. It's grand.
And I can barely remember how to spell function now.
Yeah.
Because you can within an object, it's just the name, brackets, off you go.
Yes.
There's arrow.
Fat arrow function
Fat
was
arrow.
something else I really liked.
Yep, yeah, we love a bit of fat arrow.
Yeah, because a number of times I use request animation frame, set timeout, set interval, something
Yep.
like that, and it's
Yep.
like, oh, all of a sudden I'm on the window scope, am I? Great, thanks for that. So bind, it's like, don't worry. I don't mind binding. It's better than var that equals this for me.
I don't.
You don't like
No,
that.
I don't do that equals this. But I will give it a specific, proper variable name.
Like
it's
what?
Based on the name of the class.
Like
Well, okay.
Jakey this, var Jakey this equals.
So if it's class vehicle,
yeah.
inside that I will do var vehicle equals this, like lowercase vehicle equals this, and it's. Yeah, but it makes sense then. I don't like that because it's like, well, that's just as because this is a problem in JavaScript, I think.
Yes.
Like this, so this what like,
Yeah.
and that's what one of the things that arrow functions solve is you there tends to only be one option for what the this is, and it's the instance name.
Yeah.
Which that makes way more.
So it works for me. I really like that.
Destructuring I like,
Beautiful. Beautiful.
especially for option objects.
Yes.
At the end of a
With defaults,
function.
right?
This is it. It becomes self-documenting. You can say, right, this is optional, but inside this object, here are the properties that I'm looking for, and here are their defaults.
Yep. But in any case, I feel like, going back to your original question, it's like the reason I would use a transpiler today is an if and only if it lets me experience the future now, get used to like the future now. I think it's where we're going.
Which you get with source maps. It feels like you can almost ignore the transpilers
Yeah,
there.
exactly. And as I say, the code that it generates makes sense to me. So I'm all up for that.
Yay for transpilers.
Yay!
Cheers. We need beers.
All right, well, it's getting pretty late. I think that was a pretty good take, so let's just do one more and then we'll be out for the day, okay, Rob?
All right.
3, 2.
Otherwise, as
Hey,
always,
Rob.
oh, hey, what's up, David?
Did I tell you that I got my own YouTube show?
Oh no, dude, that's awesome. What's it gonna be about?
So, like, I was thinking there's, not a lot of screencast content out there, and so I'm gonna go and make a bunch of screencasts on Firebase.
Well, that's sort of exactly what we're doing here for Polycast, a show about.
It's nothing like that, really. Like I said, my show is gonna be on Firebase. Like building real-time cross-platform apps, without any server code.
Well, I have all this equipment. I have this crew. So if you want, I can show you the ropes
I was thinking of
sometimes. Like how
calling
we
it
put the
Firecasts. Like the Firebase, is for the fire.
the Firebase, yeah.
And like the cast comes from screencast.
Screencasting.
Yeah.
Yeah.
What do you think?
Six lines of code is all it takes to write your first machine learning program. My name's Josh Gordon, and today I'll walk you through writing Hello World for machine learning. In the first few episodes of this series, we'll teach you how to get started with machine learning from scratch. To do that, we'll work with two open source libraries, scikit-learn and TensorFlow. We'll see scikit in action in a minute, but first let's talk quickly about what machine learning is and why it's important. You can think of machine learning as a subfield of artificial intelligence. Early AI programs typically excelled at just one thing. For example, Deep Blue could play chess at a championship level, but that's all it could do. Today we want to write one program that can solve many problems without needing to be rewritten. AlphaGo is a great example of that. As we speak, it's competing in the World Go Championship, but similar software can also learn to play Atari games. Machine learning is what makes that possible. It's the study of algorithms that learn from examples and experience instead of relying on hard-coded rules. So that's the state of the art, but here's a much simpler example we'll start coding up today. I'll give you a problem that sounds easy, but is impossible to solve without machine learning. Can you write code to tell the difference between an apple and an orange? Imagine I asked you to write a program that takes an image file as input, does some analysis, and outputs the type of fruit. How can you solve this? You'd have to start by writing lots of manual rules. For example, you could write code to count how many orange pixels there are and compare that to the number of green ones. The ratio should give you a hint about the type of fruit. That works fine for simple images like these, but as you dive deeper into the problem, you'll find the real world is messy, and the rules you write start to break. How would you write code to handle black and white photos? Or images with no apples or oranges in them at all? In fact, for just about any rule you write, I can find an image where it won't work. You'd need to write tons of rules, and that's just to tell the difference between apples and oranges. If I gave you a new problem, you'd need to start all over again. Clearly, we need something better. To solve this, we need an algorithm that can figure out the rules for us so we don't have to write them by hand. And for that, we're going to train a classifier. For now, you can think of a classifier as a function. It takes some data as input and assigns a label to it as output. For example, I could have a picture and I want to classify it as an apple or an orange. Or I could have an email and I want to classify it as spam or not spam. The technique to write the classifier automatically is called supervised learning. It begins with examples of the problem you want to solve. To code this up, we'll work with scikit-learn. Here, I'll download and install the library. There are a couple different ways to do that, but for me, the easiest has been to use Anaconda. This makes it easy to get all the dependencies set up and works well cross-platform. With the magic of video, I'll fast forward through downloading and installing it. Once it's installed, you can test that everything is working properly by starting a Python script and importing sklearn. Assuming that worked, that's line 1 of our program down, 5 to go. To use supervised learning, we'll follow a recipe with a few standard steps. Step 1 is to collect training data. These are examples of the problem we want to solve. For our problem, we're going to write a function to classify a piece of fruit. For starters, it will take a description of the fruit as input and predict whether it's an apple or orange as output, based on features like its weight and texture. To collect our training data, imagine we head out to an orchard. We'll look at different apples and oranges and write down measurements that describe them in a table. In machine learning, these measurements are called features. To keep things simple, here we've used just 2, how much each fruit weighs in grams and its texture, which can be bumpy or smooth. A good feature makes it easy to discriminate between different types of fruit. Each row in our training data is an example. It describes one piece of fruit. The last column is called the label. It identifies what type of fruit is in each row, and there are just 2 possibilities, apples and oranges. The whole table is our training data. Think of these as all the examples we want the classifier to learn from. The more training data you have, the better a classifier you can create. Now let's write down our training data in code. We'll use 2 variables, features and labels. Features contains the first 2 columns, and labels contains the last. You can think of features as the input to the classifier, and labels as the output we want. I'm going to change the variable type of all our features to ints instead of strings. So I'll use 0 for bumpy and 1 for smooth. I'll do the same for our labels, so I'll use 0 for apple and 1 for orange. These are lines 2 and 3 in our program. Step 2 in our recipe is to use these examples to train a classifier. The type of classifier we'll start with is called a decision tree. We'll dive into the details of how these work in a future episode, but for now it's okay to think of a classifier as a box of rules. That's because there are many different types of classifier, but the input and output type is always the same. I'm going to import the tree, then on line 4 of our script we'll create the classifier. At this point, it's just an empty box of rules. It doesn't know anything about apples and oranges yet. To train it, we'll need a learning algorithm. If a classifier is a box of rules, then you can think of the learning algorithm as the procedure that creates them. It does that by finding patterns in your training data. For example, it might notice oranges tend to weigh more, so it'll create a rule saying that the heavier a fruit is, the more likely it is to be an orange. In scikit, the training algorithm is included in the classifier object, and it's called fit. You can think of fit as being a synonym for find patterns in data. We'll get into the details of how this happens under the hood in a future episode. At this point, we have a trained classifier, so let's take it for a spin and use it to classify a new fruit. The input to the classifier is the features for our new example. Let's say the fruit we want to classify is 150 grams and bumpy. The output will be a 0 if it's an apple or 1 if it's an orange. Before we hit enter and see what the classifier predicts, let's think for a sec. If you had to guess, what would you say the output should be? To figure that out, compare this fruit to our training data. It looks like it's similar to an orange because it's heavy and bumpy. That's what I'd guess anyway, and if we hit enter, it's what our classifier predicts as well. If everything worked for you, then that's it for your first machine learning program. You can create a new classifier for a new problem just by changing the training data. That makes this approach far more reusable than writing new rules for each problem. Now you might be wondering why we described our fruit using a table of features instead of using pictures of the fruit as training data. Well, you can use pictures, and we'll get to that in a future episode, but as you'll see later on, the way we did it here is more general. The neat thing is that programming with machine learning isn't hard, but to get it right, you need to understand a few important concepts. I'll start walking you through those in the next few episodes. Thanks very much for watching, and I'll see you then.
Developing a successful app isn't easy. To reach a broad audience, you'll need to consider your iOS, Android, and mobile web users. And to build for these platforms, you'll need a backend server to store data and support the apps. Of course, you want to get your users logged in, hopefully lots of users, which means your backend will have to scale. Then after you've solved your scaling problems, you'll have to find more ways to spread the word to get new users. But have you found a way to measure all this activity? And oh no, your app is crashing and causing servers to melt down, and you haven't even made a dime yet. Don't you wish this could be easier? This is why we built Firebase. It has all the tools you need to build a successful app. It helps you reach new users, keep them engaged, scale up to meet that demand, in addition to getting paid. From the beginning, with Firebase, you'll have test lab and crash reporting to prevent and diagnose errors in your app. Your backend infrastructure problems are solved with our real-time database, file storage, and hosting solutions. Acquiring new users is easy with invites, AdWords, and dynamic links. And using the authentication component, you can get those users logged in with minimal friction. Once installed, you can keep your users engaged with notifications, cloud messaging, and app indexing. Then, with Remote Config, you'll have the freedom to experiment with new features and optimize the user experience in real time. And of course, you can earn money with the same AdMob component that's been monetizing great apps for years. Last, but certainly not least, our all-new Analytics component, designed uniquely for Firebase, brings insight into how well these components are working for you and your users. With Firebase Analytics, you can measure and optimize your advertising campaigns, discover who are your most valuable users, and understand exactly how they are using your app. Now, all these components work great on their own and provide a solid infrastructure to build out your app, but they work even better when combined in creative ways. So let Firebase handle the details of your app's backend infrastructure, user engagement, and monetization, while you spend more time building the apps your users will love. To get started right now with Firebase on Android, iOS, or the web, follow these links for more information. Then, to manage and monitor your apps connected to Firebase, there's a web console to view crashes, set up experiments, track analytics, and a whole lot more. And to learn more about Firebase and all of its components, you can read the documentation right here. We can't wait to see what you build.
Let's be honest, you're an awesome engineer with an awesome app and you are using threading to the max. Sadly though, managing all those individual threads and assigning work between them is causing you to lose your hair. My name is Colt McCandless, and please, don't join the Bald Club. Instead, use the thread pools class, which is an ideal primitive for breaking up lots of work into little buckets. See, historically, it was commonplace that applications would use a dedicated thread model. That is, one thread that only deals with database writes, while a separate thread only handles streaming of music, and a third one only handles networking. These setups are okay because the amount of work per thread isn't that large, and it's okay to handle this work in sequential order. But there reaches a point where this model starts to fall over. Say, for example, that you've got 40 bitmaps to decode, and each decode takes like 4 milliseconds or something. Putting all of this work on a single dedicated thread is a bad idea, since it'll take 80 milliseconds total to get all that work done in a sequential fashion. On the other hand, if you created 10 threads and let each one decode 4 bitmaps, then you'd end up only taking 16 milliseconds total. But then, of course, you run into the problem of how to properly pass the work around between those threads, schedule that work, and then managing of those threads. Before you start stressing out about writing all that code, don't worry. This is exactly what Thread Pool Executor primitive is for. Basically, this class will just let you spin up a number of threads and toss blocks of work to execute on it. Thread Pool Executor handles all of the heavy lifting of spinning up the threads, load balancing work across those threads, and even killing those threads when they have been idle for a while. Basically, it handles all the heavy lifting of super parallel processing on your behalf. All you have to do is split up the work. But there's a small caveat here. How many threads should your thread pool have? I mean, technically speaking, you have the ability to create as many threads as you want, but that's not ideal. See, CPUs can only execute a certain number of threads in parallel. Once you get above that number, then the CPU has to start deciding which threads get the next free block of processor time based on how important they are. Which means that if you keep eventually adding threads, you'll hit a break-even point where your computation isn't getting any faster, even though the number of threads that you have has increased significantly. And it's also important to note that each of these threads aren't free. Each thread costs you about 64K of memory in minimum, and that adds up quickly, especially in situations where the call stacks can start growing pretty large. As such, your app needs to find a sweet spot between the number of cores and the point of diminishing return with the number of threads. Thankfully, once again, the thread pool executor class has got you covered. When creating your thread pool, you can specify the number of initial threads and the number of maximum threads. As the workload in the thread pool changes, it'll scale the number of alive threads to match. Oh, and a quick note, the value returned from getAvailableProcessors may not reflect the number of physical cores in the device. See, some devices have CPUs that will deactivate one or more cores depending on the system load to save battery. So if your device has 2 CPUs but one of them is asleep, this value could return 1. And of course, thread pools won't solve all of your threading problems. As mentioned earlier, unless you're dealing with lots and lots of work packets all the time, this thing's kind of overkill. It's best to use things like handler threads or async task loaders for specific types of work blocks and only throw the massive computing problems at the thread pool. And for you power users out there, remember that RenderScript might be a better alternative to large-scale parallel work on Android devices, but that's a whole separate set of videos that we haven't gotten into yet. And don't forget that Systrace is an amazingly powerful tool that lets you visualize how work is flowing through the threads in your application. It's a great way to validate that things are working as intended and also see all the other crazy threads that are being worked on by other parts of your app. And that's the trick with performance, isn't it? I mean, you can make assumptions, but things don't always work the way you think, which is why you need to check out the rest of the Android Performance Patterns videos, and don't forget to join our Google Plus community to ask a lot of hard threading questions as well. So keep calm, profile your code, and always remember, perf matters.
Hey folks, welcome to Totally Tooling Tips Season 3.
Come check us out. We're going to be talking about progressive web apps, some of the tooling around them.
On first visit, we've got a relatively fast time to first meaningful paint. Module bundling, accessibility. Do you know what the top 4 things to look at when it comes to web accessibility are?
No, I can only think of 2. I only think of audio and then visual.
So there's visual, hearing, mobility, and cognition.
The first episode will be out on April the 27th. So subscribe to the YouTube channel, check out Season 1 and 2 before Season 3 starts, which will be happening soon.
We promise that Season 3 is going to be equally as mediocre as Seasons 1 and 2.
Welcome to the Googleplex. This is an incredible place with lots of great stuff being worked on every single day. Before I worked here, I always wondered what it would be like to come to the Googleplex, meet up with a Googler, and have coffee with them, and just chat about what they do, how they do it, and why they do it. And today we're going to do exactly that. Welcome to this episode of Coffee with a Googler, and if you, like me, love games and love 3D games and all that kind of stuff, then this show should be a treat for you. Because today I'm chatting with Shannon Woods, who's a technical program manager, and she works on our rendering teams at Google, and she's got lots of great stuff to talk about in the 3D space. So welcome, Shannon. How are you?
I'm doing all right. How are you?
Really good. I have to say I'm really envious of your job, but could you tell us what you do?
So I work with a couple of rendering teams here at Google, both Android and Chrome. And we sort of plumb code from user space down to your GPU.
Wow. Can you translate that?
Basically, our job is to get a bunch of triangles from applications down to the GPU as fast as possible.
Cool. And all graphics are ultimately made up of triangles, right?
Basically.
Now, recently you announced Vulkan. Right, and this is this like new and improved 3D rendering API. Could you tell us a bit about it?
Historically, Android and all mobile phones really have used OpenGL ES to communicate to the GPU within the phone to tell it how to draw scenes. But unfortunately, over time, the API has become less and less of a good match for what the hardware is actually doing beneath. So what would happen is you would use this API to communicate a lot of the details about your scene, and the GPU has to reorganize all of that so that it can consume it efficiently and draw it on the screen. So what Vulkan is it's another API from the same open standards group that makes OpenGL. And it's designed to be a lot closer to what the hardware actually does beneath the covers.
Okay.
So if you provide the data via Vulkan, it should be able to draw a lot quicker. Sort of the flip side of that is that, it gives you all of this control, but it means that you have to be pretty good at making sure that your code is doing exactly what you wanted it to do.
Vulkan and OpenGL ES are both from the same standards body, right?
Yes.
So that's Khronos?
Yes, Khronos.
Khronos, sorry. So you work with the standards body at Khronos?
I do. I get to travel all around the world and see beautiful conference rooms. But it's actually really interesting getting to see how the API is made from the ground up.
Cool.
Android is going to support both OpenGL ES and Vulkan. So developers can choose which API is right for what they're doing. Like if they need to render a FPS game or first-person shooting game that has to run really fast at a high frame rate, then they're going to probably want to choose Vulkan so that they can closely control exactly what's being drawn and when.
Cool.
But if they just want to get a couple of shapes on screen, then OpenGL ES is probably still the right choice for them.
Cool. So it's just really nice to have both.
Yes.
Cool. So, and from my understanding, what you're saying with Vulkan, like just being able to get down to the chipset level effectively allows you to squeeze a lot more performance out of the machine.
Yeah, it does. And one of the other things that it does is that it allows for greater parallelization.
Okay.
There's a lot of work in OpenGL ES that it's blocking work. You make a call into OpenGL ES, into the driver code, and it has to stop and perform the task that you asked it to do, and doesn't return control to the application until it finishes that task. And what this means is that if you have multiple threads, only one of them can really be talking to the driver doing these things at the same time. Vulkan is designed more for multi-threaded applications, so you can have multiple threads doing things like constructing buffers full of commands at the same time.
You're getting onto like programming and skills, and like from a skills perspective, and is the things that developers will need to learn that they don't do already, for example, if they're doing 3D games in OpenGL ES?
So the skill sets are going to be largely the same. As a Vulkan developer, you're going to have probably a tighter handle on things like synchronization, careful tracking of memory allocation, because a lot less of that is going to be done for you by the driver. The upside of this is that the driver won't be doing these things when you don't expect it to. But you're going to have to really hone your skills at things like multi-threaded synchronization, memory allocation. Make sure that you are closely keeping an eye on what your code is doing and what it's asking the GPU to do, because the driver is going to do a whole lot less of that for you. It's not going to clean up after you. It's not going to check that you are making legal calls. So you're basically going to have to be a bit of a ninja.
It's almost like driving stick versus driving manual, right?
That's probably a really good analogy.
So people can learn about Vulkan on the Khronos site?
Yes.
You mentioned. So that's Khronos.org?
Khronos.org, www.khronos.org. And Khronos is spelled Khronos. And they have a Vulkan landing page where you can find the latest news about Vulkan and also see some of the presentations that were given, for example, at SIGGRAPH this year and at GDC about the shape of the API.
Okay. Now, you were at SIGGRAPH, right?
I was at SIGGRAPH.
How did it go?
It was a lot of fun, actually. We did some demos, showed some spinning teapots.
Teapots?
So there's a little bit of history behind the teapot.
Okay.
The teapot is canonically called the Utah teapot, and it's because way back in the history of computer graphics, it's one of the first models that was digitized and shared. And interestingly, so the teapot, everybody knows that they've seen here and there over the years, it looks short and squat.
Okay.
But the reason for that is actually that on the original display system, the pixels were not square. So they had a different
ones from
TVs. The aspect ratio is a little bit different. So in real life, the teapot's actually a little taller.
Now, you're saying that the pixels are like elongated, they were rectangular pixels, because this was done so long ago?
Oh, yeah, it was, oh gosh, I guess it was the 70s.
Wow. So the first 3D model that was formed in cyberspace, or whatever you want to call it, back in the 70s, and you're still using the same model today to... I think Pixar also used the teapot, don't they?
Yeah, actually, the teapot appears in every Pixar film. One of the ones I know off the top of my head is they use it in the Tea Party scene in Toy Story.
Okay, naturally, that's where a teapot would fit.
Yeah, but there's one in every Pixar film.
Thank you so much, Shannon.
Thank you.
And thanks everybody for watching this episode of Coffee with a Googler. I don't know about you, but I've learned a lot about the kind of things that can be done with 3D graphics. And I'm really, really excited about Vulkan coming to Android. If you've got any questions for me, or if you've got any questions for Shannon, just please leave them in the comments below. We'll also link to the websites in the description of this video so that you can follow those links. And if you want to learn anything else about great stuff that Google has to offer for Android developers, Chrome developers, and everybody else, please subscribe to the Google Developers channel. Thank you.
With Android Lollipop, Material Design changed the way that apps look and feel to create more magic moments. But devices running earlier versions of Android don't have all of the same options. I'm Joanna Smith, and one of the coolest things that Material Design gave us were toolbars, which are now even more magical because they're backwards compatible as well. A toolbar is a view that is richer and more flexible than the traditional action bar. In fact, toolbars are part of your view hierarchy, so they can be animated or even react to scroll events. Because it's a view, you can use the toolbar as a standalone element anywhere in your app, providing the user with options and controls that don't need to span the entire layout width at the very top of the screen. You can even have multiple toolbars if the structure depends on the content of your layout, or if you're providing the user with many differing controls. To populate your toolbar with actions and options, you can inflate a menu onto the toolbar to display those actions to the user. You can also create your own controls, like adding a navigation button to go up to the parent activity. While toolbars can be used in any part of your layout, you can also choose to use the toolbar instead of the action bar whenever you simply want more control over the appearance and functionality of that action bar. So to use a toolbar in the place of the standard action bar, you first need to disable the action bar. The easiest way to do this is to have your theme extend from Theme AppCompat No Action Bar, or its light variant. Then create your toolbar the way you would create any other layout in your app, and call setActionBar to designate it as the action bar in the activity or fragment. By calling this method, the system will add the standard action bar options for you, so you don't need to inflate a menu. Now, you may be convinced of how awesome toolbars are, but how can you use them in versions of your app targeting older SDKs? Well, toolbars were added to the support library for AppCompat v21, so now it's as easy as calling setSupportActionBar instead of setActionBar to replace action bars on older devices. So check the documentation for all of the support options available so that you can bring more magic moments to your users. And for more tips on making sure that your app is at its best, check out the rest of our Android Development Patterns content or consider joining our G+ community. But most importantly, just continue to build better apps.
As a lot of developers know, there's more to having an app succeed than just building a great app. You want your app to be dynamic and responsive by delivering fresh content to users and quickly reacting to their changing needs. You want to test out major decisions to make sure you're doing the right thing before you push them to your entire audience. And ideally, you want to provide a tailored experience for each user, so your VIPs feel like, well, VIPs. But let's be honest, that can be a lot of work. And if you're a developer without a ton of resources, that's time you'd rather spend on other things, like building your app. That's where Firebase Remote Config comes in. Firebase Remote Config is a simple key value store that lives in the cloud. But don't let that simplicity fool you. Because it lives in the cloud, it means you're able to deploy changes that your app can read within a matter of minutes. For instance, say you've just pushed your app out to the world and you suddenly discover that your Swedish text contains some offensive language. How are you supposed to know? You don't speak Swedish. I don't blame you. But fixing that text the old-fashioned way would mean creating a new build and going through the entire publishing process again. That's something that could take days, which is an awfully long time to have 9.2 million people cursing your name. But if your app uses Firebase Remote Config, you could change that text in the cloud through the Firebase console. Kind of like this. The next time your users fire up their app, Remote Config will grab the latest values, update your app's text, and just like that, you've averted a major international crisis. Or, let's say you've got a puzzle game and you're hearing complaints from your players that level 5 is too hard. If you've configured your app using Remote Config, you could tweak those settings to give your players a few more turns and push out that change to the world. But hang on, are you sure that's the right thing to do? What if the silent majority of your users actually enjoy the challenge of a more difficult level? And by making it easier, you're going to turn away your most hardcore and potentially highest paying customers. How could you test whether or not this change is a good one? Sounds like you need an A/B test. That's where Remote Config's audience segmentation feature comes in. This allows you to deliver different configurations to different groups of users simultaneously. So you can try out your new level settings with half your users while keeping the old settings with the other half. But audience segmentation isn't just great for A/B testing. Maybe you've got a feature change that could have a major impact on your in-app economy. Or maybe you just want to double check that some new networking code isn't going to set your servers on fire. You can use Firebase Remote Config to gradually roll out these changes, trying them first with a small percentage of your users before pushing them out to your entire audience. Remote Config can also deliver different configuration sets to your users based on all sorts of different factors, from device type or locale to any audience segment you've defined in Firebase Analytics. So you can send out one welcome message to your New Zealand customers and another to your Australian ones, or only show your Review This App button to people who use your app every day, or you can change your home screen experience for your customers who have spent large amounts of money on in-app purchases, so they feel special. Remote Config is backed by a client library on iOS and Android that handles important tasks like caching, dealing with flaky connections, and keeping network requests lightweight, which is always a good thing. To give Remote Config a try, check out our documentation here. We can't wait to see what you build.
Here's an old school tip for you. If you can animate something based on user input, you probably don't want to have it update immediately to track the input event, because it can often feel very jittery. Instead, what you should do is use the oldest easing equation in the book, which looks like this: value plus equals target minus value all over strength. Here we're changing the value based on how close it is to the target. The closer it is, the less it gets moved, making it look way nicer. So there you have it, a little tip to make your input-based animations a teeny bit smoother.
Another day, another journey. I know indeed, right? How's your aim?
Well, not great in the middle of the night, but I sometimes just sit down.
No, actually I meant your snooker, your pool, or in this case, your billiards.
Ooh, we're going to a billiard hall?
That we are, sir.
So, I made a thing.
That's unusual for you.
I know.
You're like 2 in as many months or something.
Yeah, it's a new thing. It's
what is it?
It's a little.
Is it a web app?
Yes, it is a web app.
Is it a website? What's the difference, Jake?
Shut up. We're not doing web apps because it's a website. I would say it's an app.
Would you?
An
app with content?
Flipped a coin. It's an app. No, it's not. It's a site. It's a Wikipedia article viewer.
Okay.
Which I realise is what Wikipedia does already.
Yes.
But this was more of an exercise in looking at like performance, like page load time performance.
But you think you can beat Wikipedia at a server-side render, do you?
I did.
You did?
Well, so this is the thing. I was hosting on GitHub, so I was doing a client-side render.
I know. After all you said.
It seemed like a nice, simple way to get into it. And I was serving it just, JavaScript down the wire, then JavaScript's getting the content and putting it on the page. And I was you're looking at my official figures, 2.6 seconds for first render.
Okay.
And 4.7 seconds for content, which even at that point was faster than Wikipedia's actual official site.
Oh.
But, I knew it could be better than that.
Okay. What was in that first render?
First render was just like the top toolbar that said like Wikipedia and a spinner.
Okay, but from a user's point of view, they've got something. They know they're on the way. Okay.
Yeah. And then I think it was 4.7 seconds till the actual Wikipedia article came down.
So you've actually got a good couple of seconds there where you're spinning up, where your app doesn't seem to be it's idle, essentially.
Yeah, I know you're pulling your sad face, but don't worry, that's not the
I'm
end
pulling
of the story.
a mulling face. I'm mulling over.
Okay. Well, pulling your mulling face, I can tell you what I did to fix it. There's a happy.
Better than my other faces.
You okay? You're having a stroke. So yeah, I made the JavaScript async.
Okay.
And put some markup on the page for that first render.
Yes.
And I inlined the CSS for that first render.
Good. Normal. All normal.
Well, you say normal. When I first heard that rule, it was like, take some of your CSS out and put it in the head. I was like, that's a big ask for developers, really.
Whoa, big what? It's a big ask.
Yeah,
Again,
okay.
You
It's a
keep
big
saying,
ask.
It's a request, pal.
Yeah,
That's what it
I
is.
know. Oh my God, I hate
You
it when
become
people,
that person. You become
when
that
people
person.
say that.
Yeah. Next up, you'll be asking to reason about things, or using modulo.
To reason about, I hate that one, because it is just developers not wanting to say they don't understand.
I actually do like modulo, but
So, I do agree that it's too hard to async load CSS. This is something that we
Yes.
have a problem with on the platform,
yes,
right?
I actually tried it. It's rubbish.
Yeah, we've got load CSS from the Filament group, but it's more script than you should need. It should just be async on the link
Yeah,
element.
it should be declarative. Yeah.
But moreover, I think what Firefox and IE do at the moment is actually really good. It's a bit of non-standard behavior, but I really like it. Put the link element on the page, in the body, just before the content that needs it. And it will block the rendering, wait for it, it'll block the rendering of the subsequent content until that CSS loads. It's not blocking all page rendering.
Okay.
It's just the elements after don't go into the render tree.
Okay, fair enough.
We should do that.
Yes.
We should take that on. And we should also have async as well.
Okay, so
So,
here
yeah,
we
where
are.
am I?
We
Okay,
had a
we're getting
parallelizable thing last I understood of where you had the JavaScript that went off to get the Wikipedia page, and I'm
Yep,
saying
yep.
that's bonkers.
And so, yes, I came to the same conclusion. I thought, this needs server rendering.
Wise man.
Yep, thank you. Let's do a proper
Cheers
cheers.
to
Cheers
server side.
rendering.
Well, this is the nerdiest chair that ever went up.
So, like, looking at my calculations, once I introduced server rendering, things got slower.
Right.
That's
a bit annoying.
My content render actually sort of came down a little bit, not much, but my first render skyrocketed.
Why?
It was slower because connection goes off to my server.
Yes.
My server goes off to Wikipedia, gets the data, comes back, constructs the page, sends it on. You're looking at a white screen for longer now because you've got the bottleneck of your third-party service. But it was, you know, by taking that, just the JavaScript CSS, the basic page shell, down to 0.1 seconds, like as good as instant for that first render, because it's all offline. But here's an interesting thing that happened, is my content render went, because I'm now back to doing client-side rendering, content render's gone up again. Because even though it's coming from the cache, there was two problems. There's one that it was the request to Wikipedia is a little bit delayed because it has to parse the JavaScript
To Wikipedia.
To Wikipedia.
It's delayed. I like that. It's almost like a...
I didn't do that on purpose.
Really?
But yeah, so I cut that delay by, as soon as the request went to the service worker, had the service worker go off and fetch the stuff for Wikipedia.
Oh, okay, so how do you then, because you still want to send your response back with the app shell stuff.
Yep. What you're talking about there is chunked encoding.
Ah, okay.
So this is the art of being
Never
able
done
to, so being able to quickly send data back, like without knowing your whole page content. So I was able to send back like the header and the first render stuff essentially. So now the browser knows about the extra CSS and JavaScript it needs. Meanwhile, or like at the first possible opportunity, my server's gone off to Wikipedia and it's gathering that. And then as it arrives, it just streams it through, and that slashed the rendering time. We got down to, well, so we were at 1.4 seconds for first render, and when I get the official figures up, so that was it down to 2.4 seconds for the content, and that's like a 2-second saving compared to JavaScript.
That's good.
3G. Yeah, it's pretty huge. And
you can't really get any better than that, can you?
Oh, you can, sir, by using a little technology you might not have heard of before. Service worker!
Yay!
But yeah, as soon as you take the content, the page shell offline, that's it. You can get to that first render in like 0.1 seconds. Like the measurement came out, but it's instant, really.
Yeah.
But it took 9K of the content down the wire, and once I had that, wrote it to the page, and then wrote again once I had the rest. And it was a total hack to do that. And this is why my next wish for the internet, for the web standard, is streams. Because I want to be able to just take some content that we're downloading, pipe it into an element, and it appears as it. And I think once we have that, that kind of rendering as it goes along, I think that's when we can see client-side rendering apps become competitive with server-rendered apps.
We'll drink to that.
Cheers.
Hello, I'm Timothy Jordan, and you're watching the Google I/O 2016 livestream. The keynote is over, but there are many more developer sessions to come. Stay tuned on all 4 live stream channels throughout the next 3 days. We'll also be on the ground and behind the scenes finding the coolest and most innovative things to share with you right here on the live stream between sessions. Oh, and if you want us to track someone down with your question, use the hashtag AskDevShow.
Right, here we go. Mr. Lewis, how do you feel about roller coasters?
Oh, I like them. Roller coaster of love. Let's roll.
So, I've got a bone to pick with you.
Oh, that's unusual.
So
we normally get on just fine.
Well, because I've been watching you.
No,
and,
that's a bit weird.
I've noticed that you've been engaging in some degree of Babel activity.
Oh,
You've been using a bit of the ES6, ES7.
Not quite as terrifying as I thought it might have been this.
But you're the kind of person who says, and I've heard you say this, that you don't like writing code that isn't the code that ends up being executed in the browser.
Correct.
Like you don't like those little middle steps. You're kind of anti-transpiler.
I am sort of anti-transpiler. I want to feel like the code I write is the code that runs,
Right.
and I'm happy for a little bit of wool to be pulled over my eyes, but I want to feel like I can back out of it. So I don't think that's changed. I think for me, when I look at something like Babel, or Babelify or any of that, one thing is I feel like I could switch it out for Tracer, or I could switch it out for something else.
Because it's an open standard. I guess there are independent implementations of that standard.
Exactly. And
Okay, yeah, that's fair
so it's like it feels like this is the JavaScript I'm going to be writing, right? So a while from now. So if it's going to get me there, then that's fine. I'm okay with that. And then the other thing is, if you look at the ES5 that it generates, it's like, it makes sense, it's fine. And I feel like when you look at some other things, whether that, I don't know, CoffeeScript or TypeScript, something like that, you can never say that, because it's like, you're always going to be transpiling across.
Yeah, I had this issue actually. I was using a project, npm installing something, using it, and there was a bug, and I thought, as a citizen of the internet, I am going to do a pull request. I'm going to try and fix that. And and when I got onto GitHub and click, CoffeeScript.
Oh,
I was like,
okay, yeah, no, bye-bye.
Now step 1 of making this fix is learn CoffeeScript.
Yeah, and it's like, unless I really, really care about fixing the bug, it's not. For me, it's like JavaScript becomes, ES6, ES7, ES whatever. Mm-hmm. But like you say, this kind of, let's learn TypeScript or CoffeeScript or anything else. It's just like, I've got to really want to go off and do that for some reason, and I don't see what that reason is, because JavaScript for me, for everything, is fine. I actually really liked Babel, if for no other reason than its source maps were just super. So even though I wasn't really sort of aiming for that, when I did get an error, it was like, whatever .js line, whatever, and it was like, yeah, that is the correct line. And
well, so even if you're not using source maps with Babel, the output is actually pretty sensible for the most part.
Yes.
But as you say, source maps just make it completely transparent. It's almost like you're not using a transpiler at all.
Exactly. So I'm happy with the illusion of it, I think. That's probably what it comes down to. But as I say, you're right. If you look at the actual code it generates, for me, I was just like, yeah, that's not necessarily code I'd write, but that's okay. It's just about manageable and readable.
So go on then. What are your big hitters in ES6 and 7 world? What's your favies?
My faves.
Your faves.
Contentious one would be classes. I actually really like classes, because people are like, what's wrong with the prototype? You're turning your back on prototypes.
You're still using a prototype, it's just sugar.
Yes, exactly,
Yeah.
but a nice sugar at that. Very nice.
Yeah, because I don't know, I always mess it
Refined
up.
sugar.
Like if I'm doing like something.prototype equals object.create the thing I'm extending, and I keep forgetting the .prototype on the end there.
But that's one of about
It's
11
really difficult. It's really awkward compared to class thing extend thing.
And that's the one way you do it in ES6. Like with the ES5, you've got 11 billion ways of doing it, and not all of them are good necessarily, or readable, or what you want to see if you're looking at your own code 6 months from now or somebody else's code. So it kind of felt like it was more like the code I want to write, more like the code I want to read. It's where we're going. It's a feature. It's not like somebody just went off piste and did something that they wanted to do.
And I can barely remember how to spell function now. Because you can within an object, it's just the name, brackets, off you go.
Yes.
There's arrow.
Fat arrow function was something else I really liked.
Yep, we love a bit of fat arrow.
Yeah, because a number of times I use request animation frame, set timeout, set interval, something like that, and it's
Yep.
like, oh, all of a sudden I'm on the window scope, am I? Great, thanks for that. So bind, it's like, Don't worry. I mean, I don't mind binding. It's better than var that equals this for me.
I don't.
You don't like that.
No, I don't do that equals this. But I will give it a specific, proper variable name.
Like what?
Based on the name of the class.
Like
well, okay.
Jakey this, var Jakey this equals.
So if it's class vehicle,
yeah.
Inside that I will do var vehicle equals this, like lowercase vehicle equals this, and it's. Yeah, but it makes sense then. I don't like that because it's like, well, that's just as because this is a problem in JavaScript, I think.
Yes.
Like this, so this what? Like, yeah. And that's what one of the things that arrow functions solve is you there tends to only be one option for what the this is, and it's the instance name.
Yeah.
Which that makes way more.
So it works for me. I really like that.
Destructuring I like.
Beautiful.
Especially for option objects.
Yes.
At the end of a
with defaults,
function.
right?
This is it. It becomes self-documenting. You can say, right, this is optional. But inside this object, here are the properties that I'm looking for, and here are their defaults.
Yep. But in any case, I feel like, going back to your original question, it's like the reason I would use a transpiler today is an if and only if it lets me experience the future now, get used to like the future now. I think it's where we're going.
Which you get with source maps. It feels like you can almost ignore the transpilers there.
Yeah, exactly. And as I say, the code that it generates makes sense to me. So I'm all up for that.
Yay for transpilers.
Yay.
Cheers. We need beers.
All right, well, it's getting pretty late. I think that was a pretty good take, so let's just do one more and then we'll be out for the day. Okay, Rob?
All right.
3, 2.
Otherwise, as always,
Rob.
Oh, hey, what's up, David?
Did I tell you that I got my own YouTube show?
Oh, no, dude, that's awesome. What's it gonna be about?
So, like, I was thinking there's, not a lot of screencast content out there, and so I'm gonna go and make a bunch of screencasts on Firebase.
Well, that's sort of exactly what we're doing here for Polycast, a show about...
It's nothing like that, really. Like I said, my show is gonna be on Firebase, like building real-time cross-platform apps, without any server code.
Well, I have all this equipment, I have this crew, so if you want, I can show you the ropes
sometimes. So I was thinking of calling it
put the
Firecasts, like the Firebase, it's for the fire.
Yeah, the Firebase, yeah.
And, like the cast comes from screencast.
Screencasting.
Yeah.
Yes.
What do you think?
Six lines of code is all it takes to write your first machine learning program. My name's Josh Gordon, and today I'll walk you through writing Hello World for machine learning. In the first few episodes of this series, we'll teach you how to get started with machine learning from scratch. To do that, we'll work with two open source libraries, scikit-learn and TensorFlow. We'll see scikit in action in a minute, but first let's talk quickly about what machine learning is and why it's important. You can think of machine learning as a subfield of artificial intelligence. Early AI programs typically excelled at just one thing. For example, Deep Blue could play chess at a championship level, but that's all it could do. Today we want to write one program that can solve many problems without needing to be rewritten. AlphaGo is a great example of that. As we speak, it's competing in the World Go Championship, but similar software can also learn to play Atari games. Machine learning is what makes that possible. It's the study of algorithms that learn from examples and experience instead of relying on hard-coded rules. So that's the state of the art, but here's a much simpler example we'll start coding up today. I'll give you a problem that sounds easy, but is impossible to solve without machine learning. Can you write code to tell the difference between an apple and an orange? Imagine I asked you to write a program that takes an image file as input, does some analysis, and outputs the type of fruit. How can you solve this? You'd have to start by writing lots of manual rules. For example, you could write code to count how many orange pixels there are and compare that to the number of green ones. The ratio should give you a hint about the type of fruit. That works fine for simple images like these. But as you dive deeper into the problem, you'll find the real world is messy, and the rules you write start to break. How would you write code to handle black and white photos? Or images with no apples or oranges in them at all? In fact, for just about any rule you write, I can find an image where it won't work. You'd need to write tons of rules, and that's just to tell the difference between apples and oranges. If I gave you a new problem, you'd need to start all over again. Clearly, we need something better. To solve this, we need an algorithm that can figure out the rules for us so we don't have to write them by hand. And for that, we're going to train a classifier. For now, you can think of a classifier as a function, It takes some data as input and assigns a label to it as output. For example, I could have a picture and I want to classify it as an apple or an orange. Or I could have an email and I want to classify it as spam or not spam. The technique to write the classifier automatically is called supervised learning. It begins with examples of the problem you want to solve. To code this up, we'll work with scikit-learn. Here, I'll download and install the library. There are a couple different ways to do that, but for me, the easiest has been to use Anaconda. This makes it easy to get all the dependencies set up and works well cross-platform. With the magic of video, I'll fast forward through downloading and installing it. Once it's installed, you can test that everything is working properly by starting a Python script and importing sklearn. Assuming that worked, that's line 1 of our program down, 5 to go. To use supervised learning, we'll follow a recipe with a few standard steps. Step 1 is to collect training data. These are examples of the problem we want to solve. For our problem, we're going to write a function to classify a piece of fruit. For starters, it will take a description of the fruit as input and predict whether it's an apple or orange as output, based on features like its weight and texture. To collect our training data, imagine we head out to an orchard. We'll look at different apples and oranges and write down measurements that describe them in a table. In machine learning, these measurements are called features. To keep things simple, here we've used just 2, how much each fruit weighs in grams and its texture, which can be bumpy or smooth. A good feature makes it easy to discriminate between different types of fruit. Each row in our training data is an example. It describes one piece of fruit. The last column is called the label. It identifies what type of fruit is in each row, and there are just 2 possibilities, apples and oranges. The whole table is our training data. Think of these as all the examples we want the classifier to learn from. The more training data you have, the better a classifier you can create. Now let's write down our training data in code. We'll use 2 variables, features and labels. Features contains the first 2 columns, and labels contains the last. You can think of features as the input to the classifier, and labels as the output we want. I'm going to change the variable type of all our features to ints instead of strings. So I'll use 0 for bumpy and 1 for smooth. I'll do the same for our labels, so I'll use 0 for apple and 1 for orange. These are lines 2 and 3 in our program. Step 2 in our recipe is to use these examples to train a classifier. The type of classifier we'll start with is called a decision tree. We'll dive into the details of how these work in a future episode, but for now it's okay to think of a classifier as a box of rules. That's because there are many different types of classifier, but the input and output type is always the same. I'm going to import the tree, then on line 4 of our script we'll create the classifier. At this point, it's just an empty box of rules. It doesn't know anything about apples and oranges yet. To train it, we'll need a learning algorithm. If a classifier is a box of rules, then you can think of the learning algorithm as the procedure that creates them. It does that by finding patterns in your training data. For example, it might notice oranges tend to weigh more, so it'll create a rule saying that the heavier a fruit is, the more likely it is to be an orange. In scikit, the training algorithm is included in the classifier object, and it's called fit. You can think of fit as being a synonym for find patterns in data. We'll get into the details of how this happens under the hood in a future episode. At this point, we have a trained classifier, so let's take it for a spin and use it to classify a new fruit. The input to the classifier is the features for our new example. Let's say the fruit we want to classify is 150 grams and bumpy. The output will be a 0 if it's an apple or 1 if it's an orange. Before we hit enter and see what the classifier predicts, let's think for a sec. If you had to guess, what would you say the output should be? To figure that out, compare this fruit to our training data. It looks like it's similar to an orange because it's heavy and bumpy. That's what I'd guess anyway, and if we hit enter, it's what our classifier predicts as well. If everything worked for you, then that's it for your first machine learning program. You can create a new classifier for a new problem just by changing the training data. That makes this approach far more reusable than writing new rules for each problem. Now you might be wondering why we described our fruit using a table of features instead of using pictures of the fruit as training data. Well, you can use pictures, and we'll get to that in a future episode, but as you'll see later on, the way we did it here is more general. The neat thing is that programming with machine learning isn't hard, but to get it right, you need to understand a few important concepts. I'll start walking you through those in the next few episodes. Thanks very much for watching, and I'll see you then.
Developing a successful app isn't easy. To reach a broad audience, you'll need to consider your iOS, Android, and mobile web users. And to build for these platforms, you'll need a backend server to store data and support the apps. Of course, you want to get your users logged in, hopefully lots of users, which means your backend will have to scale. Then after you've solved your scaling problems, you'll have to find more ways to spread the word to get new users. But have you found a way to measure all this activity? And oh no, your app is crashing and causing servers to melt down, and you haven't even made a dime yet. Don't you wish this could be easier? This is why we built Firebase. It has all the tools you need to build a successful app. It helps you reach new users, keep them engaged, scale up to meet that demand, in addition to getting paid. From the beginning, with Firebase, you'll have test lab and crash reporting to prevent and diagnose errors in your app. Your backend infrastructure problems are solved with our real-time database, file storage, and hosting solutions. Acquiring new users is easy with invites, AdWords, and dynamic links. And using the authentication component, you can get those users logged in with minimal friction. Once installed, you can keep your users engaged with notifications, cloud messaging, and app indexing. Then, with Remote Config, you'll have the freedom to experiment with new features and optimize the user experience in real time. And of course, you can earn money with the same AdMob component that's been monetizing great apps for years. Last, but certainly not least, our all-new Analytics component, designed uniquely for Firebase, brings insight into how well these components are working for you and your users. With Firebase Analytics, you can measure and optimize your advertising campaigns, discover who are your most valuable users, and understand exactly how they are using your app. Now, all these components work great on their own and provide a solid infrastructure to build out your app, but they work even better when combined in creative ways. So let Firebase handle the details of your app's backend infrastructure, user engagement, and monetization, while you spend more time building the apps your users will love. To get started right now with Firebase on Android, iOS, or the web, follow these links for more information. Then, to manage and monitor your apps connected to Firebase, there's a web console to view crashes, set up experiments, track analytics, and a whole lot more. And to learn more about Firebase and all of its components, you can read the documentation right here. We can't wait to see what you build.
Let's be honest, you're an awesome engineer with an awesome app and you are using threading to the max. Sadly though, managing all those individual threads and assigning work between them is causing you to lose your hair. My name is Colt McCandless, and please, don't join the Bald Club. Instead, use the thread pools class, which is an ideal primitive for breaking up lots of work into little buckets. See, historically, it was commonplace that applications would use a dedicated thread model. That is, one thread that only deals with database writes, while a separate thread only handles streaming of music, and a third one only handles networking. These setups are okay because the amount of work per thread isn't that large, and it's okay to handle this work in sequential order. But there reaches a point where this model starts to fall over. Say, for example, that you've got 40 bitmaps to decode, and each decode takes like 4 milliseconds or something. Putting all of this work on a single dedicated thread is a bad idea, since it'll take 80 milliseconds total to get all that work done in a sequential fashion. On the other hand, if you created 10 threads and let each one decode 4 bitmaps, then you'd end up only taking 16 milliseconds total. But then, of course, you run into the problem of how to properly pass the work around between those threads, schedule that work, and then managing of those threads. Before you start stressing out about writing all that code, don't worry. This is exactly what Thread Pool Executor primitive is for. Basically, this class will just let you spin up a number of threads and toss blocks of work to execute on it. Thread Pool Executor handles all of the heavy lifting of spinning up the threads, load balancing work across those threads, and even killing those threads when they have been idle for a while. Basically, it handles all the heavy lifting of super parallel processing on your behalf. All you have to do is split up the work. But there's a small caveat here. How many threads should your thread pool have? I mean, technically speaking, you have the ability to create as many threads as you want, but that's not ideal. See, CPUs can only execute a certain number of threads in parallel. Once you get above that number, then the CPU has to start deciding which threads get the next free block of processor time based on how important they are. Which means that if you keep eventually adding threads, you'll hit a break-even point where your computation isn't getting any faster, even though the number of threads that you have has increased significantly. And it's also important to note that each of these threads aren't free. Each thread costs you about 64K of memory in minimum, and that adds up quickly, especially in situations where the call stacks can start growing pretty large. As such, your app needs to find a sweet spot between the number of cores and the point of diminishing return with the number of threads. Thankfully, once again, the thread pool executor class has got you covered. When creating your thread pool, you can specify the number of initial threads and the number of maximum threads. As the workload in the thread pool changes, it'll scale the number of alive threads to match. Oh, and a quick note, the value returned from getAvailableProcessors may not reflect the number of physical cores in the device. See, some devices have CPUs that will deactivate one or more cores depending on the system load to save battery. So if your device has 2 CPUs but one of them is asleep, this value could return 1. And of course, thread pools won't solve all of your threading problems. As mentioned earlier, unless you're dealing with lots and lots of work packets all the time, this thing's kind of overkill. It's best to use things like handler threads or async task loaders for specific types of work blocks and only throw the massive computing problems at the thread pool. And for you power users out there, remember that RenderScript might be a better alternative to large-scale parallel work on Android devices, but that's a whole separate set of videos that we haven't gotten into yet. And don't forget that Systrace is an amazingly powerful tool that lets you visualize how work is flowing through the threads in your application. It's a great way to validate that things are working as intended and also see all the other crazy threads that are being worked on by other parts of your app. And that's the trick with performance, isn't it? I mean, you can make assumptions, but things don't always work the way you think, which is why you need to check out the rest of the Android Performance Patterns videos, and don't forget to join our Google Plus community to ask a lot of hard threading questions as well. So keep calm, profile your code, and always remember, perf matters.
Hey folks, welcome to Totally Tooling Tips Season 3.
Come check us out. We're going to be talking about progressive web apps, some of the tooling around them.
On first visit, we've got a relatively fast time to first meaningful paint. Module bundling, accessibility. Do you know what the top 4 things to look at when it comes to web accessibility are?
No, I can only think of 2. I only think of audio and then visual.
So there's visual, hearing, mobility, and cognition.
The first episode will be out on April the 27th. So subscribe to the YouTube channel, check out Season 1 and 2 before Season 3 starts, which will be happening soon.
We promise that Season 3 is going to be equally as mediocre as Seasons 1 and 2.
Welcome to the Googleplex. This is an incredible place with lots of great stuff being worked on every single day. Before I worked here, I always wondered what it would be like to come to the Googleplex, meet up with a Googler, and have coffee with them, and just chat about what they do, how they do it, and why they do it. And today we're going to do exactly that.
Welcome to this episode of Coffee with a Googler, and if you, like me, love games and love 3D games and all that kind of stuff, then this show should be a treat for you. Because today I'm chatting with Shannon Woods, who's a technical program manager, and she works on our rendering teams at Google, and she's got lots of great stuff to talk about in the 3D space. So welcome, Shannon. How are you?
I'm doing all right. How are you?
Really good. I have to say I'm really envious of your job, but could you tell us what you do?
So I work with a couple of rendering teams here at Google, both Android and Chrome. And we sort of plumb code from user space down to your GPU.
Wow. Can you translate that?
Basically, our job is to get a bunch of triangles from applications down to the GPU as fast as possible.
Cool. And all graphics are ultimately made up of triangles, right?
Basically.
Now, recently you announced Vulkan. Right, and this is this like new and improved 3D rendering API. Could you tell us a bit about it?
Historically, Android and all mobile phones really have used OpenGL ES to communicate to the GPU within the phone to tell it how to draw scenes. But unfortunately, over time, the API has become less and less of a good match for what the hardware is actually doing beneath. So what would happen is you would use this API to communicate a lot of the details about your scene, and the GPU has to reorganize all of that so that it can consume it efficiently and draw it on the screen. So what Vulkan is it's another API from the same open standards group that makes OpenGL. And it's designed to be a lot closer to what the hardware actually does beneath the covers.
Okay.
So if you provide the data via Vulkan, it should be able to draw a lot quicker. Sort of the flip side of that is that it gives you all of this control, but it means that you have to be pretty good at making sure that your code is doing exactly what you wanted it to do.
Vulkan and OpenGL ES are both from the same standards body, right?
Yes.
So that's Khronos?
Yes, Khronos.
Khronos, sorry. So you work with the standards body at Khronos?
I do. I get to travel all around the world and see beautiful conference rooms. But it's actually really interesting getting to see how the API is made from the ground up.
Cool.
Android is going to support both OpenGL ES and Vulkan. So developers can choose which API is right for what they're doing. Like if they need to render a FPS game or first-person shooting game that has to run really fast at a high frame rate, then they're going to probably want to choose Vulkan so that they can closely control exactly what's being drawn and when.
Cool.
But if they just want to get a couple of shapes on screen, then OpenGL ES is probably still the right choice for them.
Cool. So it's just really nice to have both.
Yes.
Cool. So, and from my understanding, what you're saying with Vulkan, like just being able to get down to the chipset level effectively allows you to squeeze a lot more performance out of the machine.
Yeah, it does. And one of the other things that it does is that it allows for greater parallelization.
Okay.
There's a lot of work in OpenGL ES that it's blocking work. You make a call into OpenGL ES, into the driver code, and it has to stop and perform the task that you asked it to do, and doesn't return control to the application until it finishes that task. And what this means is that if you have multiple threads, only one of them can really be talking to the driver doing these things at the same time. Vulkan is designed more for multi-threaded applications, so you can have multiple threads doing things like constructing buffers full of commands at the same time.
You're getting onto like programming and skills, and like from a skills perspective, and is the things that developers will need to learn that they don't do already, for example, if they're doing 3D games in OpenGL ES?
So the skill sets are going to be largely the same. As a Vulkan developer, you're going to have probably a tighter handle on things like synchronization, careful tracking of memory allocation, because a lot less of that is going to be done for you by the driver. The upside of this is that the driver won't be doing these things when you don't expect it to. But you're going to have to really hone your skills at things like multi-threaded synchronization, memory allocation. Make sure that you are closely keeping an eye on what your code is doing and what it's asking the GPU to do, because the driver is going to do a whole lot less of that for you. It's not going to clean up after you. It's not going to check that you are making legal calls. So you're basically going to have to be a bit of a ninja.
It's almost like driving stick versus driving manual, right?
That's probably a really good analogy.
So people can learn about Vulkan on the Khronos site?
Yes.
You mentioned. So that's Khronos.org?
Khronos.org, www.khronos.org. And Khronos is spelled Khronos. And they have a Vulkan landing page where you can find the latest news about Vulkan and also see some of the presentations that were given, for example, at SIGGRAPH this year and at GDC about the shape of the API.
Okay. Now you were at SIGGRAPH, right?
I was at SIGGRAPH.
How did it go?
It was a lot of fun, actually. We did some demos, showed some spinning teapots.
Teapots?
So there's a little bit of history behind the teapot. The teapot is canonically called the Utah teapot, and it's because way back in the history of computer graphics, it's one of the first models that was digitized and shared. And interestingly, so the teapot, everybody knows that they've seen here and there over the years, it looks short and squat. But the reason for that is actually that on the original display system, the pixels were not square. So they had a different
ones from
TVs. The aspect ratio is a little bit different. So in real life, the teapot's actually a little taller.
Now you're saying that the pixels are like elongated, they were rectangular pixels, because this was done so long ago?
Oh yeah, it was, oh gosh, I guess it was the 70s.
Wow. So the first 3D model that was formed in cyberspace or whatever you want to call it back in the 70s, and you're still using the same model today to... I think Pixar also used the teapot, don't they?
Yeah, actually the teapot appears in every Pixar film. One of the ones I know off the top of my head is they use it in the Tea Party scene in Toy Story.
Okay, naturally that's where a teapot would fit.
Yeah, but there's one in every Pixar film.
Thank you so much, Shannon.
Thank you.
And thanks everybody for watching this episode of Coffee with a Googler. I don't know about you, but I've learned a lot about the kind of things that can be done with 3D graphics. And I'm really, really excited about Vulkan coming to Android. If you've got any questions for me, or if you've got any questions for Shannon, just please leave them in the comments below. We'll also link to the websites in the description of this video so that you can follow those links. And if you want to learn anything else about great stuff that Google has to offer for Android developers, Chrome developers, and everybody else, please subscribe to the Google Developers channel. Thank you.
With Android Lollipop, Material Design changed the way that apps look and feel to create more magic moments. But devices running earlier versions of Android don't have all of the same options. I'm Joanna Smith, and one of the coolest things that Material Design gave us were toolbars, which are now even more magical because they're backwards compatible as well. A toolbar is a view that is richer and more flexible than the traditional action bar. In fact, toolbars are part of your view hierarchy, so they can be animated or even react to scroll events. Because it's a view, you can use the toolbar as a standalone element anywhere in your app, providing the user with options and controls that don't need to span the entire layout width at the very top of the screen. You can even have multiple toolbars if the structure depends on the content of your layout, or if you're providing the user with many differing controls. To populate your toolbar with actions and options, you can inflate a menu onto the toolbar to display those actions to the user. You can also create your own controls, like adding a navigation button to go up to the parent activity. While toolbars can be used in any part of your layout, you can also choose to use the toolbar instead of the action bar whenever you simply want more control over the appearance and functionality of that action bar. So to use a toolbar in the place of the standard action bar, you first need to disable the action bar. The easiest way to do this is to have your theme extend from Theme AppCompat No Action Bar, or its light variant. Then create your toolbar the way you would create any other layout in your app, and call setActionBar to designate it as the action bar in the activity or fragment. By calling this method, the system will add the standard action bar options for you, so you don't need to inflate a menu. Now, you may be convinced of how awesome toolbars are, but how can you use them in versions of your app targeting older SDKs? Well, toolbars were added to the support library for AppCompat v21, so now it's as easy as calling setSupportActionBar instead of setActionBar to replace action bars on older devices. So check the documentation for all of the support options available so that you can bring more magic moments to your users. And for more tips on making sure that your app is at its best, check out the rest of our Android Development Patterns content or consider joining our G+ community. But most importantly, just continue to build better apps.
As a lot of developers know, there's more to having an app succeed than just building a great app. You want your app to be dynamic and responsive by delivering fresh content to users and quickly reacting to their changing needs. You want to test out major decisions to make sure you're doing the right thing before you push them to your entire audience. And ideally, you want to provide a tailored experience for each user, so your VIPs feel like, well, VIPs. But let's be honest, that can be a lot of work. And if you're a developer without a ton of resources, that's time you'd rather spend on other things, like building your app. That's where Firebase Remote Config comes in. Firebase Remote Config is a simple key value store that lives in the cloud. But don't let that simplicity fool you. Because it lives in the cloud, it means you're able to deploy changes that your app can read within a matter of minutes. For instance, say you've just pushed your app out to the world and you suddenly discover that your Swedish text contains some offensive language. How are you supposed to know? You don't speak Swedish. I don't blame you. But fixing that text the old-fashioned way would mean creating a new build and going through the entire publishing process again. That's something that could take days, which is an awfully long time to have 9.2 million people cursing your name. But if your app uses Firebase Remote Config, you could change that text in the cloud through the Firebase console. Kind of like this. The next time your users fire up their app, Remote Config will grab the latest values, update your app's text, and just like that, you've averted a major international crisis. Or, let's say you've got a puzzle game and you're hearing complaints from your players that level 5 is too hard. If you've configured your app using Remote Config, you could tweak those settings to give your players a few more turns and push out that change to the world. But hang on, are you sure that's the right thing to do? What if the silent majority of your users actually enjoy the challenge of a more difficult level? And by making it easier, you're going to turn away your most hardcore and potentially highest paying customers. How could you test whether or not this change is a good one? Sounds like you need an A/B test. That's where Remote Config's audience segmentation feature comes in. This allows you to deliver different configurations to different groups of users simultaneously. So you can try out your new level settings with half your users while keeping the old settings with the other half. But audience segmentation isn't just great for A/B testing. Maybe you've got a feature change that could have a major impact on your in-app economy. Or maybe you just want to double check that some new networking code isn't going to set your servers on fire. You can use Firebase Remote Config to gradually roll out these changes, trying them first with a small percentage of your users before pushing them out to your entire audience. Remote Config can also deliver different configuration sets to your users based on all sorts of different factors, from device type or locale to any audience segment you've defined in Firebase Analytics. So you can send out one welcome message to your New Zealand customers and another to your Australian ones, or only show your Review This App button to people who use your app every day, or you can change your home screen experience for your customers who have spent large amounts of money on in-app purchases, so they feel special. Remote Config is backed by a client library on iOS and Android that handles important tasks like caching, dealing with flaky connections, and keeping network requests lightweight, which is always a good thing. To give Remote Config a try, check out our documentation here. We can't wait to see what you build.
Here's an old school tip for you. If you can animate something based on user input, you probably don't want to have it update immediately to track the input event, because it can often feel very jittery. Instead, what you should do is use the oldest easing equation in the book, which looks like this: value plus equals target minus value all over strength. Here we're changing the value based on how close it is to the target. The closer it is, the less it gets moved, making it look way nicer. So there you have it, a little tip to make your input-based animations a teeny bit smoother.
Another day, another journey.
I know indeed, right? How's your aim?
Well, not great in the middle of the night, but I sometimes just sit down.
No, actually, I meant your snooker, your pool, or in this case, your billiards.
Ooh, we're going to a billiard hall.
That we are, sir.
So, I made a thing.
That's unusual for you.
I know.
You're like
quite proud
two
of
in as
myself.
many months or something.
Yeah, it's a new thing. It's
What is
really,
it?
It's a little
Is it a web
Wikipedia.
app?
Yes, it is a web app.
Is it a website? What's the difference, Jake?
Shut up. We're not doing web apps versus websites. I would say it's an app.
Would you?
I
An app with content?
Flipped a coin. It's an app. No, it's not. It's a site.
Mm.
It's a Wikipedia article viewer.
Okay.
Which I realise is what Wikipedia does already.
Yes.
But this was more of an exercise in looking at like performance, like page load time performance.
But you think you can beat Wikipedia at a server-side render, do you?
I did.
You did?
Well, so this is the thing. I was hosting on GitHub, so I was doing a client-side render. I know.
After all you said.
It seemed like a nice, simple way to get into it, and I was serving it just JavaScript down the wire, then JavaScript's getting the content and putting it on the page, and I was seeing, you're looking at my official figures, 2.6 seconds for first render, and 4.7 seconds for content, which even at that point was faster than Wikipedia's actual official site.
Oh.
But I knew it could be better than that.
Okay. What was in that first render?
First render was just like the top toolbar that said like Wikipedia and a spinner.
Okay, but from a user's point of view, they've got something, they know they're on the way. Okay.
Yeah, and then I think it was 4.7 seconds till the actual Wikipedia article came down.
So you've actually got a good couple of seconds there where you're spinning up, where like your app doesn't seem to be like it's idle essentially.
Yeah, I know you're pulling your sad face, but don't worry, that's not the end
I'm pulling
of the
a mulling
story.
face. I'm mulling over.
Okay, well, pulling your mulling face, I can tell you what I did to fix it. There's a happy.
Better than my other faces.
You okay? You're having a stroke. So yeah, I made the JavaScript async.
Okay.
And put some markup on the page for that first render.
Yes.
And I inlined the CSS for that first render.
Good.
Normal.
Yeah. All normal.
Well, you say normal. When I first heard that rule, it was like, take some of your CSS out and put it in the head. I was like, that's a big ask for developers, really.
Whoa, big what? You said big ask.
Yeah, okay.
He keeps saying, It's a request, pal.
Yeah,
That's what it
I
is.
know. Oh my God, I hate
You
it when
become
people,
that person. You become
when
that
people
person.
say that.
Yeah. Next up, you'll be asking to reason about things, or using modulo.
To reason about, I hate that one, because it is just developers not wanting to say they don't understand.
I actually do like modulo, but...
So, I do agree that it's too hard to async load CSS. This is something that we have a problem with on the platform,
Yes,
right?
I actually tried it. It's rubbish.
Yeah, we've got load CSS from the Filament group, but it's more script than you should need. It should just be async on the link element.
It should be declarative. Yeah.
But moreover, I think what Firefox and IE do at the moment is actually really good. It's a bit of non-standard behavior, but I really like it. Put the link element on the page, in the body, just before the content that needs it. And it will block the rendering, wait for it, it'll block the rendering of the subsequent content until that CSS loads. It's not blocking all page rendering.
Okay.
It's just the elements after don't go into the render tree.
Okay, fair enough.
We should do that.
Yes.
We should take that on. And we should also have async as well.
Okay, so here
yeah,
we
where
are.
am I? Okay,
We had a
I'm gonna get
parallelizable thing, last I understood, of where you had the JavaScript that went off to get the Wikipedia page, and I was saying that's bonkers.
And so, yes, I came to the same conclusion. I thought, this needs server rendering.
Wise man.
Yep, thank you. Let's do a
Cheers
to server rendering.
Well, this is the nerdiest chair that ever went up.
So, like, looking at my calculations, once I introduced server rendering, things got slower.
Right.
That's
a bit annoying.
My content render actually sort of came down a little bit, not much, but my first render skyrocketed.
Why?
It was slower because connection goes off to my server.
Yes.
My server goes off to Wikipedia, gets the data, comes back, constructs the page, sends it on. You're looking at a white screen for longer now because you've got the bottleneck of your third-party service. But it was by taking that just the JavaScript CSS, the basic page shell, down to 0.1 seconds, like as good as instant for that first render because it's all offline. But here's an interesting thing that happened is my content render went, because I'm now back to doing client-side rendering.
Yeah.
Content render's gone up again. Because even though it's coming from the cache, there was two problems. There's one that it was the request to Wikipedia is a little bit delayed because it has to parse the JavaScript
to Wikipedia.
To Wikipedia.
It's delayed. I like that. It's almost like a...
I didn't do that on purpose.
Really?
But yeah, so I cut that delay by as soon as the request went to the service worker, had the service worker go off and fetch the stuff for Wikipedia.
Oh, okay. So how do you then? Because you still want to send your response back with the app shell stuff.
Yep. What you're talking about there is chunked encoding.
Ah, okay.
So this is the art of being able to being able to quickly send data back without knowing your whole page content. So I was able to send back like the header and the first render stuff essentially. So now the browser knows about the extra CSS and JavaScript it needs. Meanwhile, or like at the first possible opportunity, my server's gone off to Wikipedia and it's gathering that. And then as it arrives, it just streams it through, and that slashed the rendering time. We got down to so we were at 1.4 seconds for first render, and when I get the official figures up, so that was down to 2.4 seconds for the content, and that's like a 2-second saving compared to JavaScript.
That's good.
3G. Yeah, it's pretty huge. And
you can't really get any better than that, can you?
Oh, you can, sir, by using a little technology you might not have heard of before. Service worker!
Yay!
But yeah, as soon as you take the content, the page shell offline, that's it. You can get to that first render in like 0.1 seconds. Like the measurement came out, but it's instant, really.
Yeah.
But it took 9K of the content down the wire, and once I had that, wrote it to the page, and then wrote again once I had the rest. And it was a total hack to do that. And this is why my next wish for the internet, for the web standard, is streams. Because I want to be able to just take some content that we're downloading, pipe it into an element, and it appears as it. And I think once we have that, that kind of rendering as it goes along, I think that's when we can see client-side rendering apps become competitive with server-rendered apps.
We'll drink to that.
Cheers.
Hello, I'm Timothy Jordan, and you're watching the Google I/O 2016 livestream. The keynote is over, but there are many more developer sessions to come. Stay tuned on all 4 livestream channels throughout the next 3 days. We'll also be on the ground and behind the scenes finding the coolest and most innovative things to share with you right here on the livestream between sessions. Oh, and if you want us to track someone down with your question, use the hashtag AskDevShow.
Right, here we go. Mr. Lewis, how do you feel about roller coasters?
Oh, I like them. Roller coaster of love. Let's roll.
So, I've got a bone to pick with you.
Oh, that's unusual.
So
we normally get on just fine.
Well, because I've been watching you.
No,
and,
that's a bit weird.
I've noticed that you've been engaging in some degree of Babel activity.
Oh,
You've
thank
been
goodness
using
for
a bit
that.
of the ES6, ES7.
Not quite as terrifying as I thought it might have been this.
But you're the kind of person who says, and I've heard you say this, that you don't like writing code that isn't the code that ends up being executed in the browser.
Correct.
Like
Can't
you
stand
don't
it.
like
Don't
those
like
little middle steps. You're kind of anti-transpiler.
I am sort of anti-transparent. I want to feel like the code I write is the code that runs,
Right.
and I'm happy for a little bit of wool to be pulled over my eyes, but I want to feel like I can back out of it. So I don't think that's changed. I think for me, when I look at something like Babel, or Babelify or any of that, one thing is I feel like I could switch it out for Tracer, or I could switch it out for something else.
Because it's an open standard. I guess there are independent implementations of that standard.
Exactly. And
Okay, yeah, that's fair
so it's like it feels like this is the JavaScript I'm going to be writing, right? So a while from now. So if it's like if it's going to get me there, then that's fine. Like I'm okay with that. And then the other thing is, if you look at the ES5 that it generates, it's like it makes sense. It's fine. And I feel like when you look at some other things, whether that I don't know, CoffeeScript or TypeScript, something like that, you can never say that because it's like you're always going to be transpiling across.
Yeah, I had this issue actually. I was using a project, npm installing something, using it, and there was a bug, and I thought, as a citizen of the internet, I am going to do a pull request. I'm going to try and fix that. And and when I got onto GitHub and click, CoffeeScript.
Oh,
I was like,
okay,
well,
yeah, no. Bye-bye.
Now step one of making this fix is learn CoffeeScript.
Yeah, and it's like unless I really, really care about fixing the bug, it's not. For me, it's like JavaScript become ES6, ES7, ES whatever. But like you say, this kind of let's learn TypeScript or CoffeeScript or anything else. It's just like I've got to really want to go off and do that for some reason, and I don't see what that reason is because JavaScript for me for everything is fine. I actually really liked Babel, if for no other reason than its source maps were just super. So even though I wasn't really sort of aiming for that, when I did get an error, it was like whatever .js line whatever, and it was like that is the correct line. And
well, so even if you're not using source maps with Babel, the output is actually pretty sensible for the most part.
Yes.
But as you say, source maps just make it completely transparent. It's almost like you're not using a transpiler at all.
Exactly. So I'm happy with the illusion of it. I think that's probably what it comes down to. But as I say, you're right. If you look at the actual code it generates, for me, I was just like, that's not necessarily code I'd write, but that's okay. It's just about manageable and readable.
So go on then. What are your big hitters in ES6 and 7 world? What's your favies?
My faves.
Your faves.
Contentious one would be classes. I actually really like classes because people are like, "What's wrong with the prototype? You're turning your back on prototype."
You're still using a prototype. It's just sugar.
Yes, exactly.
Yeah.
But nice sugar at that. Very nice.
Yeah, because I don't know. I always mess it
refined
up.
sugar.
Like if I'm doing like something.prototype equals object.create the thing I'm extending, and I keep forgetting the .prototype on the end there.
But that's one of about
It's
11
really difficult. It's really awkward compared to class thing extend thing.
And that's the one way you do it in ES6. Like with the ES5, you've got 11 billion ways of doing it, and not all of them are good necessarily, or readable, or what you want to see if you're looking at your own code 6 months from now or somebody else's code. So it kind of felt like it was more like the code I want to write, more like the code I want to read. It's where we're going. It's a feature. It's not like somebody just went off piste and did something that they wanted to do.
And I can barely remember how to spell function now. Because you can within an object, it's just the name, brackets, off you go. There's arrow.
Fat arrow function was something else I really liked.
Yep, we love a bit of fat arrow.
Yeah, because a number of times I use request animation frame, set timeout, set interval, something like that, and it's
Yep.
like, oh, all of a sudden I'm on the window scope, am I? Great, thanks for that. So bind, it's like, don't worry. I don't mind bind. It's better than var that equals this for me.
I don't.
You don't like that.
No, I don't do that equals this. But I will give it a specific proper variable name,
Like what?
based on the name of the class.
Like Jakey this, var Jakey this equals.
So if it's class vehicle, inside that I will do var vehicle equals this, like lowercase vehicle equals this, and it's yeah, but it makes sense then. I don't like that because it's like, well, that's just as because this is a problem in JavaScript, I think.
Yes.
Like so this what? Like, yeah. And that's what one of the things that arrow functions solve is there tends to only be one option for what the this is, and it's the instance name.
Yeah.
Which that makes way more sense.
So it works for me. I really like that.
Destructuring I like.
Beautiful.
Especially for option objects.
Yes.
At the end of a
with defaults,
function.
right?
This is it. It becomes self-documenting. You can say, right, this is optional, but inside this object, here are the properties that I'm looking for, and here are their defaults.
Yep. But in any case, I feel like, going back to your original question, it's like the reason I would use a transpiler today is an if and only if it lets me experience the future now, get used to like the future now. I think it's where we're going.
Which you get with source maps. It feels like you can almost ignore the transpilers there.
Yeah, exactly. And as I say, the code that it generates makes sense to me. So I'm all up for that.
Yay for transpilers.
Yay.
Cheers. We need beers.
All right, well, it's getting pretty late. I think that was a pretty good take, so let's just do one more and then we'll be out for the day. Okay, Rob?
All right.
3, 2.
Otherwise, as
Hey,
always,
Rob.
Oh, hey, what's up, David?
Did I tell you that I got my own YouTube show?
Oh no, dude, that's awesome. What's it gonna be about?
So, like, I was thinking there's, not a lot of screencast content out there, and so I'm gonna go and make a bunch of screencasts on Firebase.
Well, that's sort of exactly what we're doing here for Polycast, a show about.
It's nothing like that, really. Like I said, my show is gonna be on Firebase. Like building real-time cross-platform apps, without any server code.
Well, I have all this equipment, I have this crew, so if you want, I can show you the ropes
So I was thinking
sometimes.
of calling
like how we
it
put the
Firecasts. The Firebase, is for the fire.
Yeah, the Firebase, yeah.
And, like the cast comes from screencast.
Screencasting.
Yeah.
Yes.
What do you think?
Six lines of code is all it takes to write your first machine learning program. My name's Josh Gordon, and today I'll walk you through writing Hello World for machine learning. In the first few episodes of this series, we'll teach you how to get started with machine learning from scratch. To do that, we'll work with two open source libraries, scikit-learn and TensorFlow. We'll see scikit in action in a minute, but first let's talk quickly about what machine learning is and why it's important. You can think of machine learning as a subfield of artificial intelligence. Early AI programs typically excelled at just one thing. For example, Deep Blue could play chess at a championship level, but that's all it could do. Today we want to write one program that can solve many problems without needing to be rewritten. AlphaGo is a great example of that. As we speak, it's competing in the World Go Championship, but similar software can also learn to play Atari games. Machine learning is what makes that possible. It's the study of algorithms that learn from examples and experience instead of relying on hard-coded rules. So that's the state of the art, but here's a much simpler example we'll start coding up today. I'll give you a problem that sounds easy, but is impossible to solve without machine learning. Can you write code to tell the difference between an apple and an orange? Imagine I asked you to write a program that takes an image file as input, does some analysis, and outputs the type of fruit. How can you solve this? You'd have to start by writing lots of manual rules. For example, you could write code to count how many orange pixels there are and compare that to the number of green ones. The ratio should give you a hint about the type of fruit. That works fine for simple images like these, but as you dive deeper into the problem, you'll find the real world is messy, and the rules you write start to break. How would you write code to handle black and white photos? Or images with no apples or oranges in them at all? In fact, for just about any rule you write, I can find an image where it won't work. You'd need to write tons of rules, and that's just to tell the difference between apples and oranges. If I gave you a new problem, you'd need to start all over again. Clearly, we need something better. To solve this, we need an algorithm that can figure out the rules for us so we don't have to write them by hand. And for that, we're going to train a classifier. For now, you can think of a classifier as a function. It takes some data as input and assigns a label to it as output. For example, I could have a picture and I want to classify it as an apple or an orange. Or I could have an email and I want to classify it as spam or not spam. The technique to write the classifier automatically is called supervised learning. It begins with examples of the problem you want to solve. To code this up, we'll work with scikit-learn. Here, I'll download and install the library. There are a couple different ways to do that, but for me, the easiest has been to use Anaconda. This makes it easy to get all the dependencies set up and works well cross-platform. With the magic of video, I'll fast forward through downloading and installing it. Once it's installed, you can test that everything is working properly by starting a Python script and importing sklearn. Assuming that worked, that's line 1 of our program down, 5 to go. To use supervised learning, we'll follow a recipe with a few standard steps. Step 1 is to collect training data. These are examples of the problem we want to solve. For our problem, we're going to write a function to classify a piece of fruit. For starters, it will take a description of the fruit as input and predict whether it's an apple or orange as output, based on features like its weight and texture. To collect our training data, imagine we head out to an orchard. We'll look at different apples and oranges and write down measurements that describe them in a table. In machine learning, these measurements are called features. To keep things simple, here we've used just 2, how much each fruit weighs in grams and its texture, which can be bumpy or smooth. A good feature makes it easy to discriminate between different types of fruit. Each row in our training data is an example. It describes one piece of fruit. The last column is called the label. It identifies what type of fruit is in each row, and there are just 2 possibilities, apples and oranges. The whole table is our training data. Think of these as all the examples we want the classifier to learn from. The more training data you have, the better a classifier you can create. Now let's write down our training data in code. We'll use 2 variables, features and labels. Features contains the first 2 columns, and labels contains the last. You can think of features as the input to the classifier, and labels as the output we want. I'm going to change the variable type of all our features to ints instead of strings. So I'll use 0 for bumpy and 1 for smooth. I'll do the same for our labels, so I'll use 0 for apple and 1 for orange. These are lines 2 and 3 in our program. Step 2 in our recipe is to use these examples to train a classifier. The type of classifier we'll start with is called a decision tree. We'll dive into the details of how these work in a future episode, but for now it's okay to think of a classifier as a box of rules. That's because there are many different types of classifier, but the input and output type is always the same. I'm going to import the tree, then on line 4 of our script we'll create the classifier. At this point, it's just an empty box of rules. It doesn't know anything about apples and oranges yet. To train it, we'll need a learning algorithm. If a classifier is a box of rules, then you can think of the learning algorithm as the procedure that creates them. It does that by finding patterns in your training data. For example, it might notice oranges tend to weigh more, so it'll create a rule saying that the heavier a fruit is, the more likely it is to be an orange. In scikit, the training algorithm is included in the classifier object, and it's called fit. You can think of fit as being a synonym for find patterns in data. We'll get into the details of how this happens under the hood in a future episode. At this point, we have a trained classifier, so let's take it for a spin and use it to classify a new fruit. The input to the classifier is the features for our new example. Let's say the fruit we want to classify is 150 grams and bumpy. The output will be a 0 if it's an apple or 1 if it's an orange. Before we hit enter and see what the classifier predicts, let's think for a sec. If you had to guess, what would you say the output should be? To figure that out, compare this fruit to our training data. It looks like it's similar to an orange because it's heavy and bumpy. That's what I'd guess anyway, and if we hit enter, it's what our classifier predicts as well. If everything worked for you, then that's it for your first machine learning program. You can create a new classifier for a new problem just by changing the training data. That makes this approach far more reusable than writing new rules for each problem. Now you might be wondering why we described our fruit using a table of features instead of using pictures of the fruit as training data. Well, you can use pictures, and we'll get to that in a future episode, but as you'll see later on, the way we did it here is more general. The neat thing is that programming with machine learning isn't hard, but to get it right, you need to understand a few important concepts. I'll start walking you through those in the next few episodes. Thanks very much for watching, and I'll see you then.
Developing a successful app isn't easy. To reach a broad audience, you'll need to consider your iOS, Android, and mobile web users. And to build for these platforms, you'll need a backend server to store data and support the apps. Of course, you want to get your users logged in, hopefully lots of users, which means your backend will have to scale. Then after you've solved your scaling problems, you'll have to find more ways to spread the word to get new users. But have you found a way to measure all this activity? And oh no, your app is crashing and causing servers to melt down, and you haven't even made a dime yet. Don't you wish this could be easier? This is why we built Firebase. It has all the tools you need to build a successful app. It helps you reach new users, keep them engaged, scale up to meet that demand, in addition to getting paid. From the beginning, with Firebase, you'll have test lab and crash reporting to prevent and diagnose errors in your app. Your backend infrastructure problems are solved with our real-time database, file storage, and hosting solutions. Acquiring new users is easy with invites, AdWords, and dynamic links. And using the authentication component, you can get those users logged in with minimal friction. Once installed, you can keep your users engaged with notifications, cloud messaging, and app indexing. Then, with Remote Config, you'll have the freedom to experiment with new features and optimize the user experience in real time. And of course, you can earn money with the same AdMob component that's been monetizing great apps for years. Last, but certainly not least, our all-new Analytics component, designed uniquely for Firebase, brings insight into how well these components are working for you and your users. With Firebase Analytics, you can measure and optimize your advertising campaigns, discover who are your most valuable users, and understand exactly how they are using your app. Now, all these components work great on their own and provide a solid infrastructure to build out your app, but they work even better when combined in creative ways. So let Firebase handle the details of your app's backend infrastructure, user engagement, and monetization, while you spend more time building the apps your users will love. To get started right now with Firebase on Android, iOS, or the web, follow these links for more information. Then, to manage and monitor your apps connected to Firebase, there's a web console to view crashes, set up experiments, track analytics, and a whole lot more. And to learn more about Firebase and all of its components, you can read the documentation right here. We can't wait to see what you build.
Let's be honest, you're an awesome engineer with an awesome app and you are using threading to the max. Sadly though, managing all those individual threads and assigning work between them is causing you to lose your hair. My name is Colt McCandless, and please, don't join the Bald Club. Instead, use the Thread Pools class, which is an ideal primitive for breaking up lots of work into little buckets. See, historically, it was commonplace that applications would use a dedicated thread model. That is, one thread that only deals with database rights, while a separate thread only handles streaming of music, and a third one only handles networking. These setups are okay because the amount of work per thread isn't that large, and it's okay to handle this work in sequential order. But there reaches a point where this model starts to fall over. Say, for example, that you've got 40 bitmaps to decode, and each decode takes like 4 milliseconds or something. Putting all of this work on a single dedicated thread is a bad idea, since it'll take 80 milliseconds total to get all that work done in a sequential fashion. On the other hand, if you created 10 threads and let each one decode 4 bitmaps, then you'd end up only taking 16 milliseconds total. But then, of course, you run into the problem of how to properly pass the work around between those threads, schedule that work, and then managing of those threads. Before you start stressing out about writing all that code, don't worry. This is exactly what Thread Pool Executor primitive is for. Basically, this class will just let you spin up a number of threads and toss blocks of work to execute on it. Thread Pool Executor handles all of the heavy lifting of spinning up the threads, load balancing work across those threads, and even killing those threads when they have been idle for a while. Basically, it handles all the heavy lifting of super parallel processing on your behalf. All you have to do is split up the work. But there's a small caveat here. How many threads should your thread pool have? I mean, technically speaking, you have the ability to create as many threads as you want, but that's not ideal. See, CPUs can only execute a certain number of threads in parallel. Once you get above that number, then the CPU has to start deciding which threads get the next free block of processor time based on how important they are. Which means that if you keep eventually adding threads, you'll hit a break-even point where your computation isn't getting any faster, even though the number of threads that you have has increased significantly. And it's also important to note that each of these threads aren't free. Each thread costs you about 64K of memory in minimum, and that adds up quickly, especially in situations where the call stacks can start growing pretty large. As such, your app needs to find a sweet spot between the number of cores and the point of diminishing return with the number of threads. Thankfully, once again, the Thread Pool Executor class has got you covered. When creating your thread pool, you can specify the number of initial threads and the number of maximum threads. As the workload in the thread pool changes, it'll scale the number of alive threads to match. Oh, and a quick note, the value returned from get available processors may not reflect the number of physical cores in the device. See, some devices have CPUs that will deactivate one or more cores depending on the system load to save battery. So if your device has 2 CPUs but one of them is asleep, this value could return 1. And of course, thread pools won't solve all of your threading problems. As mentioned earlier, unless you're dealing with lots and lots of work packets all the time, this thing's kind of overkill. It's best to use things like handler threads or async task loaders for specific types of work blocks and only throw the massive computing problems at the thread pool. And for you power users out there, remember that RenderScript might be a better alternative to large-scale parallel work on Android devices, but that's a whole separate set of videos that we haven't gotten into yet. And don't forget that Systrace is an amazingly powerful tool that lets you visualize how work is flowing through the threads in your application. It's a great way to validate that things are working as intended and also see all the other crazy threads that are being worked on by other parts of your app. And that's the trick with performance, isn't it? I mean, you can make assumptions, but things don't always work the way you think, which is why you need to check out the rest of the Android Performance Patterns videos, and don't forget to join our Google Plus community to ask a lot of hard threading questions as well. So keep calm, profile your code, and always remember, perf matters.
Hey folks, welcome to Totally Tooling Tips Season 3.
Come check us out. We're going to be talking about progressive web apps, some of the tooling around them.
On first visit, we've got a relatively fast time to first meaningful paint. Module bundling, accessibility. Do you know what the top 4 things to look at when it comes to web accessibility are?
No, I can only think of 2. I only think of audio and then visual.
So there's visual, hearing, mobility, and cognition.
The first episode will be out on April the 27th. So subscribe to the YouTube channel, check out Season 1 and 2 before Season 3 starts, which will be happening soon.
We promise that Season 3 is going to be equally as mediocre as Seasons 1 and 2.
Welcome to the Googleplex. This is an incredible place with lots of great stuff being worked on every single day. Before I worked here, I always wondered what it would be like to come to the Googleplex, meet up with a Googler, and have coffee with them, and just chat about what they do, how they do it, and why they do it. And today we're going to do exactly that.
Welcome to this episode of Coffee with a Googler, and if you, like me, love games and love 3D games and all that kind of stuff, then this show should be a treat for you. Because today I'm chatting with Shannon Woods, who's a technical program manager, and she works on our rendering teams at Google, and she's got lots of great stuff to talk about in the 3D space. So welcome, Shannon. How are you?
I'm doing all right. How are you?
Really good. I have to say I'm really envious of your job, but could you tell us what you do?
So I work with a couple of rendering teams here at Google, both Android and Chrome. And we sort of plumb code from user space down to your GPU.
Wow. Can you translate that?
Basically, our job is to get a bunch of triangles from applications down to the GPU as fast as possible.
Cool. And all graphics are ultimately made up of triangles, right?
Basically.
Now, recently you announced Vulkan. Right, and this is this like new and improved 3D rendering API. Could you tell us a bit about it?
Historically, Android and all mobile phones really have used OpenGL ES to communicate to the GPU within the phone to tell it how to draw scenes. But unfortunately, over time, the API has become less and less of a good match for what the hardware is actually doing beneath. So what would happen is you would use this API to communicate a lot of the details about your scene, and the GPU has to reorganize all of that so that it can consume it efficiently and draw it on the screen. So what Vulkan is it's another API from the same open standards group that makes OpenGL. And it's designed to be a lot closer to what the hardware actually does beneath the covers.
Okay.
So if you provide the data via Vulkan, it should be able to draw a lot quicker. Sort of the flip side of that is that, you know, it gives you all of this control, but it means that you have to be pretty good at, making sure that your code is doing exactly what you wanted it to do.
Vulkan and OpenGL ES are both from the same standards body, right?
Yes.
So that's Khronos?
Yes, Khronos.
Khronos, sorry. So you work with the standards body at Khronos?
I do. I get to travel all around the world and see beautiful conference rooms. But it's actually really interesting getting to see how the API is made from the ground up.
Cool.
Android is going to support both OpenGL ES and Vulkan. So developers can choose which API is right for what they're doing. Like if they need to render a FPS game or first-person shooting game that has to run really fast at a high frame rate, then they're going to probably want to choose Vulkan so that they can closely control exactly what's being drawn and when.
Cool.
But if they just want to get a couple of shapes on screen, then OpenGL ES is probably still the right choice for them.
Cool, cool. So it's just really nice to have both.
Yes.
Cool. So, and from my understanding, what you're saying with Vulkan, like just being able to get down to the chipset level effectively allows you to squeeze a lot more performance out of the machine.
Yeah, it does. And one of the other things that it does is that it allows for greater parallelization.
Okay.
There's a lot of work in OpenGL ES that it's blocking work. You make a call into OpenGL ES, into the driver code, and it has to stop and perform the task that you asked it to do, and doesn't return control to the application until it finishes that task. And what this means is that if you have multiple threads, only one of them can really be talking to the driver doing these things at the same time. Vulkan is designed more for multi-threaded applications, so you can have multiple threads doing things like constructing buffers full of commands at the same time.
You're getting onto like programming and skills, and like from a skills perspective, and is the things that developers will need to learn that they don't do already, for example, if they're doing 3D games in OpenGL ES?
So the skill sets are going to be largely the same. As a Vulkan developer, you're going to have probably a tighter handle on things like, synchronization, careful tracking of memory allocation, because a lot less of that is going to be done for you by the driver. The upside of this is that the driver won't be doing these things when you don't expect it to. But you're going to have to really hone your skills at things like multi-threaded synchronization, memory allocation. Make sure that you are closely keeping an eye on what your code is doing and what it's asking the GPU to do, because the driver is going to do a whole lot less of that for you. It's not going to clean up after you. It's not going to check that you're making legal calls. So you're basically going to have to be a bit of a ninja.
It's almost like driving stick versus driving manual, right?
That's probably a really good analogy.
So people can learn about Vulkan on the Khronos site?
Yes.
You mentioned. So that's Khronos.org?
Khronos.org, www.khronos.org. And Khronos is spelled Khronos. And they have a Vulkan landing page where you can find the latest news about Vulkan and also see some of the presentations that were given, for example, at SIGGRAPH this year and at GDC about the shape of the API.
Okay. Now you were at SIGGRAPH, right?
I was at SIGGRAPH.
How did it go?
It was a lot of fun, actually. We did some demos, showed some spinning teapots.
Teapots?
So there's a little bit of history behind the teapot.
Okay.
The teapot is canonically called the Utah teapot, and it's because way back in the history of computer graphics, it's one of the first models that was digitized and shared. And interestingly, so the teapot, everybody knows that they've seen here and there over the years, it looks short and squat.
Okay.
But the reason for that is actually that on the original display system, the pixels were not square. So they had a different
ones from
TVs.
TVs.
The aspect ratio is a little bit different. So in real life, the teapot's actually a little taller.
Now you're saying that the pixels are like elongated, they were rectangular pixels, because this was done so long ago?
Oh yeah, it was, oh gosh, I guess it was the 70s.
Wow. So the first 3D model that was formed in cyberspace or whatever you want to call it back in the 70s, and you're still using the same model today to... I think Pixar also used the teapot, don't they?
Yeah, actually the teapot appears in every Pixar film. One of the ones I know off the top of my head is they use it in the Tea Party scene in Toy Story.
Okay, naturally that's where a teapot would fit.
Yeah, but there's one in every Pixar film.
Thank you so much, Shannon.
Thank you.
And thanks everybody for watching this episode of Coffee with a Googler. I don't know about you, but I've learned a lot about the kind of things that can be done with 3D graphics. And I'm really, really excited about Vulkan coming to Android. If you've got any questions for me, or if you've got any questions for Shannon, just please leave them in the comments below. We'll also link to the websites in the description of this video so that you can follow those links. And if you want to learn anything else about great stuff that Google has to offer for Android developers, Chrome developers, and everybody else, please subscribe to the Google Developers channel. Thank you.
With Android Lollipop, Material Design changed the way that apps look and feel to create more magic moments. But devices running earlier versions of Android don't have all of the same options. I'm Joanna Smith, and one of the coolest things that Material Design gave us were toolbars, which are now even more magical because they're backwards compatible as well. A toolbar is a view that is richer and more flexible than the traditional action bar. In fact, toolbars are part of your view hierarchy, so they can be animated or even react to scroll events. Because it's a view, you can use the toolbar as a standalone element anywhere in your app, providing the user with options and controls that don't need to span the entire layout width at the very top of the screen. You can even have multiple toolbars if the structure depends on the content of your layout, or if you're providing the user with many differing controls. To populate your toolbar with actions and options, you can inflate a menu onto the toolbar to display those actions to the user. You can also create your own controls, like adding a navigation button to go up to the parent activity. While toolbars can be used in any part of your layout, you can also choose to use the toolbar instead of the action bar whenever you simply want more control over the appearance and functionality of that action bar. So to use a toolbar in the place of the standard action bar, you first need to disable the action bar. The easiest way to do this is to have your theme extend from theme appcompat no action bar, or its light variant. Then create your toolbar the way you would create any other layout in your app, and call setActionBar to designate it as the action bar in the activity or fragment. By calling this method, the system will add the standard action bar options for you, so you don't need to inflate a menu. Now, you may be convinced of how awesome toolbars are, but how can you use them in versions of your app targeting older SDKs? Well, toolbars were added to the support library for AppCompat v21, so now it's as easy as calling setSupportActionBar instead of setActionBar to replace action bars on older devices. So check the documentation for all of the support options available so that you can bring more magic moments to your users. And for more tips on making sure that your app is at its best, check out the rest of our Android Development Patterns content or consider joining our G+ community. But most importantly, just continue to build better apps.
As a lot of developers know, there's more to having an app succeed than just building a great app. You want your app to be dynamic and responsive by delivering fresh content to users and quickly reacting to their changing needs. You want to test out major decisions to make sure you're doing the right thing before you push them to your entire audience. And ideally, you want to provide a tailored experience for each user, so your VIPs feel like, well, VIPs. But let's be honest, that can be a lot of work. And if you're a developer without a ton of resources, that's time you'd rather spend on other things, like building your app. That's where Firebase Remote Config comes in. Firebase Remote Config is a simple key value store that lives in the cloud. But don't let that simplicity fool you. Because it lives in the cloud, it means you're able to deploy changes that your app can read within a matter of minutes. For instance, say you've just pushed your app out to the world and you suddenly discover that your Swedish text contains some offensive language. How are you supposed to know? You don't speak Swedish. I don't blame you. But fixing that text the old-fashioned way would mean creating a new build and going through the entire publishing process again. That's something that could take days, which is an awfully long time to have 9.2 million people cursing your name. But if your app uses Firebase Remote Config, you could change that text in the cloud through the Firebase console. Kind of like this. The next time your users fire up their app, Remote Config will grab the latest values, update your app's text, and just like that, you've averted a major international crisis. Or, let's say you've got a puzzle game and you're hearing complaints from your players that level 5 is too hard. If you've configured your app using Remote Config, you could tweak those settings to give your players a few more turns and push out that change to the world. But hang on, are you sure that's the right thing to do? What if the silent majority of your users actually enjoy the challenge of a more difficult level? And by making it easier, you're going to turn away your most hardcore and potentially highest paying customers. How could you test whether or not this change is a good one? Sounds like you need an A/B test. That's where Remote Config's audience segmentation feature comes in. This allows you to deliver different configurations to different groups of users simultaneously. So you can try out your new level settings with half your users while keeping the old settings with the other half. But audience segmentation isn't just great for A/B testing. Maybe you've got a feature change that could have a major impact on your in-app economy. Or maybe you just want to double check that some new networking code isn't going to set your servers on fire. You can use Firebase Remote Config to gradually roll out these changes, trying them first with a small percentage of your users, before pushing them out to your entire audience. Remote Config can also deliver different configuration sets to your users based on all sorts of different factors, from device type or locale to any audience segment you've defined in Firebase Analytics. So you can send out one welcome message to your New Zealand customers and another to your Australian ones, or only show your Review This App button to people who use your app every day, or you can change your home screen experience for your customers who have spent large amounts of money on in-app purchases, so they feel special. Remote Config is backed by a client library on iOS and Android that handles important tasks like caching, dealing with flaky connections, and keeping network requests lightweight, which is always a good thing. To give Remote Config a try, check out our documentation here. We can't wait to see what you build.
Here's an old school tip for you. If you can animate something based on user input, you probably don't want to have it update immediately to track the input event, because it can often feel very jittery. Instead, what you should do is use the oldest easing equation in the book, which looks like this: value plus equals target minus value all over strength. Here we're changing the value based on how close it is to the target. The closer it is, the less it gets moved, making it look way nicer. So there you have it, a little tip to make your input-based animations a teeny bit smoother.
Another day.
Yes. Another journey.
I know indeed, right? How's your aim?
Well, not great in the middle of the night, but I sometimes just sit down.
No, actually I meant your snooker, your pool, or in this case, your billiards.
Ooh, we're going to a billiard hall?
That we are, sir.
So, I made a thing.
That's unusual for you.
I know.
You're like 2 in as many months or something.
Yeah, it's a new thing. It's
what is
really,
it?
It's a little.
Is it a web app?
Yes, it is a web app.
Is it a website? What's the difference, Jake?
Shut up. We're not doing web apps as websites. I would say it's an app.
Would you?
I
an app with content?
Flipped a coin. It's an app. No, it's not. It's a site. It's a Wikipedia article viewer.
Okay.
Which I realise is what Wikipedia does already.
Yes.
But this was more of an exercise in looking at like performance, like page load time performance.
But you think you can beat Wikipedia at a server-side render, do you?
I did.
You did?
Well, so this is the thing. I was hosting on GitHub, so I was doing a client-side render.
I know. After all you said.
It seemed like a nice, simple way to get into it. And I was serving it just, JavaScript down the wire, then JavaScript's getting the content and putting it on the page. And I was looking at my official figures, 2.6 seconds for first render.
Okay.
And 4.7 seconds for content, which even at that point was faster than Wikipedia's actual official site.
Oh.
But, I knew it could be better than that.
Okay. What was in that first render?
First render was just like the top toolbar that said like Wikipedia and a spinner.
Okay, but from a user's point of view, they've got something, they know they're on the way. Okay.
Yeah, and then I think it was 4.7 seconds till the actual Wikipedia article came down.
So you've actually got a good couple of seconds there where you're spinning up, where your app doesn't seem to be it's idle essentially.
Yeah, I know you're pulling your sad face, but don't worry, that's not the end
I'm pulling
of the story.
a mulling face. I'm mulling over.
Okay. Well, pulling your mulling face, I can tell you what I did to fix it. There's a happy.
Better than my other faces.
You okay? You're having a stroke. So yeah, I made the JavaScript async.
Okay.
And put some markup on the page for that first render.
Yes.
And I inlined the CSS for that first render.
Good. Normal. Yeah. All normal.
Well, you say normal. When I first heard that rule, it's like, take some of your CSS out and put it in the head. I was like, that's a big ask for developers, really.
Whoa, big what? You said big ask.
Yeah, okay.
It's a big ask. It's a request, pal.
Yeah, I know. Oh my God, I hate it when people...
that person. You've become that
people
person.
say that.
Yeah. Next up, you'll be asking to reason about things, or using modulo.
To reason about, I hate that one, because it is just developers not wanting to say they don't understand.
I actually do like modulo, but...
So, I do agree that it's too hard to async load CSS. This is something that we have a problem with on the platform, right?
I actually tried it. It's rubbish.
Yeah, we've got load CSS from the Filament group, but it's more script than you should need. It should just be async on the link element.
It should be declarative. Yeah.
But moreover, I think what Firefox and IE do at the moment is actually really good. It's a bit of non-standard behavior, but I really like it. put the link element on the page in the body just before the content that needs it. And it will block the rendering, wait for it, it'll block the rendering of the subsequent content until that CSS loads. It's not blocking all page rendering.
Okay.
It's just the elements after don't go into the render tree.
Okay, fair enough.
We should do that. Yes. We should take that on. And we should also have async as well.
Okay, so
where
am
I?
We had a parallelizable thing, last I understood, of where you had the JavaScript that went off to get the Wikipedia page, and I was saying that's bonkers.
And so, yes, I came to the same conclusion. I thought, this needs server rendering.
Wise man.
Yep, thank you. Let's do a
cheers.
Cheers to server rendering.
Well, this is the nerdiest cheer that ever went up.
So, like, looking at my calculations, once I introduced server rendering, things got slower.
Right.
That's
a bit annoying.
My content render actually sort of came down a little bit, not much, but my first render skyrocketed.
Why?
It was slower because connection goes off to my server.
Yes.
My server goes off to Wikipedia, gets the data, comes back, constructs the page, sends it on. You're looking at a white screen for longer now because you've got the bottleneck of your third-party service. But it was by taking that just the JavaScript CSS, the basic page shell, down to 0.1 seconds, like as good as instant for that first render, because it's all offline. But here's an interesting thing that happened, is my content render went, because I'm now back to doing client-side rendering, content render's gone up again. Because even though it's coming from the cache, there was two problems. There's one that it was the request to Wikipedia is a little bit delayed because it has to parse the JavaScript
to Wikipedia.
To Wikipedia.
It's delayed. I like that. It's almost like I
didn't do that on purpose.
Really?
But yeah, so I cut that delay by as soon as the request went to the service worker, had the service worker go off and fetch the stuff for Wikipedia.
Oh, okay. So how do you then? Because you still want to send your response back with the app shell stuff.
Yep. What you're talking about there is chunked encoding.
Ah, okay.
So this is the art of being able to being able to quickly send data back without knowing your whole page content. So I was able to send back like the header and the first render stuff essentially. So now the browser knows about the extra CSS and JavaScript it needs. Meanwhile, or like at the first possible opportunity, my server's gone off to Wikipedia and it's gathering that. And then as it arrives, it just streams it through, and that slashed the rendering time. We got down to so we were at 1.4 seconds for first render, and when I get the official figures up, so that was it down to 2.4 seconds for the content, and that's like a 2-second saving compared to JavaScript.
That's good.
3G. Yeah, it's pretty huge. And
you can't really get any better than that, can you?
Oh, you can, sir, by using a little technology you might not have heard of before. Service worker.
Yay!
But yeah, as soon as you take the content, the page shell offline, that's it. You can get to that first render in like 0.1 seconds. Like the measurement came out, but it's instant, really.
Yeah.
But it took 9K of the content down the wire, and once I had that, wrote it to the page, and then wrote again once I had the rest. And it was a total hack to do that. And this is why my next wish for the internet, for the web standard, is streams. Because I want to be able to just take some content that we're downloading, pipe it into an element, and it appears as it. And I think once we have that, that kind of rendering as it goes along, I think that's when we can see client-side rendering apps become competitive with server-rendered apps.
We'll drink to that.
Cheers.
Hello, I'm Timothy Jordan, and you're watching the Google I/O 2016 livestream. The keynote is over, but there are many more developer sessions to come. Stay tuned on all 4 livestream channels throughout the next 3 days. We'll also be on the ground and behind the scenes finding the coolest and most innovative things to share with you right here on the livestream between sessions. Oh, and if you want us to track someone down with your question, use the hashtag AskDevShow.
Right, here we go. Mr. Lewis, how do you feel about roller coasters?
Oh, I like them. Roller coaster of love. Let's roll.
So, I've got a bone to pick with you.
Oh, that's unusual. We normally get on just fine.
Well, because I've been watching you.
No,
and,
that's a bit weird.
I've noticed that you've been engaging in some degree of Babel activity.
Oh,
You've
thank
been
goodness
using
for
a bit
that.
of the ES6, ES7.
Not quite as terrifying as I thought it might have been this.
But you're the kind of person who says, and I've heard you say this, that you don't like writing code that isn't the code that ends up being executed in the browser.
Correct.
Like you don't like those little middle steps. You're kind of anti-transpiler.
I am sort of anti-transpiler. I want to feel like the code I write is the code that runs, and I'm happy for a little bit of wool to be pulled over my eyes, but I want to feel like I can back out of it. So I don't think that's changed. I think for me, when I look at something like Babel, or Babelify or any of that, one thing is I feel like I could switch it out for Tracer, or I could switch it out for something else.
Because it's an open standard. I guess there are independent implementations of that standard.
Exactly.
Oh, okay,
so it's like it feels like this is the JavaScript I'm going to be writing, right? So a while from now. So if it's going to get me there, then that's fine. I'm okay with that. And then the other thing is, if you look at the ES5 that it generates, it's like, it makes sense, it's fine. And I feel like when you look at some other things, whether that, I don't know, CoffeeScript or TypeScript, something like that, you can never say that, because it's like, you're always going to be transpiling across.
Yeah, I had this issue actually. I was using a project, npm installing something, using it, and there was a bug, and I thought, as a citizen of the internet, I am going to do a pull request. I'm going to try and fix that. And and when I got onto GitHub and click, CoffeeScript.
Oh,
I was like,
okay,
well,
yeah, no. Bye-bye.
Now step one of making this fix is learn CoffeeScript.
Yeah, and it's like, unless I really, really care about fixing the bug, it's not. For me, it's like JavaScript becomes, ES6, ES7, ES whatever. But like you say, this kind of, let's learn TypeScript or CoffeeScript or anything else. It's just like, I've got to really want to go off and do that for some reason, and I don't see what that reason is, because JavaScript for me, for everything, is fine. I actually really liked Babel, if for no other reason than its source maps were just super. So even though I wasn't really sort of aiming for that, when I did get an error, it was like, whatever .js line, whatever, and it was like, yeah, that is the correct line. And
well, so even if you're not using source maps with Babel, the output is actually pretty sensible for the most part.
Yes.
But as you say, source maps just make it completely transparent. It's almost like you're not using a transpiler at all.
Exactly. So I'm happy with the illusion of it, I think. That's probably what it comes down to. But as I say, you're right. If you look at the actual code it generates, for me, I was just like, yeah, that's not necessarily code I'd write, but that's okay. It's just about manageable and readable.
So go on then. What are your big hitters in ES6 and 7 world? What's your favies?
My faves.
Your faves.
Contentious one would be classes. I actually really like classes, because people are like, what's wrong with the prototype? You're turning your back on prototypes.
You're still using a prototype, it's just sugar.
Yes, exactly, but nice sugar at that. Very nice.
Yeah, because I don't know, I always
refined
mess it up.
sugar.
Like if I'm doing like something.prototype equals object.create, the thing I'm extending, and I keep forgetting the .prototype on the end there.
But that's one of about
It's really difficult. It's really awkward compared to class thing extend thing.
And that's the one way you do it in ES6. Like with the ES5, you've got 11 billion ways of doing it, and not all of them are good necessarily, or readable, or what you want to see if you're looking at your own code 6 months from now or somebody else's code. So it kind of felt like it was more like the code I want to write, more like the code I want to read. It's where we're going. It's a feature. It's not like somebody just went off piste and did something that they wanted to do.
And I can barely remember how to spell function now. Yeah, because you can within an object, it's just the name, brackets, off you go. There's arrow.
Fat arrow function was something else I really liked.
Yep, we love a bit of fat arrow.
Yeah, because a number of times I use request animation frame, set timeout, set interval, something like that, and it's like, oh, all of a sudden I'm on the window scope, am I? Great, thanks for that. So bind, it's like, don't worry. I don't mind bind. It's better than var that equals this for me.
I don't.
You don't like that.
No, I don't do that equals this. But I will give it a specific, proper variable name,
like what?
Based on the name of the class.
Well, okay. Jakey this, var Jakey this.
So if it's class vehicle, inside that I will do var vehicle equals this, like lowercase vehicle equals this, and it's but it makes sense then. I don't like that because it's like, well, that's just as because this is a problem in JavaScript, I think.
Yes.
Like this, so this what and that's what one of the things that arrow functions solve is you. There tends to only be one option for what the this is, and it's the instance name.
Yeah.
Which that makes way more sense.
So it works for me. I really like that.
Destructuring I like.
Beautiful.
Especially for option objects.
Yes.
At the end of a
with defaults,
function.
right?
This is it. It becomes self-documenting. You can say, right, this is optional. But inside this object, here are the properties that I'm looking for, and here are their defaults.
Yep. But in any case, I feel like, going back to your original question, it's like the reason I would use a transpiler today is an if and only if it lets me experience the future now, get used to like the future now. I think it's where we're going.
Which you get with source maps. It feels like you can almost ignore the transpilers there.
Yeah, exactly. And as I say, the code that it generates makes sense to me. So I'm all up for that.
Yay for transpilers.
Yay.
Cheers. We need beers.
All right, well, it's getting pretty late. I think that was a pretty good take, so let's just do one more and then we'll be out for the day. Okay, Rob?
All right.
3, 2.
Otherwise, as
Hey,
always,
Rob.
Oh, hey, what's up, David?
Did I tell you that I got my own YouTube show?
Oh, no, dude, that's awesome. What's it gonna be about?
So, like, you know, I was thinking there's, you know, not a lot of screencast content out there, and so I'm gonna go and make a bunch of screencasts on Firebase.
Well, that's sort of exactly what we're doing here for Polycast, a show about...
It's nothing like that, really. Like I said, my show is gonna be on Firebase, you know, like building real-time cross-platform apps, you know, without any server code.
Well, I have all this equipment, I have this crew, so if you want, I can show you the ropes
So I was thinking of
sometimes.
calling
like
it
put the...
Firecasts, you know, like the Firebase, you know, it's for the fire.
Yeah, the Firebase, yeah.
And, you know, like the cast comes from screencast.
Screencasting.
Yeah.
Yes.
What do you think?
Six lines of code is all it takes to write your first machine learning program. My name's Josh Gordon, and today I'll walk you through writing Hello World for machine learning. In the first few episodes of this series, we'll teach you how to get started with machine learning from scratch. To do that, we'll work with two open source libraries, scikit-learn and TensorFlow. We'll see scikit in action in a minute, but first let's talk quickly about what machine learning is and why it's important. You can think of machine learning as a subfield of artificial intelligence. Early AI programs typically excelled at just one thing. For example, Deep Blue could play chess at a championship level, but that's all it could do. Today we want to write one program that can solve many problems without needing to be rewritten. AlphaGo is a great example of that. As we speak, it's competing in the World Go Championship, but similar software can also learn to play Atari games. Machine learning is what makes that possible. It's the study of algorithms that learn from examples and experience instead of relying on hard-coded rules. So that's the state of the art, but here's a much simpler example we'll start coding up today. I'll give you a problem that sounds easy, but is impossible to solve without machine learning. Can you write code to tell the difference between an apple and an orange? Imagine I asked you to write a program that takes an image file as input, does some analysis, and outputs the type of fruit. How can you solve this? You'd have to start by writing lots of manual rules. For example, you could write code to count how many orange pixels there are and compare that to the number of green ones. The ratio should give you a hint about the type of fruit. That works fine for simple images like these, but as you dive deeper into the problem, you'll find the real world is messy, and the rules you write start to break. How would you write code to handle black and white photos? Or images with no apples or oranges in them at all? In fact, for just about any rule you write, I can find an image where it won't work. You'd need to write tons of rules, and that's just to tell the difference between apples and oranges. If I gave you a new problem, you'd need to start all over again. Clearly, we need something better. To solve this, we need an algorithm that can figure out the rules for us so we don't have to write them by hand. And for that, we're going to train a classifier. For now, you can think of a classifier as a function. It takes some data as input and assigns a label to it as output. For example, I could have a picture and I want to classify it as an apple or an orange. Or I could have an email and I want to classify it as spam or not spam. The technique to write the classifier automatically is called supervised learning. It begins with examples of the problem you want to solve. To code this up, we'll work with scikit-learn. Here, I'll download and install the library. There are a couple different ways to do that, but for me, the easiest has been to use Anaconda. This makes it easy to get all the dependencies set up and works well cross-platform. With the magic of video, I'll fast forward through downloading and installing it. Once it's installed, you can test that everything is working properly by starting a Python script and importing sklearn. Assuming that worked, that's line 1 of our program down, 5 to go. To use supervised learning, we'll follow a recipe with a few standard steps. Step 1 is to collect training data. These are examples of the problem we want to solve. For our problem, we're going to write a function to classify a piece of fruit. For starters, it will take a description of the fruit as input and predict whether it's an apple or orange as output, based on features like its weight and texture. To collect our training data, imagine we head out to an orchard. We'll look at different apples and oranges and write down measurements that describe them in a table. In machine learning, these measurements are called features. To keep things simple, here we've used just two: how much each fruit weighs in grams and its texture, which can be bumpy or smooth. A good feature makes it easy to discriminate between different types of fruit. Each row in our training data is an example. It describes one piece of fruit. The last column is called the label. It identifies what type of fruit is in each row, and there are just two possibilities: apples and oranges. The whole table is our training data. Think of these as all the examples we want the classifier to learn from. The more training data you have, the better a classifier you can create. Now let's write down our training data in code. We'll use two variables, features and labels. Features contains the first two columns, and labels contains the last. You can think of features as the input to the classifier, and labels as the output we want. I'm going to change the variable type of all our features to ints instead of strings. So I'll use 0 for bumpy and 1 for smooth. I'll do the same for our labels, so I'll use 0 for apple and 1 for orange. These are lines 2 and 3 in our program. Step 2 in our recipe is to use these examples to train a classifier. The type of classifier we'll start with is called a decision tree. We'll dive into the details of how these work in a future episode, but for now it's okay to think of a classifier as a box of rules. That's because there are many different types of classifier, but the input and output type is always the same. I'm going to import the tree, then on line 4 of our script we'll create the classifier. At this point, it's just an empty box of rules. It doesn't know anything about apples and oranges yet. To train it, we'll need a learning algorithm. If a classifier is a box of rules, then you can think of the learning algorithm as the procedure that creates them. It does that by finding patterns in your training data. For example, it might notice oranges tend to weigh more, so it'll create a rule saying that the heavier a fruit is, the more likely it is to be an orange. In scikit, the training algorithm is included in the classifier object, and it's called fit. You can think of fit as being a synonym for find patterns in data. We'll get into the details of how this happens under the hood in a future episode. At this point, we have a trained classifier, so let's take it for a spin and use it to classify a new fruit. The input to the classifier is the features for our new example. Let's say the fruit we want to classify is 150 grams and bumpy. The output will be a 0 if it's an apple or 1 if it's an orange. Before we hit enter and see what the classifier predicts, let's think for a sec. If you had to guess, what would you say the output should be? To figure that out, compare this fruit to our training data. It looks like it's similar to an orange because it's heavy and bumpy. That's what I'd guess anyway, and if we hit enter, it's what our classifier predicts as well. If everything worked for you, then that's it for your first machine learning program. You can create a new classifier for a new problem just by changing the training data. That makes this approach far more reusable than writing new rules for each problem. Now you might be wondering why we described our fruit using a table of features instead of using pictures of the fruit as training data. Well, you can use pictures, and we'll get to that in a future episode, but as you'll see later on, the way we did it here is more general. The neat thing is that programming with machine learning isn't hard, but to get it right, you need to understand a few important concepts. I'll start walking you through those in the next few episodes. Thanks very much for watching, and I'll see you then.
Developing a successful app isn't easy. To reach a broad audience, you'll need to consider your iOS, Android, and mobile web users. And to build for these platforms, you'll need a backend server to store data and support the apps. Of course, you want to get your users logged in, hopefully lots of users, which means your backend will have to scale. Then after you've solved your scaling problems, you'll have to find more ways to spread the word to get new users. But have you found a way to measure all this activity? And oh no, your app is crashing and causing servers to melt down, and you haven't even made a dime yet. Don't you wish this could be easier? This is why we built Firebase. It has all the tools you need to build a successful app. It helps you reach new users, keep them engaged, scale up to meet that demand, in addition to getting paid. From the beginning, with Firebase, you'll have test lab and crash reporting to prevent and diagnose errors in your app. Your backend infrastructure problems are solved with our real-time database, file storage, and hosting solutions. Acquiring new users is easy with invites, AdWords, and dynamic links. And using the authentication component, you can get those users logged in with minimal friction. Once installed, you can keep your users engaged with notifications, cloud messaging, and app indexing. Then, with Remote Config, you'll have the freedom to experiment with new features and optimize the user experience in real time. And of course, you can earn money with the same AdMob component that's been monetizing great apps for years. Last, but certainly not least, our all-new Analytics component, designed uniquely for Firebase, brings insight into how well these components are working for you and your users. With Firebase Analytics, you can measure and optimize your advertising campaigns, discover who are your most valuable users, and understand exactly how they are using your app. Now, all these components work great on their own and provide a solid infrastructure to build out your app, but they work even better when combined in creative ways. So let Firebase handle the details of your app's backend infrastructure, user engagement, and monetization, while you spend more time building the apps your users will love. To get started right now with Firebase on Android, iOS, or the web, follow these links for more information. Then, to manage and monitor your apps connected to Firebase, there's a web console to view crashes, set up experiments, track analytics, and a whole lot more. And to learn more about Firebase and all of its components, you can read the documentation right here. We can't wait to see what you build.
Let's be honest, you're an awesome engineer with an awesome app and you are using threading to the max. Sadly though, managing all those individual threads and assigning work between them is causing you to lose your hair. My name is Colt McCandless, and please, don't join the Bald Club. Instead, use the Thread Pools class, which is an ideal primitive for breaking up lots of work into little buckets. See, historically, it was commonplace that applications would use a dedicated thread model. That is, one thread that only deals with database rights, while a separate thread only handles streaming of music, and a third one only handles networking. These setups are okay because the amount of work per thread isn't that large, and it's okay to handle this work in sequential order. But there reaches a point where this model starts to fall over. Say, for example, that you've got 40 bitmaps to decode, and each decode takes like 4 milliseconds or something. Putting all of this work on a single dedicated thread is a bad idea, since it'll take 80 milliseconds total to get all that work done in a sequential fashion. On the other hand, if you created 10 threads and let each one decode 4 bitmaps, then you'd end up only taking 16 milliseconds total. But then, of course, you run into the problem of how to properly pass the work around between those threads, schedule that work, and then managing of those threads. Before you start stressing out about writing all that code, don't worry. This is exactly what Thread Pool Executor primitive is for. Basically, this class will just let you spin up a number of threads and toss blocks of work to execute on it. Thread Pool Executor handles all of the heavy lifting of spinning up the threads, load balancing work across those threads, and even killing those threads when they have been idle for a while. Basically, it handles all the heavy lifting of super parallel processing on your behalf. All you have to do is split up the work. But there's a small caveat here. How many threads should your thread pool have? I mean, technically speaking, you have the ability to create as many threads as you want, but that's not ideal. See, CPUs can only execute a certain number of threads in parallel. Once you get above that number, then the CPU has to start deciding which threads get the next free block of processor time based on how important they are. Which means that if you keep eventually adding threads, you'll hit a break-even point where your computation isn't getting any faster, even though the number of threads that you have has increased significantly. And it's also important to note that each of these threads aren't free. Each thread costs you about 64K of memory in minimum, and that adds up quickly, especially in situations where the call stacks can start growing pretty large. As such, your app needs to find a sweet spot between the number of cores and the point of diminishing return with the number of threads. Thankfully, once again, the Thread Pool Executor class has got you covered. When creating your thread pool, you can specify the number of initial threads and the number of maximum threads. As the workload in the thread pool changes, it'll scale the number of alive threads to match. Oh, and a quick note, the value returned from get available processors may not reflect the number of physical cores in the device. See, some devices have CPUs that will deactivate one or more cores depending on the system load to save battery. So if your device has 2 CPUs, but one of them is asleep, this value could return 1. And of course, thread pools won't solve all of your threading problems. As mentioned earlier, unless you're dealing with lots and lots of work packets all the time, this thing's kind of overkill. It's best to use things like handler threads or async task loaders for specific types of work blocks and only throw the massive computing problems at the thread pool. And for you power users out there, remember that RenderScript might be a better alternative to large-scale parallel work on Android devices, but that's a whole separate set of videos that we haven't gotten into yet. And don't forget that Systrace is an amazingly powerful tool that lets you visualize how work is flowing through the threads in your application. It's a great way to validate that things are working as intended and also see all the other crazy threads that are being worked on by other parts of your app. And that's the trick with performance, isn't it? I mean, you can make assumptions, but things don't always work the way you think, which is why you need to check out the rest of the Android Performance Patterns videos, and don't forget to join our Google Plus community to ask a lot of hard threading questions as well. So keep calm, profile your code, and always remember, perf matters.
Hey folks, welcome to Totally Tooling Tips Season 3.
Come check us out. We're going to be talking about progressive web apps, some of the tooling around them.
On first visit, we've got a relatively fast time to first meaningful paint. Module bundling, accessibility. Do you know what the top 4 things to look at when it comes to web accessibility are?
No, I can only think of 2. I only think of audio and then visual.
So there's visual, hearing, mobility, and cognition.
The first episode will be out on April the 27th. So subscribe to the YouTube channel, check out Season 1 and 2 before Season 3 starts, which will be happening soon.
We promise that Season 3 is going to be equally as mediocre as Seasons 1 and 2.
Hi, I'm Timothy Jordan, and this is The Developer Show. I'm standing here with Purnima Kochikar, Director for Google Play, Apps and Games. Purnima, welcome to the show.
Thank you, Timothy. Thanks for having me.
Hey, it's great to have you here. First, I'd like to learn a little bit about your history and what brought you to Google Play. I know that you used to be VP at Nokia for developer communities. What is it that you learned about developers there that brought you to this role?
What I loved about working with developers is that they are always optimistic. I don't think there's any job in the world that you're working with more optimistic people who are trying to solve amazing problems. Every day I talk to people who are saying, this is a new way of doing taxis, or a new way of doing education, or a new way of supplying food. So there's always a new way, and that's exciting. The second thing, what I love about developers, is that they'll take the technology or a platform that you have built and completely use it in ways that you have never imagined would happen. And so the two aspects of it, the surprises and the solutions, is what makes me excited about working with developers.
That's one of my favorite things too, is that working with platforms, we always kind of have an idea of how developers are going to use it, and then they always find a way to surprise us, especially with Google Play, because the landscape is so huge. There's always something every week where you're like, that's amazing, and I never would have thought of that.
Yeah, exactly. And so it's amazing to be able to do this. Plus, you realize that you're actually making a difference in people's lives, both for the developer as well as for the user. Yeah. And so that helps too.
It's interesting to talk about Google Play because developers building on Android already know about Google Play. But sometimes I wonder if they know all of the kind of nooks and crannies and some of the best features. Do you have like maybe some of your favorite lesser-known features of Google Play that are great for app developers and publishers?
Well, I don't know whether it's about lesser-known features, but maybe we should talk about the things that people may not think about. Number one thing I believe that people should really think about is that your users really want your app to get better. And you should tap into them. I think a lot of times we think, I hear developers say, there's a really bad review, can you make it go away? And I'm like, no, harness it. Your user really cares. So what can you do about it? But they're also telling you positive things. So on Google Play, one of the things we've really focused on is to how to get developers harness all the intelligence of the users to make better products. So everything from alpha beta testing to stage rollouts, and now we just introduce A/B testing, which we call store listing experiments. So harnessing the intelligence of your users, who are your biggest advocates, and your users to make apps better, I think is something people don't use enough.
Well, and we just mentioned an article on the show about ratings and reviews in the Google Play Developer Console. And I think we've done a lot of work there to bring that intelligence into a format that's actionable and really intelligible at the same time.
Absolutely. One of the big things developers told us is that we love the fact that we can reply to reviews and that we can have a direct channel of communication to our users. However, there are so many reviews. How do I find the themes? How do I know areas that I should focus on? And what I find interesting is that there are folks who view it as something as a problem to fix, but a lot of people are now looking at as strengths that they need to leverage. So they're looking at it as a way to measure community sentiment management. So what we did is to say, how do we measure sentiment? And the tools that you're talking about allow developers to, use Google Smarts to understand all the hidden gems in your ratings and reviews.
That's cool. Developers often ask me, and I'm sure they ask you as well, what's the secret? And coolest thing is you actually recently published the second version of the Secrets to App Success on Google Play, which you should check out and will be linked in the show notes. However, maybe you could give us a highlight. What's one of your favorite kind of insights from that book?
The first thing we did was actually put it out linearly. So the nice thing about the book is that you can always just jump in where you are at the stage of what matters to you. So if you're in design, there is a section for design. If you're in a place where you're building growth, there's a section for growth. If you're thinking about, should I use ads for monetizing, there's a section for that. It goes not just about Android and Play, but also looks at other Google technologies, like ads, for example. So that's a huge plus. So the big insight I would like to point there is to really think about this, what it means to be not constrained by the market that you're in. Android is huge. It's around the world.
Okay.
And you could be a global business no matter where you are. This book gives you interesting ways to tie from everything from how do you design for various markets, how do you localize, but also how you price. So that I think is...
It's really inspiring.
Yes. I mean, think about it. 20 years ago, they would have needed a new management team to figure out how to take a business global.
Yeah.
Now you could do it from your living room.
In sales offices in multiple markets, whereas, again...
Now you can.
That's great. Thanks for joining me today.
Thanks for having me, Timothy. This was fun.
For more information about everything that we talked about, check the show notes for links. And of course, subscribe to this channel for more interviews like this. I'm Timothy Jordan, and I'll see you next time.
Polycast 43, take one.
Hey there, Polycasters. Rob here. Welcome back to the show. Last week, we were doing this thing called Ask Polymer, where we take questions from you and then we try and answer them here on the YouTube channel. And as we were collecting those questions, I noticed a lot of folks were asking, when's the Polymer team going to create a data table? Or what is the roadmap for this particular element and stuff like that. And as we were going through that process, I really started to think that, if web components are going to be successful, we're going to have to scale beyond the Polymer team. Really, it's going to be up to all of us out here in the community to start making cool stuff, sharing it with one another, and also promoting it, right? So one of the things that I wanted to do was, here on this show, I want to start a new segment called Built with Polymer, where I take all the cool stuff that you're building and we just show it off so other folks can get involved with the projects and start using it in their own applications. Now, to do this, we're going to start off by looking at a website called customelements.io. I'm curious, show of hands, how many of you have seen customelements.io before? Okay, I noticed that you did not raise your hand, sir. So for you and for other folks like you, I want to just walk you through how this website works and some of the cool stuff that's on there. So if you haven't seen it before, customelements.io is pretty badass. You can think of it kind of like NPM for web components. It's sort of a registry. It collects all the things that are actually in the Bower registry, and then it displays little bits of info about it. So you can search and you can find the different components that are out there. You go to the website, and the first thing that you're going to see up here are these three sort of main sections. You've got the stuff that is recently created, It's brand new. You got the things that have been recently updated, which I always like to see. That's supposed to be a clock. And then you've also got the stuff that's the most popular elements out there. So the things with the most GitHub stars. All three of these very useful categories to kind of keep tabs on. And one of the things that I also really like is you've got this really huge search field up at the top. You know, anything that you could kind of imagine needing a component for, you can just go type. So I might say, oh, I want something like a table. So go type in table, and now I've got all of these cool results popping up here for various kinds of tables. Another thing that CustomElements.io gives you, which is pretty awesome, is at any point if you want, you can click on someone's profile photo. And this will show you not only their profile page, but also all the cool elements that they've produced in addition to that one that you were looking at. So if you think someone's making some really high quality stuff, you can kind of stalk them on CustomElements.io and see what else they're making. Going back to where we were last week, a lot of folks were asking, when is the Polymer team going to create a date picker in the material design style? Now, this is something that is not currently on the Polymer team's to-do list. We have a lot of elements that we've created, and right now what we really want to focus on is sort of polishing those, closing bugs, and making sure that they work really well. So at the moment, no one is actively working on a paper date picker, and that, for a lot of folks, is sort of a dilemma. But if we go to CustomElements.io, we go to the search field, we can just type in date picker, or just date, whatever, and we can see right here, right away, we've got this paper date picker that shows up by this guy named Ben Davis. So let's scope that out. And looking at the component page on CustomElements.io, we get a lot of information really quick right here. So I can see, for instance, how many stars this component has. I can see how many people have forked it and how many people are watching the issues on it. I also get the one-liner to install this on Bower. And what I think is maybe one of the most important aspects of the site, I get this activity panel here. And on the activity panel, I can see that the component was created a year ago. And most importantly, I can see that it was last updated 11 days ago, which tells me that this is still being actively developed. People are, contributing to this thing. They're patching it. They're fixing bugs. And it's getting a lot of love right now, which is important for anything that I'm going to add to my application. Also, we've got the list of Bower dependencies down here on the right-hand side. And again, it's really valuable because I want to know that, hey, is this thing depending on the latest version of Polymer, or at least Polymer 1.0 and some version above that? I don't want an element that is Polymer 0.5 or Polymer 0.3 or anything. That's just not going to work in my app. So having all of this information just kind of at your disposal every time you go check out one of these elements is a huge, huge benefit, and one of the main reasons why I think everyone should be using CustomElements.io. Now, the other thing that it does is it slurps in the README for this element. So you can see here on the left, I've got kind of the GitHub README that's just been pulled into the website. And if you want, you can go down here and click on the component page. And this is going to give you sort of the classic Polymer docs style, right? You've probably seen these before, where you can see properties that an element supports. You can see the methods that it supports as well. One of the things that I noticed was not showing up here, usually up in the top right corner, there's a little demo button. It's not showing up on this page, but we can just add that by typing demo into the URL bar. And now, ta-da, we've got our paper date picker showing up. And you can see this thing looks pretty nice, right? I can go click around different dates. Changing the month gives me these sort of cool material design ripple effects. Close it, and then I can click this button again to show you how it reopens. Lastly, one of the things that's really important is making sure that the date picker is responsive. So I go grab the corner of my browser, start shrinking the page, and then boom, you can see that it has changed its layout, which is really, really good for mobile devices. So that is just one element that Ben Davis has produced. If you go back to his profile on CustomElements.io, you can see that he's got a few other items here. Paper chip, paper time picker, slightly different from a date picker, paper full screen dialog, a lot of really interesting looking stuff there that hopefully we can show off in a future episode. So go find some elements on CustomElements.io, go find the authors, stalk them on GitHub, don't stalk them in real life, but stalk them on GitHub and on this website, right? So you can keep tabs on all the cool stuff that they're building. Another thing that happened last week was a lot of folks were asking, when's the Polymer team going to create a data table? Something that is really sophisticated that I can filter, where I can rearrange columns and do all sorts of stuff like that. Honestly, again, this is one of those things that it's such a big undertaking. No one on the Polymer team currently has it on their to-do list, because building a complex data table, you could seriously just found a company just on making a killer data table. And in fact, there's a group of folks who have done just that. So recently, a team called Vaadin released a set of elements, which they're calling Vaadin elements. And very similar to the product lines that the Polymer team vends, things like iron elements and paper elements, they put out this set. And the Vaadin elements are split into kind of two categories. You've got these business-oriented elements for things like data tables and combo boxes. They've even created an icon set of kind of businessy icons. And then they've also got a bunch of sort of data visualization components, Vaadin charts. Now, the core elements, as they call them, these sort of business layout ones, these are all free and open source. They are Apache licensed, so you can use them in your project today. And then the chart elements, those are a commercial license, which you have to pay for. But since a lot of you were asking about data tables, I thought this would be a really good one to highlight because it's available on GitHub and you can mess around with it and use it today in your project for free. So if you go to their website, which is at vaadin.com/elements, they've got this little demo button. And if we click that, it's going to show us this cool expense manager application. So I'm going to scope out the live demo for this puppy. And we've got a really, really nice looking experience here. So kind of classic table layout, columns and headers. What I really like about this is there's these filters up at the top. So I can just like go and check some of these values. And for instance, checking in progress and reimbursed, you can see over here the amount of items in the table is changing as I'm changing these values, right? You can sort of see them changing over here as well on the left. We can also look for different merchants. So I could say, oh, I just want to see stuff from the taxi merchant, for instance, and we'll just get only the expenses related to that category. Likewise, we can search by min and max values. A lot of cool things you can do here. They've even got this little floating action button down here at the bottom. So you can use that to open a dialog and actually add a new expense to this table. Really, really cool example, really, really cool, powerful element. It's one of those things that, again, it's not on the Polymer team's agenda at the moment to build, but here you've got this awesome community-built project, which we can all start using in our own work. So yeah, that about covers it for today. I know I've only shown a couple elements, but there's actually a big, long list of elements that I want to start featuring on this show. But before I get into that, if you out there, if you've got some stuff that you've built which you would like for us to show off, it can be elements, it could just be cool projects that you've built, please leave me a comment down there in the YouTube comments, or you can ping me on Twitter at #BuiltWithPolymer. That about covers it for today. So as always, thank you so much for watching, and I'll see you next time. Ready? Yeah.
43, take 2, second sticks.
Hey there, Polycasters, Rob here. I'm gonna pause for a second. Oh, Twitter notifications.
If a tree falls in the forest and nobody's there to hear it, does it make a sound? More importantly, if your app gets published to the world and nobody's there to download it, was all that work for nothing? These aren't just philosophical questions. Discovery is a major issue for everybody. It doesn't matter if you're a two-person shop or a big corporation. And while there are many avenues for potential customers to discover your app, one of the most common is through recommendations from friends and family. Developers know this, which is why you see referral codes like this in a lot of apps. It's a good way of enticing users to share the app with their friends. But while these kinds of referral codes can be effective, they're also kind of a pain to use. Is your user really going to take the time and effort to copy and paste a referral code into an email, send it off to their friends, hope those friends then find and install the app, dig up whatever code redemption screen they need to redeem this offer, and copy and paste this code back into your app? Well, maybe, but maybe not. And while you could build your own UI to help this process along with, all those spare engineering cycles you've just got lying around, this is also where Firebase Invites can help. Firebase Invites makes it easy for your users to share all aspects of your app, be it a referral code or an interesting piece of content, across both Android and iOS. It looks something like this. Let's say that your app has a referral code that you'd like your users to share with their friends, and you decide to use Firebase Invites to make it happen. When your user clicks that share button, they'll see a dialog listing all their friends and colleagues with some smart recommendations at the top. They choose which friends to share with, click send, and these invitations are sent, along with a personal message, over SMS or email, depending on the contact. their friends receive a customized, richly formatted invitation, either one you've designed yourself or one you've let Firebase Invites build automatically from your app's store listing. All this recipient needs to do is click on the Call to Action button, and Firebase Invites will take them directly to the app if they already have it, or the appropriate app store for their device if they don't. Once they're done installing your app, Firebase Invites can then send the referral code to your app through a deep link. And you can send your new customer the discount that they so richly deserve. And yes, this really does work even if that friend had to install the app first. Traditionally, deep links tend to get lost during app installs, but Invites uses Firebase Dynamic Links, which are able to survive the App Store installation process. As an added bonus, many developers have found that not only are these kind of invites more successful at driving installs, but that users who join through this kind of personalized onboarding flow are more likely to come back to your app in the future. And Firebase Invites isn't just for referral codes. You can use it to share any content you want from your app. Have a recipe app? Firebase Invites can make sure that killer lemon meringue pie recipe gets the visibility that it deserves. And because Invites is a Firebase product, it works with Firebase Analytics to let you know when a user has opened or installed an app through an invite. So be sure to check out the documentation and give Firebase Invites a try. We can't wait to see what you build.
Testing? Hi. Welcome. So I'm very glad to be here today because I can finally share with you what we've been up to at Firebase. Because today, more than ever, Firebase has the tools you need to build a successful app. I'm also excited because I kind of came to I/O this year the long way around. You see, I actually left a great job at Google 4 years ago. I wanted to dive into this app development thing and change the world with a small startup. This small startup had a unique vision. We thought that we could empower developers by letting them focus on the user experience they wanted to create and not the backend that needed to support that. And that startup, of course, was Parse. So before I rejoined Google and teamed up with the Firebase team last year, I spent 3 years in the Parse team. I'm most commonly known there as the lead developer for Parse Push, and also the type of person who was called in when there was reliability or scalability issues that tended to hit only the largest customers. I worked a lot between the backend developers and the operations team. And so I've been around the block a while and have done a number of backend services. Now, to be a little bit more somber for a second, as a former Parse team member, hearing about that shutdown hurt me physically. And to anybody who is a Parse customer in this room, I want to express my sincerest apologies. Nobody in Parse nor Firebase is happy with what's happening here today. We are not happy with the pain you've gone through. And to my former teammates in Parse, I want to express how proud I am that they have responsibly handled this tragic event. Because Firebase gave a year notice that they're doing a shutdown. They gave an open source implementation of their backend, and they've dedicated themselves to spend the next year helping customers migrate. And I think we should all say thank you for setting the bar for responsibility. So the advice I'm going to give today is generic. You don't have to have been a Parse customer to benefit from it. But I've decided to lay out the content to help people who are like me, coming from a Parse backend, understand all of the new features that are available in Firebase. We're going to start today by looking at how Firebase fits in the Google ecosystem and why Firebase can help you even if you already have a backend. Next, we're going to look at the set of products within Firebase that can help cover the feature gap between Parse.com and Parse Server. Then we're going to cover some novel features unique to Firebase that have no Parse alternative. And finally, dig deep into the internals of how you build your application to see how Firebase's approach gives you some novel new tools. So we welcome you to Google, no matter where you are, no matter what you might already be running your application on, even if it's Parse Server. Because with Google, you can build just about anything. You know, when we look at a backend service, we typically compare it to one of 4 altitudes. At the very bottom, we have an infrastructure as a service. These give us the raw building blocks that we can use to build any backend, as long as we have the time and the expertise. In Google, this traditionally means Google Compute Engine, where you have access to raw virtual machines, or Google Container Engine, where you can scale up and down Docker instances. If you'd like, you can go up the stack. You can trade off some of the operational responsibility by using a platform as a service, like Google App Engine, or the up-and-coming Google Cloud Functions. These types of products let you continue developing back-end code while not needing to worry about which servers your back-end runs on. Now, just like you handed off some of the operational responsibility to build a platform as a service, you can go the next layer up and use a back-end as a service like Firebase to hand off some of the developmental responsibilities. Because a back-end as a service provides a suite of integrated features that allow you to spend most or even all of your time focused on the client code. And we're not going to spend time today covering the last level, software as a service. But I list it here today to remind you that Google is fairly unique because we have powerful and successful products at all layers of the stack. Which means when you choose to develop with Google, you are not stuck at only one altitude. You can branch out. Imagine if you have a backend today that's written on Google Compute Engine. Odds are, if you are distributing files, you're using Google Cloud Storage to do so. Now, traditionally, if you wanted to give some of those users access to files, you'd have to create your own API server to control who has access to which files. But starting today, you can use Firebase storage, the backend as a service layer on top of the infrastructure of Google Cloud Storage. This will let you use a simple rules file to describe for your entire bucket who should have access. And it saves you the need of needing to manage and scale a service between your storage and your users. Similarly, you'll also be able to go down the stack. Today, I'm announcing that the upcoming Google Cloud Functions will fully integrate with Firebase. And you'll be able to react to changes that happen in the Firebase ecosystem as well. So this means that if you already have a backend, that's fine. And if it's at a different altitude from Firebase, that's also fine. If you've migrated from parse.com to parse server, you've gone from a backend as a service to an infrastructure or platform as a service. And if that's the right choice for your team, then I encourage you to stick with it. Because Firebase can help you no matter what your existing solution is today. Well, almost no matter what. First, we have a series of features that cover the product gaps between parse.com and parse server. These are parse crash reporting, parse analytics, parse hosting, and parse config. Firebase has products in all of these areas, so let's take a quick look at how you can recover these product areas and do more than you ever could before. First and foremost, you should check out Firebase Analytics. This is the crown jewel of the new Firebase product line, and it's a great place to start because you don't actually need to add any code to start using it. And there's no charge no matter how many API requests you send. If you have complex analysis needs, Firebase Analytics will integrate with Google BigQuery, which will let you slice and dice your data as you see fit. And Analytics sets the stage for many other integrations with Firebase products. So this is our new analytics dashboard. As you'll see, the most important feature is right up at the top. How many people are using your application? We've sliced that down into the daily, weekly, and monthly active users in your app so you can understand the depth of engagement. Next, you can scroll down and see retention cohorts. This is a fancy word for do your users keep using your app or do they get bored with it? Retention cohorts lines up your user base based on which week they started using your app. So you can look vertically down the line and see when did people stop using my app. Now, you'll also notice that this dashboard is showing results for users aged 25 to 34. Now, this application wasn't actually providing that information to Firebase. Because with Firebase, you automatically get powerful information. Without adding any code, you understand where your new users are coming from, how many of them are coming back, how long they're using your app when they do, and even demographic information like their gender, age, country, and interests, all in a free product. And if you would like, you can add extra information for analytics as well. You can describe custom attributes about your users or provide up to 500 custom types of events that you would like to send. And you can use this information to dive deeper into your groups. But if you need to compose that, you can do so in audiences. Audiences let you describe a collection of users who meet certain characteristics and who have seen certain events. You can use that audience to dive deep into a demographic in your app and understand how they use it. Or you can also use audiences to re-engage customers in your application using Firebase notifications or remote config. And like I said, you don't need to add any code to use Firebase Analytics. It's part of the core SDK. But if you'd like to add additional properties, you can say set user property string, or you can log additional events with log event with name parameters. It's that easy. So if you are like me, you occasionally write imperfect software. And one of the biggest problems I always face is tracking down what went wrong in the field. Because the first time you get a bug report, it's hard to translate what your user is describing to an actual crash dump. And the second time you get a bug report, you need to triage. Is this a new issue? Or should I save myself the time and not debug this because it's already known? When you get the third crash report, if it seems familiar, you need to figure out whether or not this is a known issue that's already been fixed, or whether that bug has regressed. And crash reporting can help you solve all three of these important problems. So in the crash reporting dashboard, you can see at a glance how many crashes are happening in your application. And there's three important metrics here. You can see the raw numbers of errors that we're managing, but we've grouped them together into clusters. Clusters are errors with similar stack traces and likely have the same root cause. This can greatly help you triage and dive into the individual reports that you see. You can also triage by how many users are impacted by these crashes. Now, when we scroll down into clusters, you can see that we have detailed information. You see the stack trace, the latest version that this app is crashed for. But you can also dive into every single error that was reported. And these reports have detailed information. You can understand what device was running this app. You can understand whether that device was jailbroken. You can understand how much memory was available in the app or what country the app was in case you're debugging maybe network issues. You can understand whether it's on Wi-Fi or cellular. And one great feature for Android is that you can report non-fatal errors as well. So you don't have to wait for a crash to start improving your stability of your app. So crash reporting also comes without code by default. It's part of the core SDK on Android. And in iOS, you just have to add the crash reporting pod. However, you can make your life easier if you'd like to add a little bit of code. First, Firebase crash.log will add a log line that only shows up in a crash report. It doesn't show up in Logcat. If you want it to show up in both places, you can do that with Firebase crash.logcat. And to report a non-fatal error, Firebase crash.report. Now, if you have an existing backend, odds are you already have a server that is able to host web content. I still recommend that you check out a dedicated hosting service because it can make your life much easier. With the Firebase hosting product, you can use a simple command line tool, which is Firebase deploy. You deploy an entire copy of your static website. If you've screwed up and there's an issue, you can safely get back to a well-known version using Firebase rollback. But you can deploy with more confidence because the Firebase command line tool lets you host your website on the same, or locally, with the same software that we use in our infrastructure. And Firebase hosting is fast because it automatically integrates with content delivery networks to make sure your website is delivered quickly across the globe. And it's secure. We are SSL first. We manage all of the certificates that you need to handle to serve secure content. You just give us files, and we give you a fast, secure network. Firebase hosting is so easy to use, I actually struggled to come up with the follow-up slide here. So instead, I decided to give an announcement. Starting today, Firebase hosting supports custom domains absolutely free. Now, our final product gap between parse.com and parse server was parse config. And Firebase Remote Config is such a powerful product that I'm really happy to share it with you today. Because sometimes you need dynamic content in your application, but the database isn't really the right place to put it. Firebase Remote Config lets you store dynamic content just like parse config did, except you have the ability to target what you are sending according to the demographics of your user. You can send different configs to different people. So imagine you've written a newspaper app. Newspapers of old had headlines, and so we're going to add one into our application. Well, that headline is meant to drive engagement, and we'll do so with relevance. With Firebase Remote Config, you can target national breaking news to users who are in a particular country. If you have multiple headlines, you can do a tested rollout and use %rollout to do A/B testing to see whether or not the new headline is driving the engagement you expect. If you're a multilingual product, you can add translations in your remote config by providing a different config based on the language of the device that is accessing it. And if you have particular interest groups within your newspaper, those will probably be in analytics. You'll probably have an audience for people who love snowboarding or who love Google. So you can post all of your I/O news headlines to people who are in the Google lovers audience in Firebase Analytics. And using remote config is very easy. There's 3 things you need to do to get started. First, you want to provide offline defaults. These will be used either before your initial request or any time the cached value is too old to be usable. Next, you can tell remote config to fetch or fetch with expiration duration. And this will make sure you get a fresh copy of remote config if it has expired. Now, finally, once remote config has accessed the newest copy, it doesn't automatically make it available. Because it would be pretty bad if you started configuring your app with one set of config values and then continued without knowing there was an update in between. The line activate fetched helps you coordinate copies of remote config with how your application flows. Once you have the latest copy of remote config, you can use that same object just like you would a dictionary. Use bracket syntax and access any property by name, and you'll get a wrapper object back where you can get strings, ints, bools, whatever you'd like. So these features helped us gain parity from parse server back to what we used to have in parse.com. Now, before we go on to the things that are the core of your app, where you might need to choose between one backend or another, I want to give a brief shout out to some very novel features that are unique to Firebase. First, we have dynamic links. Dynamic links are like URLs for your application. They can share the location of content deep within your app. They work even for users who don't have the app installed yet. Shazam has been investing in dynamic links recently by partnering with Coca-Cola to print them on their bottle so you can get a warm welcome for users who want to try out the application. Now, in case you are not fortunate enough to be partnering with Coca-Cola, we have another product for you. With Firebase Invites, your users can send these dynamic links to their friends regardless of whether or not they're using your app. And then you can improve organic growth in your application with app indexing. App indexing allows the Google search engine to crawl the dynamic links in your app and provide deep links into your app's content in Google search results. Now, since, like I said, I am fallible and many of you are probably as well, we have Firebase Test Lab for Android. This will let you automate your app on many physical devices owned by Google, so you can get much broader test coverage without having to buy every Android device that comes out. You can increase paid growth in your application by using the new integrations with Google AdWords, so that once you've identified a group in Firebase Analytics that is more likely to engage in your application, you can target your ads to that demographic. And you can earn money in your application by using Google AdMob, which will host advertisements in your application. So now the meat of the talk. Because the remaining products are more central to the way that you build an application. Notifications, authentication, and data. So they deserve a deeper look. First and foremost, as I've said, notifications have a special place in my heart. And Firebase has two products in this sort of area. Google Cloud Messaging is now Firebase Cloud Messaging. This is the product that provides a low-level service for sending content directly to an app, for pushing data to it. It is still freely available, accessible from the same APIs, and is the platform that other providers like Parse or Urban Airship already use today to reach your devices for their push platforms. Nothing in Firebase Cloud Messaging requires you to use other Firebase services. On top of that, we've built Firebase Notifications. This is the set of products that will help you use the information you've gained from Firebase to more accurately target your users and to create notifications for those users. So let's look at the new dashboard. Obviously, a notification composer should let you type in a notification. You can also schedule that notification to be sent now or later. You can schedule it either to be now, an exact time in the future, or a time relative to the user's device. If you have that news application, you can schedule the push to be sent every morning at 8:30 at the user's time zone. But the real power of Firebase Notifications comes from its targeting framework. With Firebase Notifications, you can use all of that rich knowledge you've learned in Firebase Analytics to target your users however you'd like. You can target your users with the audiences you've created. If you're more of a parse push-to-channel person, then I recommend checking out topics. They're the same general concept. You subscribe to a topic, and then you'll receive pushes sent to that topic. The main difference between push-to-channel and using topics is that topics is about 50 times faster. And then finally, if you're testing an individual device, you can use this console to target just your device so that you can be confident you haven't just sent hello world to your entire user base. I have seen that happen, actually. It's not the greatest page to get. Also, Firebase Notifications integrates with Firebase Analytics in both directions. You can use analytics to decide who you want to engage, and you can use analytics to measure whether or not you successfully engage that audience. We automatically measure how many pushes were sent and how many were opened, but we will also be able to measure a conversion event if you apply one. In this example, we have asked the users to look at a new talk. Our goal here is that they will star that session, that they will add the talk to their favorites. And if you do so, it will show up in our analytics funnel. To understand more about Firebase Notifications and Firebase Cloud Messaging, check out these two talks. We have GCM is now FCM, which covers that foundational technology. And on top of it, we have Firebase Notifications, everything you need to know in 45 minutes. Now, I am going to give a lot of shout-outs to different talks. I will post them all in Spaces afterwards, so you don't need to go take pictures of every single slide. Firebase Auth describes who's using your app, something that we're very familiar with. But Firebase Auth gives you the ability to connect with all the same authentication providers you're used to and expect, and more. More importantly, Firebase Auth allows you to provide your own backend service to control your own authentication, and it will be treated as a peer to our providers. This means with Firebase Auth, it is so powerful that you can actually implement login, where you log into Firebase using a parse session token. Now, for any service, if you have parse server, which is going to stay around, that might be a fine strategy. If you are on parse.com, I recommend that you use a migration from the client side. When someone tries to log in, you'll try to log in against Firebase. If that doesn't succeed, but does succeed against parse, you now use those credentials that you still have in your app to create a new user in Firebase and then migrate the record from parse user over to your Firebase database. Now, Firebase sessions have the same power of parse sessions, except we've used cryptography instead of a database. Because the session token in Firebase includes all the things that you would have had in your PF session object, except it's encoded and signed by your app's private key. This means you can know for sure that the session is valid, which user it applies to, when it's supposed to expire, and any custom claims you have from your personal auth service. Rules like this particular session is from an IoT device and therefore should have restricted access. These can all be verified directly on the session token without having to make an extra API request for every call that you make. And Firebase Auth integrates with Firebase rules. See, in a system like parse, every object describes its own access control. And as an app administrator, this can lead to uncertainty because you can't actually audit the access control in your system unless you read through your entire app's contents. Even worse, if you need to update information or security in your application, if you need to give admins access, you would have to do a full data migration of your entire application for this to work. Instead, Firebase Auth and Firebase security rules allow you to describe in one file the rules that should be applied to entire systems, your entire Firebase database, or your entire Firebase storage bucket. And you can know with confidence that these rules are applied everywhere. So you can learn more about identity and authorization in Firebase with 3 key talks. First, there's the key to Firebase security. This will go over the languages that you'll use to secure the real-time database and Firebase storage. Next, to focus on the actual login experience, we have best practices for a great sign-in experience. And one talk I'll pitch a few times is Zero to App, developed with Firebase. This talk combines auth, the database, and storage to create 3 apps with live coding. We'll have someone live coding at all times for iOS, Android, and web, so nobody's left out in the talk. Now, next, there we go. If you have large blobs of data, a database is not the right place to put it. So for blobs of rich data, we have Firebase storage, the Firebase layer on top of the petabyte scale Google Cloud Storage product. Now, if you look at our dashboard, the first thing you'll see in our dashboard is that Firebase storage is actually a standalone product. You can look at your files here. You can modify them, upload them, and you don't need to wrap your files inside other objects. Also, you'll notice that we have a Rules tab. Firebase files are secured themselves, not just objects that point to them. This means that the data you store is secure, even if the URLs leak out. And you can delete files directly. There's no more garbage collection required. And there's no more 10 megabyte limit for the files that you use in Firebase storage, because Firebase allows you to do download and upload resuming easily. Now, Parse has not yet decided the migration strategy for parse.com and parse files. But there is a GitHub Wikipedia page, which I will post in the spaces after this talk. On the other hand, there's very good news for Parse Server users, because Parse Server already has a plug-and-play adapter for parse files. And you can use Google Cloud Storage. There's an official node module. And since Firebase is built on Google Cloud Storage, it's reverse compatible with all of those same APIs, which means you can use one backend to have data that is both a parse file and Firebase storage. Now, they say you save the best for last, so let's cover the Firebase real-time database. This is the original Firebase product, and it's why 470,000 developers trust us today. The Firebase database started years ago by letting go of preconceptions of how a database needs to work. We don't need to have unstructured data just thrown in some collection. We can lay out our data to match the way we plan to present it in our application. And we don't need to restrict ourselves to just some RESTful interface. REST is nice because it's easy to think about, so Firebase does support REST for the real-time database. However, we believe that being a drag to refresh just doesn't cut it. Dragging to refresh is going to be as old tomorrow as clicking refresh to check your email is today. So, while on other systems, you might have to save an object, have a Cloud Code trigger, send a push notification, have that show up in your device, issue a new query, update your UI, realize that not everybody has push notifications enabled, so then also have a poll loop which damages your battery life and isn't very responsive. So add extra UI that allows you to override it with pull to refresh. We thought we had a better idea at Firebase. Let's just make the data sync. Describe the data you want, and it's pushed to devices in milliseconds. So the way we've done this is by restructuring how we show data. Data in a Firebase database is built like a giant shared JSON document, or a giant tree. And you can point to any node in that tree and say, I care about this. Once you've said you like to listen to a point in the Firebase database, any changes to that will be intelligently streamed down to your device. Now, this requires us to have an unfamiliar structure, but you can see some familiar concepts show up. If we look at the first top-level keys here, they're presentations and presenters. Now, these are the names of collections, which should sound familiar. Your first concept in most databases is your table or your class. And it's the same way in Firebase. So next, underneath the presentations collection, we'll see some gibberish, some numbers. More commonly, you'll see random strings. This is how you have a list of objects in Firebase. We have a tool called a push ID, which will generate a random string based on the server's timestamp. This allows you to insert data into Firebase and insert data into a list while avoiding collisions. With this type of layout, though, you can consider these to be the object IDs in our collection. And underneath these object IDs, you'll see that all the next keys have the same structure. These are our objects in our document object model. Now, some of these keys make sense. Location, title, and time are just strings. This last one is a little bit curious. It's a bit nested, it's structured. Well, what is this? The first key is that title, presenters. Because if you remember, that was the name of our other namespace. And remember how I said that lists of numbers or garbage strings are arrays? This is the name of a namespace being mapped to a key or to an array of inlined. Well, if we scroll down, we'll notice that presenters has a child named inline. This is how we can structure relational data in Firebase. We have the name or value of one key pointing to basically a template parameter or the location inside the database somewhere else. And that's how you can use that one reference to have a list of objects or a list of pointers to objects elsewhere in the Firebase database. So this is a new and novel approach. I know it might seem a little intimidating at first. So I wanted to share a case study from Skyscanner. Skyscanner is a very popular travel app in Europe. They have over 5 million monthly active customers. And they had built a modern web app, or sorry, a web mobile app, and they wanted to know how they were doing. So they had this feature here where they would ask the customer, how happy are you? If the customer was happy, they'd invite the user to share their feedback on the App Store or share the app with their friends. If the feedback was negative, they asked for feedback directly. So this was on another backend, and they decided to try out Firebase. They said it took them 10 hours to rewrite this whole feature using Firebase. It took them 2 days to test all of their integrations with the new Firebase products. And it took them 2 weeks to fully roll out their entire new code base. What did they say about it? It was easy to switch from the legacy solution. The web API is pretty mature for the real-time database, and it's incredibly easy to use. So I'm going to lightning fast go through some strategies of migrating data, because these are fundamentally different. They're structured differently. Typically, we talk about a background sync. You have your old app. You build a new app in a clean room. You might need some type of transformer logic, but you can use that to load and import. You can use that to test your new app with a snapshot of old data. You can drop that data if you want and restart. Next, you need to restart again and do syncing with your backend to make sure that when you have these two copies, they don't diverge. This is a bit of a challenge because you need to sync at the same time as your import, so it can't overwrite old data. I've written some cloud code for you that I'll share that can help you do these types of migrations. But the other option you can do is just take your app and put it into read-only mode while doing your initial sync, and then start your synchronization afterwards. The other option is a double write. You start with your old app, and you connect to a new database with an app that has access to both copies. First, you treat your old database as the source of truth, and you might do a backfill of data in the background. As features become available or fully migrated, you can change your source of truth to be the hybrid app, or sorry, to be the new backend. Eventually, your old app stops being used. You can clean up your dependency on the old backend, and then write your new app. So like I said, I'm going to be sharing, there's 2 sessions to dive in deeper. Deep dive into the real-time database, and zero to app develop with Firebase. So today, we've shown you how Firebase is a suite of integrated products designed to help you develop your app, grow a user base, and earn money. We've covered how Firebase fits in the Google ecosystem, how you can add some novel tools to Firebase, or from Firebase, and how Firebase's approach to to building an app gives you novel advantages. So remember, migrating to Firebase doesn't need to mean migrating away from something else. We've shown you how the Firebase tools can help you solve problems in ways you haven't been able to before. What's next? We have the rest of Firebase.com, or firebase.google.com. Join online. I'd love to hear what you've been doing, what you love about the new Firebase, and how we can improve. So thank you very much on behalf of myself and my partner, Silvana, who wrote the migration guide. I will be spending the rest of my time out in the tent, or I'll be at all of the afternoon sessions at I/O. Thank you.
With the dataset, we're ready to train a classifier. But before we do that, first we need to split up the data. I'm going to remove several of the examples and put them aside for later. We'll call the examples I'm putting aside our testing data. We'll keep these separate from our training data. And later on, we'll use our testing examples to test how accurate the classifier is on data it's never seen before. Testing is actually a really important part of doing machine learning well in practice, and we'll cover it in more detail in a future episode. Just for this exercise, I'll remove one example of each type of flower. And as it happens, the data set is ordered so the first setosa is at index 0, and the first versicolor is at 50, and so on. The syntax looks a little bit complicated, but all I'm doing is removing 3 entries from the data and target variables. Then I'll create 2 new sets of variables, one for training and one for testing. Training will have the majority of our data, and testing will have just the examples I removed. Now, just as before, we can create a decision tree classifier and train it on our training data. Before we visualize it, let's use the tree to classify our testing data. We know we have 1 flower of each type, and we can print out the labels we expect. Now let's see what the tree predicts. We'll give it the features for our testing data, and we'll get back labels. You can see the predicted labels match our testing data. That means it got them all right. Now keep in mind this was a very simple test, and we'll go into more detail down the road. Now let's visualize the tree so we can see how the classifier works. To do that, I'm going to copy-paste some code in from Scikit's tutorials. And because this code is for visualization and not machine learning concepts, I won't cover the details here. Note that I'm combining the code from these 2 examples to create an easy-to-read PDF. I can run our script and open up the PDF, and we can see the tree. To use it to classify data, you start by reading from the top. Each node asks a yes or no question about one of the features. For example, this node asks if the petal width is less than 0.8 centimeters. If it's true for the example you're classifying, go left, otherwise go right. Now let's use this tree to classify an example from our testing data. Here are the features and label for our first testing flower. Remember, you can find the feature names by looking at the metadata. We know this flower is a setosa, so let's see what the tree predicts. I'll resize the windows to make this easier to see. And the first question the tree asks is whether the petal width is less than 0.8 centimeters. That's the 4th feature. The answer is true, so we proceed left. At this point, we're already at a leaf node. There are no other questions to ask, so the tree gives us a prediction, setosa, and it's right. Notice the label is 0, which indexes to that type of flower. Now let's try our second testing example. This one is a versicolor. Let's see what the tree predicts. Again, we read from the top, and this time the petal width is greater than 0.8 centimeters. The answer to the tree's question is false, so we go right. The next question the tree asks is whether the petal width is less than 1.75. It's trying to narrow it down. That's true, so we go left. Now it asks if the petal length is less than 4.95. That's true, so we go left again. And finally, the tree asks if the petal width is less than 1.65. That's true, so left it is. And now we have our prediction. It's a versicolor, and that's right again. You can try the last one on your own as an exercise, and remember the way we're using the tree is the same way it works in code. So that's how you quickly visualize and read a decision tree. There's a lot more to learn here, especially how they're built automatically from examples. We'll get to that in a future episode, but for now let's close with an essential point. Every question the tree asks must be about one of your features. That means the better your features are, the better a tree you can build. And in the next episode, we'll start looking at what makes a good feature. Thanks very much for watching, and I'll see you next time.
So constraints. They're a great way for you as a developer to deal with the ever-expanding number of screen sizes, device rotations, and new form factors like slide over in the iOS world. But one unfortunate casualty in this brave new world of alignment has been the way we animate views. See, it used to be we could go around setting a UI view's position or frame with a fun little UI view animate with duration method and watch our view scoot around the screen. Oh, that was fun. But that's harder to do in a world full of constraints. Constraints don't necessarily play nicely with a view whose frame you're setting explicitly, as you can see here. Well, that leads us to this episode's quick tip sent in by Jacob Cho, a fan of Route 85 and a software engineer at Ensemble, a mobile app developer located in beautiful Vancouver, British Columbia. Jacob notes that many iOS developers forget that in addition to the old way of animating a view's position, you can also animate constraints in iOS. Let's look at how you might do that. Here's my storyboard, and as you can see here, I've got everything set up nicely using constraints. Now to move my UI image view on and off screen, I'm going to want to change this constraint here, the one that sets my image's leading edge to the leading edge of my super view. Right now it's set to -180, so it's off screen. So first I'm going to control drag from this constraint into my view controller to make it an IB outlet of type NSLayout constraint. This allows me to access it in my code. Now I can adjust it with a standard UI view animate with duration call. In this case, I'll change the constant of the constraint from -180 to 0 so that it appears on screen, and now we can give it a try. Well, that's weird. The constant definitely changed, but what happened to my animation? Well, it turns out to get this constant to animate nicely, I need to call layout if needed on my view controller's view within this animation block. We'll give it one more try, and that's much better. I now have a constraint that I can change within an animation block, and everything animates smoothly to its final position, except in cases where I want to adjust something besides my constraint's constant. Let's take a look at another example. Here, I want to adjust this center square to expand or shrink to be either twice or half the width of its neighbors. Now, I could do that in theory by adjusting the multiplier on the center view's width constraint, but it turns out that changing that multiplier in code doesn't work. See, constraint multipliers are a get-only property, and Xcode will give me an error. So how do I change it? Well, the answer is I don't. Instead, I create two completely different constraints and enable or disable either one as necessary. As long as I'm still calling layout if needed in my animation block, this kind of change will still animate. Now, there are two ways I can accomplish this constraint swapping. One way is to create both constraints in Interface Builder, like so. Now, Xcode will complain that these are incompatible, and it's right. So first step, we'll uninstall one of them by checking this box here. Next, we'll control drag both of these constraints into our code to make them IB outlets. And then I can enable or disable these as necessary in my animation block, like this. Once again, you'll notice I make sure we're calling layout if needed in our animation block, and we end up with a nice smooth looking animation. Look at that. The other way to accomplish this would be to create a completely new constraint in code. This is useful when I don't know in advance what I'm going to want this multiplier to be, and I need to create it dynamically. So let's see that in action. This time in my animation block, I'll first remove the old constraint. Next up, I can create a new multiplier. Let's make it slightly random just for fun. Ooh, hey, that is fun. OK, next I'll create a brand new constraint with this new multiplier and assign it to my center view width property. And then I can add it back in again to my view. Finally, I call layout if needed on the super view in the animation block, and I once again have some nicely animating views that use this new constraint that I've created. And because this is all done using constraints, you'll notice this works as intended on an iPhone in landscape mode, or even, say, a slide over view on an iPad. And once you understand that this trick simply involves removing an old constraint and adding a new one, you might discover a whole new world of animation is available to you simply by turning on and off various constraints. For example, on this screen, I can change all my views to be either left aligned or right aligned, simply by adding and removing two different groups of constraints, and then calling our now familiar layout if needed method. Pretty neat, huh? Oh, by the way, one fun little quirk about all this, if you add your new constraints before you remove the old ones, iOS will complain about all the incompatible constraints it has to deal with in those few milliseconds. So always make sure you remove the old ones first before adding the new ones. So thanks to Jacob for the quick tip. Jacob, you're going to get a very stylish Google t-shirt in the mail. But hang on, we're not done yet. You see, now that you know all about constraint animation, I have a couple more quick tips from one of Google's engineers about more efficient ways to implement it. So follow me on to the next video, because we're not done learning just yet. Click here, click here. And otherwise, I'll see you on Route 85. Bye.
People love to use different mobile devices in different ways that suit their situation and lifestyle. Michael uses a phone to play games on the go, while Tony enjoys using a large tablet as he relaxes on the sofa. And Jen carries a small tablet in her purse for reading on the bus. But they all want to use your app on the devices they prefer. So you'll want to make sure they each have a great experience, regardless of screen size, OS version, and the features of the app they use the most. It can be taxing to test each one of these situations so that all your users can be happy. We know you'd rather not have to buy and store stacks of devices and test your app in all these circumstances. That's why we built Firebase Test Lab for Android to make it easy and affordable for you to test your app with a variety of devices and be sure it works great for all your users. Our device lab, hosted in the cloud, offers a variety of physical devices ready to test your app. The selection of devices is always growing, so your tests will stay current with the latest hardware and operating systems. The easiest way to use Firebase Test Lab is to run a robo test. This is an intelligent, automated test that crawls your app to discover and exercise its features. You won't need to write any additional code to make use of a robotest. For more advanced testing, you can also script the interactions with your app to simulate specific use cases and verify that everything works as expected. Test results include a detailed report for each device used, including screenshots, device logs, and any crashes that may have occurred during the test. This allows you to verify that your app is working correctly on the variety of devices and configurations you selected. It's easy to make Firebase Test Lab a part of your daily development routine, and we have multiple ways to help you test regularly and spot errors early. First, you can use the Firebase console to upload and test your app. There is also a command line interface for testing with continuous integration servers, so you can automatically test every build. During Android development, you can deploy your app directly to Firebase Test Lab using Android Studio 2.0. And finally, in the Play Store Developer Console, there is a special automated launch test that will run for Android apps published to an alpha or beta channel. To get started using Firebase Test Lab and learn how to regularly test your app on different devices and configurations, you can start with the documentation available right here. Happy testing!
Yeah, no pressure whatsoever.
Hi, everyone. My name is Ahmed. I'm a product manager at Firebase Test Lab, and I'm joined with my amazing colleagues here.
Fergus Hurley on the Google Play Developer Console team.
Ali, I'm a product manager on Firebase Crash Reporting.
Michael Bailey, Android engineer at American Express.
And I'm Jordanis from Shazam.
Hi, and we'll be talking to you about the different tools that Google provides you to be able to ensure the quality of your apps during testing and monitoring. Now, we all know that quality is really important for us. We're going to be hearing this plea throughout the conference today. We want you to be able to build the best possible apps, build a great user base, and be able to monetize your apps. And to ensure you build the best possible apps, you need to ensure your quality to be able to make your apps successful. In fact, more than 51% of the one-star reviews that we saw on the reviews on Google Play that we were able to classify are related to quality issues. They are bugs and crashes. Data is clearly showing us that we need to make sure that these quality issues are resolved. And in this talk, we'll be talking to you about the different tools that Google offers to be able to manage your quality throughout the life cycle of your application development. Starting with Firebase Test Lab, which allows you to manage the quality of your application during development, to the Play Launch Report, which was announced today. And it's going to allow you to manage the quality of your app during the release process. And then finally, Firebase Crash Reporting, which was also announced today, which is a cross-platform product that allows you to collect your crashes on Android and iOS, prioritize the most important and most impactful crashes, and resolve them really quickly so that they don't affect your users. Now, many of you probably heard about Cloud Test Lab, which was announced last year at Google I/O. We're now proud to say that we're part of the Firebase family. You guys all heard of Firebase today. This is the most amazing Google developers product that was ever released. It's basically all of the amazing Google tools in one convenient location, and Firebase Test Lab is now part of that suite of tools. So Firebase Test Lab is your first stop to manage your quality during the development process. With Firebase Test Lab, we want you to make sure that your app works well on devices that your users have. And that's why the first part to get started is the infrastructure. This is an actual photo from our device lab. This is devices running in our data centers that we're hosting them from different manufacturers, different API levels, different form factors. Our goal is to make it easy for you to access any of these devices at any time, so that you don't worry about building your own infrastructure, or don't worry about just buying more devices. We got that covered for you. You just build your app, and we run it on this amazing infrastructure. And then the second part of Firebase Test Lab is how it easily integrates with your development workflow. All you need to get started is a web browser and your app. And you can upload your app to the browser, start your test, and go from there. We also built an integration with Android Studio, so that you can run your tests during development in Android Studio. And then finally, we built a command line interface that you can use from your continuous integration environment. If you use Jenkins, you can see the instructions on our developers' documentation. And then also our amazing community built for us instructions on how to use it using Circle CI and TeamCity. So all of these docs are available, and we're adding more and more. And then we all acknowledge that many of us developers think that writing test code is something we don't want to invest in from the very beginning. And this is why we built this amazing Robo crawler. This crawler launches your app and clicks on buttons and navigates through it as if a normal user would do. It builds an activity map that visualizes all the paths in your app that lead to a crash. Now look at this. The Robo is actually able to navigate through the iOS 16 app that you guys have. It's logging in using Google right now, and it's bypassing a login screen, login using Google. And then it was actually able to find a crash near the end. And it gives you the full path leading to the crash so that you can resolve all of these issues. Now, no matter how smart this Robo is, it probably won't be able to guess your custom login credentials. So that's why we're building the Espresso test recorder in Android Studio, so that all you need to do to write your first test using Espresso is launch the app on your phone. Use it as if you use it on a regular basis. We capture all the interactions that you do, and we build a fully reusable Espresso test script for you. This is the fastest way to get started with covering the most important scenarios you need to worry about in your application, the most impactful user journey, cover them with test cases. And then every new change that you add to your code, make sure that these scenarios don't break. These are the most important scenarios in your app. You shouldn't break them by any change. And then finally, Firebase Test Lab provides you with a full report that contains logs, screenshots, stack traces, and a video that allow you to fix any issues in your app and resolve them and go back to a green state, basically. So I mentioned that Firebase Test Lab is basically Cloud Test Lab, which was announced last year at I/O, but it's basically now it's part of the Firebase family. And we're proud to say that we worked really closely with our partners, with our developers, and they helped us shape the product. We ran over 1 million tests on our devices infrastructure, and we believe we can add much more than that. Here's Foursquare. They are telling us how it was easy for them to integrate Firebase Test Lab into their workflow. They didn't need to build their own device infrastructure. They just used Firebase Test Lab. Also, our friends from KKBox, they were able to, just with the Robo, just by crawling their application, they were able to resolve issues on launch on their devices that they would have never captured it otherwise, and it would have affected their users. And now I want to introduce Michael Bailey from American Express. Michael and I did a talk previously at DroidCon SF 2 months ago, and I'm really proud to be doing my second talk in a row with him. Michael is a very, very respectful and highly influential in the Android community, so I'm going to leave it up to him. Yeah. Oh.
Thanks, Amin.
So we have an American Express Android app. We wanted it to be high quality. When tools like Espresso came out, we started writing UI tests to verify that the app did what we wanted it to do. To make sure that those tests were always passing, we set up a physical device farm. It started on my desk with a bunch of devices connected to a Mac Mini so that we can run Jenkins and we can run all of our tests for every branch and every pull request. We ran all the tests to make sure we didn't introduce any defects. Well, that was fine when we had a small number of tests and we didn't have that big of an Android team. But Espresso made it easy to write tests. So we wrote more of them because they helped us increase our quality. But then we needed more devices. And we had problems hooking so many devices to a Mac Mini, so we had to buy more Mac Minis for more Jenkins slaves. So this grew and grew and grew. And we got more engineers, which means more pull requests, which means more tests to run on our infrastructure. A constant refrain at our daily stand-ups was, I can't merge my change because the builds aren't passing, because this device is giving me problems. Can you go unplug it and replug it and with USB to get the test to run? So it was becoming a maintenance burden for us, and it was just a daily refrain and a daily pain in our process to run these tests and make sure that they were always passing. So it was taking a lot of engineer time. It was taking a lot of hardware to run all these tests. Well, last year at Google I/O, I heard about what was called Cloud Test Lab, now Firebase Test Lab for Android, about how I could run my tests on devices provided by Google. So I contacted them. I asked them for early access. Last July, Ahmed and team came to our office. They got us set up with Cloud Test Lab. And then by August, we had decommed our own physical device farm, and we were running all our tests on Firebase Test Lab. This, no more did we have our daily stand-ups, the complaints about running all of your tests and then getting to that last one and it just fails and you have to start the job all over again. We were able to add more engineers and add more tests without having to worry about how are we going to get more devices. Is this just going to slow down our whole process? So by switching to this, we got more productivity. We were able to get early access to this tool, and we have a lot less maintenance. We can actually focus ourselves on writing the tests and with making a high-quality app that our card members expect. So now I'm going to turn it over to Fergus from the Play team.
Thanks, Michael. I'm very excited to be here today to announce the pre-launch report as part of the Play Developer Console. So as Ahmed talked about, when you're in the development lifecycle of building your app, you should be testing it using Firebase Test Lab for Android, using Android Studio integrations, Jenkins plugins, and the command line. But then when you're just about to release your app to the 1.2 billion monthly active Play users, you want that one last sanity check. Did I fix all those issues? Is my app ready to be shown to that many users? How does my app look across all these devices? And that's where the pre-launch report comes in and shines. So before I go into what is actually included in the pre-launch report, hands up if you have an app on Play today. All right, awesome. Keep your hand up if you tested that latest version that you pushed to all your users on more than 10 devices. All right, I'm impressed. Keep your hand up if you were able to get those results within an hour. OK, well, very impressive guy over here. And I'm going to show you how you can all keep your hand up when you ask that question in the future as a result of the pre-launch report. So the pre-launch report is powered by Firebase Test Lab. And it includes 3 parts today: crashes, screenshots, and security. In the crashes section, we show you the results of the robo that Ahmed described interacting with your app for about 5 minutes across 10+ physical Android devices. And we show you if there was a crash, we show you the stack trace, the logcat, the device spec, and a video of the robot interacting with the application. And so this really helps you be able to get to the problem that the app has and be able to solve that crash. As you can see with this app developer, their first version they uploaded as part of the pre-launch report had a lot of issues. Then as they kept releasing new versions, they fixed the issue. And then they, with their final version that they've just pushed to the alpha and beta channel, they've identified 2 new crashes. And they can be able to solve those. So we know that no developer in this room would ever have a crash happen in their app. So we've decided to launch the screenshot section, which helps you with the usability issues with your app. And this is really powerful when you have green results as part of your pre-launch report. So as part of this, you can see what your app looks like across the different Android devices, different Android versions, different screen resolutions, screen sizes, and even languages. So you can see what your app looks like in right-to-left language Arabic, in the emerging markets, Hindi, or in languages that have long strings. So for example, here you see that in German, there's an issue with the layout of the text. And this really helps your design team be able to catch those issues before it's pushed to all your users. Great. The last part of the report that I'm going to tell you about today is the security section. This is where we put Google's security team to work for you. This is where we have the known vulnerabilities that we detect in your application identified, and we give you the information to be able to help you solve that issue before you release it to all the users on Play. So how do you get access to this pre-launch report? You just go to the Google Play Developer Console, click on the pre-launch report tab, which replaces the Cloud Test Lab tab that used to be part of the Play Developer Console, and you will then have it, when you click on that tab and opt in, that the next APK you upload to the alpha and beta channel will have this report generated within 1 hour. We've already found that 60% of the top 1,000 apps on Google Play already use the alpha and beta channel. And if you didn't have a reason to use it before, now you do. So we really encourage you to do that. Great. Thank you very much. I'm going to hand over to Ali to talk about Firebase crashboarding.
All right. Thank you very much. Thanks, everybody. We have also launched Firebase Crash Reporting today, and we're super excited about it. So thanks so much for being here. Along with Test Lab and the pre-launch report, we really think that crash reporting completes our vision for app quality. While Test Lab focuses on the development stage, and while the pre-launch report focuses on the release stage, crash reporting focuses on production. It focuses on that stage where you have actual users coming into your app, interacting with your app. And the objective here is to give them the best possible user experience. And this is not exactly the easiest thing, right? When you think about the mobile ecosystem we live in, there's many variables at play. We have multiple operating systems. We have many different OS levels, API levels, different device manufacturers, different device models. The list of variables just goes on and on. And the combination of all these things can be just too much to handle within testing alone. But you need to have something in production, because losing users that happen to be on a device that wasn't tested or happen to go through a user path that wasn't accounted for is just not acceptable. Every single user is as important as every other user. And that's exactly why we introduced Firebase Crash Reporting. So what is it exactly? Crash Reporting is an SDK that supports both iOS and Android. You get it packaged into your app, you push it to production, and it detects information about the errors that your users see. It aggregates this data, and using the Firebase console, you get to see details about it so that you can be on your way to fixing these issues faster than ever. Setting up is really easy. If you're on Android, you grab the Cradle plugin. If you're on iOS, install the pod, add one line of code to initialize Firebase, and off you go. You have errors running. And when you actually push to production, and you start seeing errors coming in, when they first come in, they start looking something like this, right? They're all over the place. Some errors come from some devices, but not the others. Some errors come from specific user paths that weren't accounted for. And the first thing we do with this data is we cluster it. So it looks something like this. We group these errors by having them in buckets of similar stack traces. And what that does for you is a couple of things. First of all, it allows you to get a sense of how many unique issues you have in your app. And the other thing is that you get a sense of prioritization. You understand for each cluster of errors, is it a fatal error or a non-fatal error? You get a user count, and you get a number of occurrences, so you understand the severity of that issue. Our friends in Skyscanner have been using this for a little while. And using clustering, they were able to identify a couple of out-of-memory issues, and they cut down their crashes by 30%. So think about this when you work on your own app, the amount of gain that you can have with such a simple action. OK, so now you've identified through clustering what you need to work on. The best part now is actually fixing the issue, right? So this is where the Firebase console comes in. We give you a lot of data, a lot of information, basically everything that you need to identify the root cause of the issue and get it done in no time. The first thing you see is a top-level breakdown of metrics. So we'll tell you obvious things like the exception name in Android or the crashing signal in iOS, but we also tell you things like a breakdown of the app version so that you can understand if your latest app version in production is doing better or worse than the previous ones. We'll also give you a breakdown of the operating systems or operating system levels, a breakdown of the devices, and so on. And the idea here is that you're quickly able to attribute the errors to some factors and eliminate other factors. The next thing we give you is the stat trace, which is probably the most important thing. We support symbolication on iOS and deobfuscation on Android, which means that you get to see everything down to the line number. We even highlight that frame in the stat trace that belongs in your app so that you can jump into the problem right away and not waste any time. Additionally, you get comprehensive device diagnostics. And this is important for a couple of things. But let me first tell you what you get. Some of the things that we give you are the amount of RAM and disk space that are available on your device. You get things like, was the device in landscape or portrait? You get the timestamp of the actual error, API levels, basically everything you can think of that is set on a device. And you get to actually go through instances and see what the device of that user was like at the moment the error took place. And this is pretty important, not just because you get to fix the issue faster, but you also get to save time on customer support because you don't have to go do that back and forth with your users so that you understand what the device was like at the time of the error. Everything I've talked about so far is about creating a snapshot, an accurate snapshot of the issue. But what happens when you have multiple ways that can lead you to the same point in the code, which happens often? For that, we have an API that allows you to log custom events. We, out of the box, log some events for you, such as when the crash actually takes place. But then you get to interlace your own custom events with it so that you can get to read your errors kind of like a story. So I called my backend API, I got some data back, and I populated my UI model, and then boom, a crash happens. So reproducing that crash becomes that much easier. Over the last couple of months, we've had the great pleasure of working with our friends in Shazam. They've been kind enough to test our product and give us great feedback and make it much better. And today, I'm really, really happy to have my friend Jordanis from Shazam, who leads Android development. And he's going to tell us a little bit about it. So, Jordanis.
Thank you. Top points for pronouncing my name correctly, so that's good. I've seen a lot of excited people about Firebase today. For Shazam, that excitement started a couple of months ago when we were first contacted by the Firebase team. At Shazam, we deeply care about how users perceive the quality of the app, and we know that it's hugely correlated to the stability of the app. So because installation was so easy, we decided, and some of the features that Ali just described were so compelling, we decided to integrate with crash reporting first. After a couple of months of having it out in production, it turns out to be a quite valuable addition to our current toolchain, and that's for those three reasons. Shazam gets a very large number of users per day, and even if just a tiny percentage of those users experiences a crash, it adds up. So the number of crashes are actually quite a lot. In our previous system, couldn't handle all of that traffic. So we knew we're not getting the whole picture. We know that's not going to be an issue with Google, with Firebase, because it's powered by Google's massively scalable infrastructure. And we know we always have a very accurate view of how many crashes we get. Ali just described the level of details you get with Firebase crash reporting, and I'll give an example of how that helped us. Currently, we are also getting the number of users and the distribution of users where a crash occurs, which we didn't have before. A couple of releases ago, we saw two new issues that were appearing with the same kind of frequency, but with very different distributions of users. So the first one was very spread out, very high distribution. So we knew that wasn't going to be a device-specific bug, and it was going to be quite occasional. The other one, on the other hand, was very specific, very limited number of users. So when we went to the Firebase console, we saw exactly the manufacturers, the models that were affected, and the OS versions, and that's how we managed to fix the issues. And the breadth of Firebase, I said we integrated with crash reporting. We also used analytics. We know it's all going to be part of the same unified SDK and console. So very recently, we also started using dynamic links, which, as you may have seen, helps you maintain the context of a user through the installation of your app. It's been amazing to be an early user of crash reporting, and we're looking forward to do more and more integrations. I'll leave back to you.
All right, thanks, Pal. I want to touch on a point that Jordanis just mentioned at the end. One of the main principles that guide us as we think about app quality is that it's not just about metrics that you show in a dashboard. It's what you do with this data. And it's about putting your users first by having timely action and winning them. We think that Firebase can be a key ingredient to that. Let me give you an example. Let's say you have an e-commerce app and you're about to push this new feature that you think is going to have a great effect on your conversion rates, okay? And you want to keep an eye on quality, of course. So you jump into the Firebase console, and the first thing you do is go to Analytics. In Analytics, you build an audience of users that see errors. You get to do this because we have this integration out of the box. So every time crash reporting actually catches an error, that user gets added to an audience. And we'll see how important this is in a bit. The second thing you do is you go to Remote Config, which allows you to control things remotely. And you wire that to your feature so you can use it as an on-off switch. So you get to pull the plug on it anytime you want to without actually having to push an update. OK, so you do these two things. You push your new version out with the feature. And then you take a look at the crash reporting console. And all of a sudden, there's a spike in errors. Obviously, that's not a good thing. So you drill a bit more into it. You take a look at the stack trace. And you quickly realize this has something to do with the feature that you just pushed. You jump back into Remote Config. You turn the feature off. And then going to Firebase notifications, you can actually send a push notification to an audience in Analytics. Well, you just created an audience of people that see errors. So now you can automatically send them a push notification, tell them, sorry, that you're working on this, and maybe send them a discount to re-engage them back into the app. So within minutes, you get to do things that would otherwise take you days of coding. And that's not even counting the time that it would have taken your users to pick up an update. So it's really powerful stuff. And of course, at the end, when you fix the issue, you go back to Test Lab, you build a test case for it, and you make sure that any possible regression that might happen in the future never actually makes it to your users. This is what's so cool about Firebase. It is 14 powerful features that you get access to using one SDK in one console, and you mix and match whatever features you need. They are cross-platform. The vast majority of features we have today are already supporting iOS and Android, and it's only going to get better as we cross-integrate them more and more. So we hope that this gives you a different perspective on app quality and get you to think about it throughout the stages of your app. When you develop, use Test Lab to make sure that you catch all the bugs that you can catch in development. When you're about to release, keep your eye on the alpha and beta channels and make sure that your release is looking good. And then in production, use crash reporting to catch everything out there. We really think that using this combination will go a long way and will get you those 5-star reviews. We hope you're excited. We already have an amazing community of app developers that you can see on this slide, and we would love nothing more than for you guys to join us. Some last notes here. We have a booth set up right outside of this room where the Test Lab team actually set up a rack with actual devices in it. It's really cool. You really need to check this out. So drop us a visit over there. We're going to be around as well for Q&A for about an hour or so. We'd love to talk to you. And finally, all the products we talked about today are live today. So go to the consoles, start hacking away, enjoy it. And please keep thinking about app quality. It really matters. Thank you so much, and we'll talk to you in a bit.
So we'll do Q&A. There's mics here if you want to ask questions right now, actually. Yeah. Yeah.
haven't been telling people that this is like them, right? Because this is nothing like them. This would be boring.
Strong skepticism. I'm giving it a shot. The result is Pivotal. It's a lot like Serial.
It's not like that either.
Each episode is part of a larger story. Having an app targeting an API that's fallen off the sliding scale of relevancy is a great opportunity to replace tricks, hacks, and deprecated APIs with a robust modern architecture. That means integrating the Android support library, the Fuse location provider, the job scheduler, material design, enhanced notifications, Android Wear, and all the features of Ice Cream Sandwich, Jelly Bean, Kit Kat, Lollipop, and Marshmallow. And everything else I don't yet realize needs to be updated. You won't see much of me, but imagine me here, dressed neatly at a tidy desk, with a warm cup of tea. Definitely do not picture me with my feet up on a messy desk, and absolutely not me at home in my pajamas. Picture me here, in my happy place.
Rado, we're going to need you to clear out of here. We've got another shoot. Can't you do this at your desk?
I'm Rado Meyer. Join me on the Android Developers YouTube channel as I bring an old app back to the future, here in my office. Welcome to Pivotal.
There's something really satisfying about getting your app to look great on your device. But just because there's over 11,000 other Android devices out there doesn't mean you need to build 11,000 other layouts to make a great-looking app. Not if you're using responsive UI principles. You may have noticed that I'm not Ian or Joanna. My name is Mike Denny, a design advocate on the Google design team. First things first, thinking about specific phones and tablets is only going to get you into trouble. There's a wide spectrum of devices and not that much difference between the largest phone and the smallest tablet. Instead, think more generally about how much space you have to work with. This can come in 3 different flavors: width, height, and smallest width. Width is super important and should be the basis for breakpoints in designing and building your UI. For example, 600 dp in width is the first point where you could consider having a side-by-side summary and detail level view. Any lower and you won't be giving each level the full attention it deserves. Height is less common when designing responsive UI, but keep in mind that something like a vertically scrolling container is going to be difficult to use if you can only see 1 or 2 elements at a time due to a constrained height. Smallest width, unlike height or width, is designed to be rotation insensitive as it's just the smaller of the 2 values. This gives you a better idea of how much space is available and is an easy way to ensure that your app remains consistent as the device is rotated. You don't want to force your user to relearn your navigation structure every time they rotate their device. This is particularly important in the multi-window world. When your app is resized, your width, height, and smallest width are going to be updated. You might be going from full screen on a tablet down to what amounts to a portrait-oriented phone worth of space. Here's where a good responsive UI can make for a smooth transition. There are a number of common patterns you might consider when building that responsive UI, such as revealing previously hidden content as the screen size grows, transforming your navigation pattern or switching from a list to a grid, dividing your screen into multiple sections side by side, reflowing specific elements, expanding the size or margins of individual elements, or even changing the position of specific elements like a floating action button. Check out the blog post for more details on designing responsive UI and specific patterns you can use to build better apps.
Classifiers are only as good as the features you provide. That means coming up with good features is one of your most important jobs in machine learning. But what makes a good feature, and how can you tell? If you're doing binary classification, then a good feature makes it easy to decide between 2 different things. For example, imagine we wanted to write a classifier to tell the difference between 2 types of dogs, greyhounds and Labradors. Here we'll use 2 features, the dog's height in inches and their eye color.
Just for this toy example, let's make a couple assumptions about dogs to keep things simple. First, we'll say that greyhounds are usually taller than Labradors. Next, we'll pretend that dogs have only 2 eye colors, blue and brown, and we'll say the color of their eyes doesn't depend on the breed of dog. This means that one of these features is useful and the other tells us nothing.
to understand how useful do you think this feature is? Well, on average, greyhounds tend to be a couple inches taller than Labradors. Do you think this feature is? Well, on average, greyhounds tend to be a couple inches taller than Labradors, but not always. There's a lot of variation in the world. So when we think of a feature, we have to consider how it looks for different values in a population.
Let's head into Python for a programmatic example. I'm creating a population of 1,000 dogs, 50-50 Greyhound Labrador. I'll give each of them a height. For this example, we'll say that Greyhounds are on average 28 inches tall, and Labradors are 24. Now all dogs are a bit different. Let's say that height is normally distributed, so we'll make both of these plus or minus 4 inches. This will give us two arrays of numbers, and we can visualize them in a histogram. I'll add a parameter so Greyhounds are in red and Labradors are in blue. Now we can run our script. This shows how many dogs in our population have a given height. There's a lot of data on the screen, so let's simplify it and look at it piece by piece.
We'll start with dogs on the far left of the distribution, say who are about 20 inches tall. Imagine I asked you to predict whether a dog with this height was a Lab or a Greyhound. What would you do? Well, you can figure out the probability of each type of dog given their height. Here it's more likely the dog is a Lab. On the other hand, if we go all the way to the right of the histogram and look at a dog who is 35 inches tall, we can be pretty confident they're a Greyhound. Now what about a dog in the middle? You can see the graph gives us less information here because the probability of each type of dog is close. So height is a useful feature, but it's not perfect. That's why in machine learning you almost always need multiple features, otherwise you could just write an if statement instead of bothering with the classifier. To figure out what types of features you should use, do a thought experiment. Pretend you're the classifier. If you were trying to figure out if this dog is a Lab or a Greyhound, what other things would you want to know? You might ask about their hair length, or how fast they can run, or how much they weigh. Exactly how many features you should use is more of an art than a science, but as a rule of thumb, think about how many you'd need to solve the problem. Now let's look at another feature like eye color.
Just for this toy example, let's imagine dogs have only two eye colors, blue and brown. And let's say the color of their eyes doesn't depend on the breed of dog. Here's what a histogram might look like for this example.
For most values, the distribution is about 50-50, so this feature tells us nothing because it doesn't correlate with the type of dog. Including a useless feature like this in your training data can hurt your classifier's accuracy. That's because there's a chance they might appear useful purely by accident, especially if you have only a small amount of training data. You also want your features to be independent, and independent features give you different types of information. Imagine we already have a feature, height in inches, in our data set. Ask yourself, would it be helpful if we added another feature, like height in centimeters? No, because it's perfectly correlated with one we already have. It's good practice to remove highly correlated features from your training data. That's because a lot of classifiers aren't smart enough to realize that height in inches and centimeters are the same thing, so they might double count how important this feature is. Last, you want your features to be easy to understand. For a new example, imagine you want to predict how many days it will take to mail a letter between two different cities. The farther apart the cities are, the longer it will take. A great feature to use would be the distance between the cities in miles. A much worse pair of features to use would be the cities' locations given by their latitude and longitude. And here's why. I can look at the distance and make a good guess of how long it will take the letter to arrive. But learning the relationship between latitude, longitude, and time is much harder and would require many more examples in your training data. Now, there are techniques you can use to figure out exactly how useful your features are, and even what combinations of them are best, so you never have to leave it to chance. We'll get to those in a future episode.
Coming up next time, we'll continue building our intuition for supervised learning. We'll show how different types of classifiers can be used to solve the same problem and dive a little bit deeper into how they work.
Thanks very much for watching, and I'll see you then.
Hey gang, did you know you can send notifications to iOS devices using Google Cloud Messaging? Well, you can! Why would you ever want to do that? Maybe that's a better question. Let's find out the answer on this episode of Route 85. So notifications. They're a great way for you to engage with your users. They let your customers know you have important new information for them, and when used responsibly, they can be a great way to keep users coming back to your app. But they're not super fun to implement. There's a lot of steps required to set up notifications in the first place. You need logic on both the client and the server, and if you're developing a cross-platform mobile app, and most of you are these days, you have to do this for Android and for iOS. And I'm not just talking about two sets of client logic either. It turns out sending notifications to iOS and Android devices requires different logic on the server too. See, if you've done any notifications work in the past, you're probably used to talking to APNS, that's the Apple Push Notification Service, to deliver notifications to iOS devices, and to GCM, that's Google Cloud Messaging, to deliver notifications to Android devices. And while sending notifications through these two services is similar, they each have slightly different features, use different protocols, accept different message payloads, and return different responses, all of which means that you got to keep track of what kind of device each of your users has and use two completely different code paths to send a notification. Or do you? Well, no. No, you don't. You see, one pretty great feature about Google Cloud Messaging that a lot of people don't know about is that GCM can relay to APNS any notifications you want to send to an iOS device. Now, granted, you'll need to do some setup work like upload your APNS certificate to GCM and make sure your client sends its device token to the GCM service. But once you've done that, you can use GCM to send all of your notifications, no matter what platform your target device is, and GCM will deliver your notifications to the correct device using the appropriate service. What all this means is that you don't need to care about what device your user has anymore. You just have to write and maintain one code path, and as we all know, less code means less room for mistakes. But it's not just about using less code. By using GCM to handle your messaging for you, you can take advantage of some of the other nice features that GCM offers to developers, like topics. Topics allow your app to subscribe to notifications about any particular topic that you or your users want to. For example, let's say you've got a weather app and I, as a loyal weather fan, want to be notified whenever there's extreme weather happening in my zip code. Well, in the old way of doing this, you'd probably need to set up a database where you keep track of each one of your users and their devices and their zip codes and do this whole select users where blah 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 query, then loop through the results and send notifications to each device that you get back from this database query. But with topics, none of that's necessary. Instead, your app simply tells GCM that you're interested in subscribing to, say, the weather 94043 topic. Then, next time there's rain in California, for us that counts as extreme weather.
Oh my gosh, there's something coming down from the sky. I don't know if it's water or if it's acid. I can't go out. I don't know how to drive anymore.
Yeah, that seems about right. So yeah, with topics, your server simply tells GCM to send notifications to all devices subscribed to the weather 94043 topic, and I will get notified along with all other devices subscribed to that topic. So there's no database required. Go ahead and throw it out. Oh, as long as you weren't using it for anything else, I guess. I probably should have mentioned that earlier. GCM has other useful features too, like upstream messaging, which allows your app to communicate to your server through GCM. This can be helpful in cases where you might want some lightweight communication from your clients to your server, but don't feel like dealing with the hassle of setting up and maintaining a full-blown server open to the entire world. Or read receipts, where in some, but not all situations, you can be notified that a user has received your message, something you can't normally do through APNS alone. Oh, and in case you're wondering, all this is free, as in please send us $0, and it's using much of the same infrastructure that Google uses for its own apps, so it'll probably scale for yours. So there's a lot to learn when it comes to notifications, and I encourage you to get started here with our Google Cloud Messaging documentation for iOS. We also have a couple of sample applications for you to look at. There's Friendly Ping, our cross-platform chat app powered entirely through Google Cloud Messaging, as well as the GCM Playground, which lets you easily experiment with sending calls through the GCM service. And keep watching Route 85. Maybe you'll see another Google Cloud Messaging video pop up in the future. If only we had some way of letting you know when that happened. Well, I'm stumped.
Consider the simple URL. A few years ago, these were pretty straightforward. You clicked on one, and 9 times out of 10, you went to a web page. Then things changed. People started using their mobile devices for, well, everything. And these devices in turn started supporting the idea of deep links. Click on one of these deep links and it could take you not just anywhere on the web, but anywhere in an app as well. So you could use a deep link to point directly to a specific restaurant inside a reservation app, or give your new customers a personalized welcome based on the link that brought them to your app in the first place. At least, that's how they worked in theory. In practice, deep linking had issues. The same link wouldn't necessarily work on an iOS or Android device, and they behave very differently, or didn't work at all, for users who didn't have your app installed. And for people who did install your app through a deep link, all of that great link info was typically lost during the installation process, leaving your personalized warm welcome out in the cold. So while deep links were great in theory, their uses were a little more limited in practice. Enter Firebase Dynamic Links. Firebase Dynamic Links are deep links that work the way you want them to. So you can create one single link that behaves one way on iOS, another on Android, and even a third on a desktop browser, and it will take you to a place that's appropriate to that platform. You can also set up dynamic links to change their behavior depending on whether or not your user has your app installed. For users who don't have your app installed, maybe you send them to your website, maybe you take them to the Play Store, or maybe you show them an interstitial describing the benefits of your app before you take them to the App Store for a smoother transition. More importantly, these links can survive the App Store installation process. So if your user installs your app when clicking on a dynamic link, all of that information is still available to you when your user opens up your app for the first time. So what does this mean? It means you can use dynamic links the way you've always wanted to use deep links. You can use them in marketing campaigns, from email to social media to banner ads to, heck, even QR codes. And in addition to install attribution tracking, the kind that lets you know which campaigns are getting you the highest quality users, you can also give your users a customized first-time experience based on the campaign that brought them there. So if a user installs your music app because you showed them an ad for classical music, you can make sure your app takes them right to Chopin's latest hits when they first open it up. Dynamic links are great for sharing too. Your users can use them to share recipes, links to their favorite level in your game, or even coupon codes. In fact, dynamic links are the technology that powers Firebase Invites. And because dynamic links are a Firebase product, you can see their stats directly through the Firebase console. Find out how many people clicked on a link, or use Firebase Analytics to find out which of your users first opened your app through a particular link. To find out more about dynamic links, check out the documentation here and give them a try. And deep link away.
Bitcoin represents a way to transfer money anonymously and at almost no cost. And since it's an arbitrary currency with no nationality attached to it, you're free to exchange it with anyone in the world. What is money? Resources are limited, and they hold explicit value to people. Most resources are physical, and such needed to be traded in a physical form: diamonds, gold coins, chickens, or bikes. At some point, it becomes too difficult to physically transact those objects, and it's easier to agree, collectively, on the value of cash instead of gold. As we know today, this has many advantages. Credit cards and the modern banking basically gave us another abstraction layer on top of cash. There is a centralized system which defines who owns what resources. All of these trades are made virtually. This is the backbone of why Bitcoin is a valid idea. What is Bitcoin? Bitcoin is decentralized, anonymous, digital-only currency that recently received public attention. Bitcoin was originally developed in 2008. Like in any good mystery, someone using the alias Satoshi Nakamoto published a paper describing how Bitcoin could work. There's a very interesting story about this guy too. He must be very smart, but he never came forward to claim ownership or any part of the revenue. Just 1 year later, in 2009, Bitcoin started being traded. Where do they come from? Think about gold. You could buy it or mine it, and it's the same concept with Bitcoin. You do this by using your computer to hunt for 64-digit numbers. By having your computer repeatedly solve complex mathematical puzzles, you're competing with other miners to generate the number that the Bitcoin network is looking for. If your computer generates it first, you receive Bitcoins. The Bitcoin system is programmed to generate a fixed number of Bitcoins per unit of computing time. It is also self-sustaining, coded to prevent inflation, and encrypted to prevent anyone from disrupting its code. In the year 2140, the total number of Bitcoins in circulation will be capped at 21 million. So how much is a Bitcoin worth today? You'll need to Google it. Just type Bitcoin in US dollar, for example. You could also check it out at priv.com. Why are they anonymous? Bitcoin are pseudo-anonymous because they are built upon this centralized system. The Bitcoins themselves are anonymous. The wallets are not. Here is why. The base algorithm creates anonymity, but as the recent court cases show, if your Bitcoin wallet is identified and attached to a person, then someone can go through and track every transaction you've made. Bitcoins exist entirely on their own because there's no central infrastructure to shut down. You are identified by nothing more than your Bitcoin wallet address, a string of randomized letters and numbers. There are absolutely no identifying characteristic beyond that. For the paranoid dude, you can simply create a new wallet for each transaction. Here are some interesting startups that push the technology forward. We are still in the initial phase of Bitcoins, and there are many challenges and opportunities ahead. Exchanges, wallets, merchant services, security, and more. But this is something for another episode. Until next time, eat your vegetables and listen to your partners.
One word that's the bane of both the novice and expert programmer alike: threads. I'm Joanna Smith, and threading can be one of the greatest perf improvements you make, but it will also likely drive you crazy. Tom Sawyer illustrated threading perfectly a long time ago when he needed to paint that fence, because when you've got a large chunk of work to do and it's the same work over and over again, you call on some friends to get it done quickly. So for computations that are taking a long time, consider calling in reinforcements with threads. By allowing multiple threads of execution to operate on your dataset in parallel, you reduce the overall time required to complete the task. With Android, threading becomes especially important because the entire app runs on the main thread, which is also called the UI thread because it updates the UI. And when the UI stops responding, users stop using your app. So, when you want to perform some complex action in response to a button being pushed, for example, you'll want to move that off the main thread until it is finished so that the user can continue to interact with your app. Because there are few things worse than the dreaded application not responding dialog. However, integrating threads into your system is not for the faint of heart. You're going to have to rethink your entire approach to computational complexity and to your memory model in order to properly integrate threads. So, to avoid the rabbit hole, take advantage of the Android framework, which has been built to help you out. Careful thought and planning about your app's structure and flow will enable you to determine whether a thread should affect the UI or be entirely hidden. APIs like Async Task and Thread both help you manage the work and keep your app from hanging, but Async Task will also allow you to affect the UI, like when you want to display a progress dialog. So take a walk through your own app and see if there are places where it stops responding or gets exceptionally slow in response to a user action, and then move all of that extra work off the main thread. But, thoughtfully. Don't just change things willy-nilly. Because while threading may be intimidating, it shouldn't scare you. What is scary, though, is bad performance, which is why you should check out the rest of our Android Performance Patterns content and consider joining our G+ community for tips, tricks, and help. But most importantly, keep calm, profile your code, and always remember, perf matters.
Hello and welcome to Supercharged. Now this is a kind of TLDW. Last week I did a live stream with Surma where we made some swipeable cards. Now you probably recognize swipeable cards from things like Google Now, where you just kind of take a card and you dismiss it. And you can actually see what I've got on screen. This is what we ended up making. There you go, you see? Dismiss it and all that kind of good stuff. Now the idea is, if you've not got an hour to watch that live stream back, although if you can, I would recommend it, and you can find the link to that below. If you can't, that's exactly what this is for. I want to step through the things that we learned, the things that we did, and just so you can get an insight into what actually went into it. So, before we actually get started, what I want to do is I want to step over to Theory Corner. Oh yeah, theory. Love theory. And what we can do in Theory Corner is discuss what we need to do. Join me. Welcome to Theory Corner. You can tell it's Theory Corner because there's some theory in a corner. Now, this is what we have. We've got the cards. You can tell it's a card because it says card. The cards have will change transform on it. The idea I have here is that we want each card to be transformed around the screen. And so we want to give each card its own layer. The compositor then can move those around with the help of the GPU. So long as we stick to transform, opacity, and we set wheel change, we should be good. So we move the card as you touch and swipe. But as you get across to this side, we have this marker of like 0.35. Now I picked that at random. You could pick a different number. 0.35. If you go past that point, we basically say, well, this card is being dismissed. So we slide it off to the side. The other thing that we're going to do is we're going to change the opacity. So the further you go across, the lower the opacity in both directions. So that works there. Okay, so we're going to put each card on its own layer, and shift it side to side, and fade it out. Let's go back to reality. What we're going to do here is we're going to step into the code so you can actually see bit by bit what we actually did. Here's the cards, and what we do first of all is we basically create an array from the cards that we've got in the document. So we'd have to have some kind of code that adds or removes those cards later on, but don't worry about that. We'll just get on with what we've got here. The next thing to notice is that I've got these named functions on start, on move, on end, and update. Now the first three are our input events, and I choose to do it this way. What I do is I take a copy of it by calling .bind on this, and that takes it from the prototype into the actual instance. But it does another thing for me as well. It means that it's bound to the instance so that in those functions, when I say this dot whatever, it's actually applying to the instance and not to the target's event. No, wait, the event's target. Oh, one of those two. So it also does something else for me. It means that I can do add event listener and remove event listener, and I can call it by name. I can say like this dot on start, for example. You can see that down here in the add event listeners. So I do add event listener for touch start, touch move, touch end, mouse down, mouse move, and mouse up. All of them. Yay! And I can just basically say on start, on move, on end, and so on. And if I wanted to do the remove event listeners, I could do that, and that would just work out fine for me. So we've got our event listeners, and we have a bunch of variables here that are just sort of housekeeping, things that we need to keep a track on. The other thing I do is I start a request animation frame where I busily sort of kind of do an update. Now, if you're doing this in production, I would suggest you don't do it quite like this. I would start the request animation frame when the user starts interacting, and then when the animation's finished, I would stop doing the request animation frame loop. But for the case of this, just to keep things simple, I just start it right at the start, and I do a kind of busy loop through. So what do we actually do in the on start, on move, and on end event listeners? Wow, saying event listeners over and over and over and over and over again, that's not confusing for me. No! What do we do in those? Well, first, in the on start, the main thing is this. We basically take a marker for the start position of the interaction. Where does the user put their finger down on the screen? And then we get that with page X. The other thing we do is we take a copy of that for the current position, because as we move our finger, we're going to update the current position so we know where we started and where we currently are, and the difference is how far we want to transform the card. The other things that we do in this is we set the dragging card to say true, but as we discussed in Theory Corner, we set will change to transform. Now we can check that that actually works by going back to the code, bringing up DevTools, and in the rendering settings, we're going to show layer borders. Anything that's got its own layer is going to go orange around its border. You ready? So when I click, you can see that immediately the card gets its own layer, which is really cool. That means that we can transform and move it around cheaply, like we discussed over there in the Theory Corner. Here's what we've got in the on move. It's fairly straightforward. All we do is we take the current position of the input and we basically say that's the current X. Now inside the update, what we can do is we can say if they're dragging the card, the screen X, which is basically the position of the card on the screen, is the current minus the start. That's basically how far they've moved. And we can apply the transform to account for that. Ta-da! Now when the user stops interacting, we actually have to make a decision. If you remember over in Theory Corner, we said if the user is past that 0.35 marker, so it's a sort of a 0 to 1 range, 1 being the full distance of the card, 0 being not at all. If they go past 0.35, which is what I've chosen, but you could choose a different number, what we want to say is they are dismissing the card. And we do this by setting a target X, which we use later on in the update. And here we do screen X plus equals the target minus the current screen X over 4. What this is going to do is it's going to ease the card to that final position, which will either be the center or it'll be off to the side, depending on whether we've decided that they've gone past the point of dismissal or not. Then there's a little bit of tidy up that we do here. We basically normalize the drag distance and we use that to set the opacity so that the further across you get, the more fadey the card is. Ta-da! So far, so good. So the last little bit is what we do when you dismiss the card, because what we want to do is we want to slide all the other cards into place. And we do that with this animate other cards into position function. Let me show you what it looks like without that. I'll switch off the layer borders. Okay, here's what it looks like without that. You see all the other cards just snap into place, which you could do, but doesn't look quite so nice. So what we need to do is we need to transform them down quickly to where they moved from, which will be the height of the card plus the margin. And you can see that here. So we take every card that's after the current one, which is this, and we basically say translate yourself the height of a card plus 20 pixels, which is the margin. And again, this is hard coded, so you'd probably make this more dynamic in production. And then we basically go from that to no transform at all, and we use an easing of this cubic Bezier and a duration of 150 milliseconds. And all we need to do is just say card.animate with those settings, and then when you've finished, we say the animation's complete, at which point we can just reset the target and call it a day, and the animation's done. So with that switched on, you can see we get a nice smooth animation. So the only other thing to notice is when I'm dismissing the cards, you can see that the other ones get their own layer temporarily. This is because we're using element.animate and we're using a transform, and that means that those get temporarily promoted to their own layer. Cool. That means that it's also doing the same thing that we had over in Theory Corner. We're getting its own layer, which means it happens nice and performantly, and then when it's finished, the browser automatically demotes them back, and we're all good. So there you have it, that's swipeable cards. If you've got time, make sure you watch the live stream. There's loads in there. There's us finding and fixing bugs. There's just chatting about the general approach. All sorts of goodies in there. Hopefully you've enjoyed this little TLDW. Don't forget to subscribe to the channel, and I will catch you on the flip side.
Hey everybody, I'm Rob Wormald. I'm a developer advocate on the Angular team.
And I'm Alex Rickabaugh. I'm a software engineer on the Angular team. Rob and I work on Angular Mobile and making Angular a great framework for building mobile apps. And we're here to talk to you today about these things called progressive web apps.
So if you've been at I/O at all today, you've probably heard about progressive web apps. They talked a little bit about in the keynote. And I think for us to understand why we're going to talk about them today and why Angular and why you should be interested in them, we should probably go back a little bit and kind of talk about where we came from, right? So in the Wild West of the web development world, and this is like, what, 6 months ago, right? That everybody is kind of, this is how we started building web apps, right? So you'd have a browser and you'd have a server, and you'd go to a website. The server would kind of construct this whole page, and it would send it back, and then you decide you want to buy this widget on whatever shopping website, and then you'd send a post back, and then the server would reconstruct another page and send it all the way back to you. And this cycle would kind of go on and on and on, right? And this worked really great for a long time.
And then we discovered Ajax. And we started building these things called single-page applications. And the idea was that instead of this request-response cycle over and over again, we would send down a bunch of JavaScript code with the first page, Then that code would take over and kind of run the UI for us. And if it needed data, it would go and get it via an AJAX call. We wouldn't send back HTML. We'd send back JSON and drop it into the DOM, right? So this was a much better world, actually. We had applications that felt a lot more interactive and faster.
And so the framework that we work on kind of came from this world. You might have heard of it. Anybody in here an Angular developer? Yes? You can woo. That's good if you want to woo. Woo, cool. And so we describe Angular as this kind of super heroic JavaScript MVW framework. And we say it's like what Angular would have been had it, or said it's what HTML would have been had we designed it for building web apps, right? And so this has worked great. People have built millions of apps. There's tons of Angular apps out in the wild. You've all probably built one. And everything was kind of wonderful and great, right? Like, it's a great world we live in.
So we started building more and more complicated single-page applications with more features and more bells and whistles. We ran into some problems, right? Suddenly we're pushing a lot of code to the browser every time the application starts up. And the web really wasn't designed to do this. Web pages are supposed to be interactive. It shouldn't take 10 seconds to load all this code in.
Yep. And so this is really why we're here today, and this is why the progressive web apps thing has become a thing, right? So this is the kind of quote from Google developers' website, and it talks about, I'm not going to read it to you because you read it, but I think the primary takeaway here is this idea of the app-like user experience, right? And so on the Angular team, we've been doing this, right? We've been trying to kind of hit this goal of building really, really app-like, really kind of native app-like apps, right? And so while the web has been evolving, while these ideas of PWAs have been coming out, Angular's been evolving, right? So we've kind of been writing this new version of Angular, Angular 2, and we've been really kind of trying to re-evolve the entire framework, right, as this whole web kind of thing changes. And we want to keep up, right? And so to do that, we wanted to build one, right? Like, we wanted to see what the experience is like, because, funny story that a huge amount of the Angular team, we don't build apps on a day-to-day basis, right? Like, we're building framework code, but we don't always write apps, right? And we don't always know what you as developers are having to deal with and how the framework works for you, right? So this is something we want to do. And so we wanted to build this progressive web app and really get a feel for like what it means to make an application really performant, what it means to make them reliable offline, online, all of these things, and really how hard it is, how easy it is to make things really immersive to really get this good experience.
So we didn't just want to build like another to-do MVC or sample application. We wanted to build something we'd actually use. And the Angular team, we get a lot of GitHub issues.
A lot.
Yeah, and some of them are really good bug reports with very reproducible, and some of them are kind of like not as high quality. So we need some way to like go through them and triage them quickly. So we built this thing called Issue 0. And if you used Inbox 0, it's kind of the same principle. You go through and you like swipe left on issues to close them, or you swipe right on them, and you can triage them and apply labels and stuff like that. As Rob was saying, we really don't build comprehensive applications that much, so we wanted to make sure all of this stuff that we were like pushing would actually work well together. So from progressive web apps, we took this idea of an application shell, we took the service worker API, we use Firebase authentication, because it's a serverless app. We use IndexedDB to make sure the data is cached offline, so if you don't have a network connection, it'll still load. And then we use two projects within Angular, our material framework for building really pretty, beautiful UIs, and our CLI, which takes care of a lot of the build tooling for us. And so the first challenge that we wanted to see if we addressed really well was loading the application, getting something on the screen really quickly. And so this idea of application shell that we're using to do this comes from progressive web apps. And the idea is that you really take advantage of what index.html is. Index.html is not just this place where we put all the scripts that we want to load and all the link tags to the CSS that we want to load. It's the very first thing that gets sent from the web server to the phone or to the browser. So we take advantage of it, and we've put this static UI into it, this code that will render this little title bar and the menu icon. And it's not much, but it tells our users that this application is alive on the page. It's loading, it's working, it's doing work for you in the background to fetch data. And at the very bottom, we put our script tags loaded asynchronously. And that means that Angular is loading in the background while the browser is busy rendering this page. And eventually, it'll fill this application shell with dynamic content. And that gives you a really nice, beautiful loading experience. But one challenge doing this is you kind of have this two copies of your application. You have the static code, the HTML, that loads this app shell, and you have your dynamic application written in Angular. And we didn't want you to have to do this. So we thought, what if we could use the same primitives in Angular that we use to control what DOM appears where, just how you normally write an Angular app, to control what would be in your application shell and what would be in your static application, in your dynamic application. So that's what we did. We have this little shell render directive, and you can apply it and say, this thing should be part of the app shell, or this thing should be excluded from the app shell.
And so how do we do this? If you've built an Angular 1 application, right, you kind of know what the point of Angular is. The idea has always been that you write an application, you talk to Angular, and Angular kind of handles talking to the DOM for you, right? Like, we don't make you do manual DOM updates. This has always kind of been the magical selling point of Angular, right? It's why we all use it. But it's also kind of the biggest crutch in Angular 1 is that we are really tightly coupled to the DOM. So in Angular 2, we have this idea of really splitting these two ideas apart, right? So now Angular 2 is very much two parts, right? So we have the Angular that you kind of know and love, that you speak to, and that's what your application talks to. And then we have a separate layer we call the renderer. And the renderer is actually what handles talking to the DOM. But these two pieces are very decoupled, right? So we have this kind of bridge that you speak between the two. And it means that this renderer could be, by default, it's the one we use in the DOM, like we do in Angular 1. But it also allows us to do some very, very flexible, interesting things. We've rolled a lot of this work under a project called Angular Universal. And so the idea of Universal is that it allows us to really boot up your application and treat Angular as if it was just an app. You don't have to worry, you don't have to think that it's a browser app or a web app or whatever. It's just an app. And so this is an example in Gulp. We're actually booting up your Angular application, pre-rendering the content, and writing it out to disk, right? So this is happening when you build your app at the same time you're compiling your code. This means that we can take that application shell, do all of the work up front, and then you can statically cache this application ready to go on your web server.
Yeah, so that's how Universal works to build application shell for you from your templates in HTML at build time. But you can actually run Universal at runtime, too, on your web server. So if you have a Node.js server or ASP.NET has a beautiful integration with Universal, you can actually, when the user requests a page, instead of serving them the JavaScript and the HTML of your application and having Angular run in the browser, you can run Angular on the server and render out the HTML that you would otherwise have displayed in the browser and send it to the user statically. So here's an example of how that works in a Node.js server. If you've written any Node.js web code, you've probably looked at Express. Express is a framework for building web servers in Node. And here we're telling Express that when it sees a request for an HTML file, it should use the Express engine from Universal. So instead of sending static HTML bytes to the client, Express will actually boot up the Angular application, run through and render all your templates just as if it were running in the browser, and send the resulting HTML to the client. It's a really powerful way of doing things. And it has a lot of benefits. We talked about performance, right? Getting applications on screen fast. But another one is search engine optimization. Not every web crawler out there executes JavaScript code when it's loading your application. So if you want to have, if you want to be indexed really well and have a good experience in all the search engines out there, it's really beneficial to be able to serve static HTML to the crawler instead of a bunch of JavaScript that it won't understand. And that also works in your favor on social networks. If someone takes a link to your application and shares it, right, the scraper from the social network that's trying to figure out like a good image or text extract to put in the post won't actually know what to do with the JavaScript either, but it can understand the static HTML that Universal produces. So this experience with Universal running on the server works really well across all browsers, all devices. But if your user happens to be using a modern web browser like Chrome that supports Service Worker, this experience gets even better. You can think of a Service Worker as a little HTTP server that runs in the browser and handles all the requests client side. So in the Service Worker, we can actually cache all of the static content for your application, all the JavaScript, CSS, HTML that makes it tick. And whenever the user opens the app, we're not serving over a network connection slowly. We're loading that stuff from cache on the phone. In addition to the static content, we actually cache that application shell that was built for you by Universal at build time, so that even the very first paint running locally happens with static content. And that is really, really, really fast.
Yeah, like it's crazy, crazy, crazy fast.
So that only gets us so far, right? We can get the initial load, the initial first paint working really quickly. But Angular still has to download in the background, and your application still has to download in the background. And that means we still can't be doing things like this, where we just load too much JavaScript code before the application can start up. And so how do we deal with this problem? We break up the application and use the router to load code in only when it's needed. So when we start up the app, we only serve the code needed to render the home screen. If you were watching the keynote this morning, the Android Instant Apps works exactly the same way. They're only serving the part of the app that's needed for that first view. And then as you move around in the application, our router will issue requests and load in code dynamically to keep the application running. And that, too, gets even better if you have a service worker. Not only do we cache this static content in the application shell, for a small application, we can actually load all of the routes into the service worker cache so that they're available just as if the user had downloaded your whole app. For a large application, we plan to have some strategies in the service worker to wait for a strong Wi-Fi connection and wait for the user to be idle in the application, and then start prefetching some of these things more intelligently. And we think that'll lead to a really good experience for all sizes of applications, no matter how much JavaScript you need.
So again, I think we've solved, or maybe not solved, but we made pretty good progress on getting this application up and running really quick. And again, being able to kind of progressively load this application as we go along. And of course, data binding is really the magic that makes Angular tick, right? I think it's a big reason that all of us use it. If you haven't, just we'll do a quick review. This is what it looks like in Angular 2. We've got a template here. We've got a little bit of data in our controller. And we were basically just binding this repo.icon to the source tag of the image. And we're doing these little double curly brace syntaxes. And we're just sort of doing some actual text binding there. So this is really fast. This is something that Angular's done for a long time. I think it's why we all love it, right? And in Angular 2, we've kind of made some changes to how the change detection works. So in an Angular 1 application, you could get into situations where if you were doing strange things or you're having things that updated other things, you get this idea of a cycle, right? And if you've had an Angular application that's exploded and it said something like infinite digest cycle, right, this is why. So in Angular 2, we wanted to solve this problem, and I think we have. So in Angular 2, change detection kind of runs from the top to the bottom. So your Angular app is a tree of components, and we start checking at the top, and we run all the way down. Run it once, it's very, very fast, right? But if you have a situation where you have a huge list, right? If you have 1,000 GitHub issues to get through in your app, you can get into situations where you get bogged down, right? You have a lot of stuff that has to be change detected. And so we put an optimization in here that we call on-push change detection. And what this allows us to do is, so in this case, we have like an issue list, and this is going to have a lot of stuff in it. But you might be doing other stuff in the application that's not going to change all that often. And what you don't want to do is have to repeatedly check the bindings of this list, right? So we can declare this on-push change detection strategy. And what it means is that when the application does its regular change detection cycle, we'll just skip that whole tree of components, right? So it gives you a really big boost in speed. And then if you're using observables or immutable data or anything like that, you can then just say to the application, hey, this thing is ready to be dirty checked, right? You get a really nice performance boost from doing that. And so bear with me, because this gets a little bit technical, but this is kind of my favorite part of Angular 2, I think. So in Angular 1, we did this idea where we took your template, right? And the way that data binding works is we compile your templates. So we load them in. We pull them off the server, right? We run a little bit of code in the browser that parses these templates. And then we sort of turn them into instructions to update the DOM. So when this bit of data changes, we're going to update the browser DOM, right? That's how it works in Angular 1. Again, it works really well. But we wanted in Angular 2 to make sure we did it better. So in Angular 2, we have a very similar idea. We have this idea where we're taking your templates and sort of generating these instructions from them. But again, we're actually doing it at build time. So rather than doing it in the browser when your application boots up, we do it when you build your app with Gult or Webpack or whatever. And we generate very, very, very efficient code. Tobias on our team calls it obviously fast, which I think is a really good term for it. So again, you get some really big benefits. It's fast, right? You don't have to ship all this extra weight to the browser. Things start up very, very, very quickly. We got this demo working the other day. This is a Hello World application. So this is I believe it's broadly zipped, right? So this is compressed. An Angular 1 application, an Angular 2 application where we have to ship all of this extra code gets down to 118K, which isn't bad. But if we can run the precompile step and pull out all this extra code that's not necessary, we can get it down to 22 kilobytes, which is pretty ridiculously small, I think, right?
Yeah, isn't Angular 1 itself, like the whole library, around 50?
It's bigger than that.
Yeah.
Yeah, it's bigger.
So Rob loves running this offline compiler and figuring out how small he can get Angular. This is my favorite part.
This is literally my life. That's all I do at the moment.
This is my favorite part of the offline compiler. So at the top here, we have Angular running in the dynamic mode. And that means we're shipping the compiler to the browser. We're downloading all your templates, all your code in the browser, and running the compilation step there. And that's not a bad experience for developing an application. You can edit code on disk, save it, refresh. It shows up in the browser. It's a great way to develop. But we have this big green blob here. And this, I can't see the screen. This big green blob is actually Angular compiling your application, all the work that we have to do, all the execution we have to do in the browser before your app even boots up. And then we finally finish compilation. There's this pink ribbon on the right, which shows Angular actually starting to execute your application. So that works today. With the offline compiler, we get rid of that big green blob. We're no longer downloading the compiler and running it. Right? We don't have to do that work. When the browser loads the JavaScript that the offline compiler produces, it starts running your app from the first line. And so it just works, and it's a lot faster. And we don't even have to do the work in the browser of parsing the JavaScript from the compiler, and that gives you even more speed up. So here, the dynamic application loads in about 500 milliseconds, and whatever this trace was captured, we're booting the static, the compiled version in about 250. So it's a really good speed improvement.
So I think that we've done a huge amount of work, right? I think we've done some really, really great stuff. And I think one of the big things that we are all really excited on the Angular team is that now everybody else can start building stuff on top of this, right? And so the reason that Angular 1 was such a success is we had this huge community of people who built really awesome tools, right? And I think that for us, it's now that time where we really get to see the cool stuff come, right? So if you watched the keynote this morning, there was this big deal with Firebase. Yeah, woo! We've worked with Firebase for a long time. They've been really, really amazing partners. If you've used Angular Fire in Angular 1, really, really awesome library. We wanted to make sure that there was an equally good experience, better experience for Angular 2. So we have Angular Fire 2, right? Obviously, for Angular 2. Angular Fire 2 works on their real-time database. It's awesome. So it's a single thing you just drop into your Angular application. This is a real-time chat in, 8 lines of code? Really not a very, very simple thing to do. So that's amazing. That's part of the Firebase umbrella. Authentication, right? Authentication is super hard for web developers, super hard for everybody, right? And so again, in Angular Fire, we just drop it in. You do 2 bits of config, you plug into your application, and then it's 2 lines of code, log in, there you go. Super, super simple. The other thing that comes into Firebase is push messaging, right? Firebase Cloud Messaging. Cool. So we've never been able to do this in a browser before, right? Native apps can do it. It's easy. It's something they all do. But we've never had this possibility in a web browser before. And so now, with service workers, because they're running in the background constantly all the time, if you've got access to a service worker, you can tell it to register for push notifications, and it will, even if your application is closed, you get a push notification. It's amazing, amazing stuff. This we're super, super excited about. The other one that we're really super excited, and the Ionic team talked about this a little while ago. So Ionic has been an amazing partner for us in Angular 1. Again, hundreds of thousands of Ionic apps out there. They do a really good job at doing visuals, at doing sort of app development in general. They announced that they're going to support progressive web apps. We've been working with them for a little while on building Ionic progressive web apps. So that's going to be super, super, super exciting. Stoked about that. And this is one thing that if you're a JavaScript developer, this is mind-blowing. And if you write code in any other language, you're like, why are you talking about this? But if you're a JavaScript developer, I want to show this to you, right? So this is Angular 2. We use TypeScript to write Angular 2. And this is the idea that now that we have code that understands itself effectively, right? So this is me getting code completion in my IDE, which the first time I got this, it was like, right, I'm a web developer. I don't get this. And then when I screw up, right, again, I get messages, I get warnings. Before you compile your code, before you run it, it's like, hey, you did something wrong. And this is a big deal, right? And again, if you're like an Android developer, you're like, why are you talking about this? Because we don't get this as web developers, right? We don't get to do this. This, I think, is super, super amazing. So this is coming for us.
Yeah, one of the really awesome things, too, is the offline compiler generates TypeScript, right?
That's true.
In your templates, you will actually get error messages saying, oh, you misspelled something in this data binding. It doesn't actually exist on your component.
Yeah, I spent 30 minutes. I spent 30 minutes the other day going, what have I broken in the compiler? And it was actually telling me, no, actually, you've got something wrong in your template. And I had no idea. Again, this has never happened as an Angular developer that your template is checked. And it said, nope, you're wrong. Do that. So that's coming soon. Very, very cool.
So in Angular 2, you're writing these Angular components, and you're building applications by composing them, and that works really well. But there's also this thing out there called web components. And a web component is basically a custom DOM element that you make and attach some behavior to. And because they're normal DOM elements, and Angular works really well with all DOM elements, they actually fit really well into an Angular application. So this is a YouTube search page that we've written. It has an input where we want to type for something, and a list of search results, and a YouTube player. And this YouTube player is not actually an Angular component. It's a web component that someone's written that takes a video ID, and we just bind that video ID to the one that comes out of the search, and it just works. It's awesome. So we've talked about TypeScript. We've talked about this compiler. And in general, the JavaScript ecosystem is getting kind of complicated. Angular works with ES6 modules now. There's all kinds of compilation steps you have to do. So we really wanted to build something that would get that out of your way and let you focus on just building applications. And that's what our CLI is designed to do. It lets you focus on your app, and we take care of the tooling. So I'm going to show you how that works. So to start a new project with the CLI, you first npm install it, right? We're all used to doing stuff like this. And you say ng new my web app. And the CLI will set up an Angular application for you with a build script and all of that. And when you cd into it and say ng serve, it'll build your application. It'll start up a web browser, start up a web server, open the app in the browser, and actually watch the file system. So when you edit code in your IDE and save it, it'll refresh the browser, and it'll just start executing. So if you want to start doing mobile app development with Angular, we've added this -- mobile flag to the CLI. And when you say ng new -- mobile, we set up the same Angular application scaffold for you. But we also add a web app manifest. So you get a really nice install to home screen prompt in Chrome. And I think we add meta tags for Safari as well. And if you want to, it'll also set up a service worker. So you can do, your application will be reliable to work offline or online. It's integrated with the build process, so we figure out what static content your application has, and the service worker will cache it. And we set up that application shell for you with Universal. So you can use that shell render, shell no render, and it'll generate an application shell for you. So our CLI is not only designed to help you start up a project, but also to live with you as you go through the development process. It'll create your project and install dependencies. It'll help you scaffold your application. So every time you're creating new components or creating new routes or something like that, it'll set up the boilerplate for you. It'll help you at build time, run all the compilation process, generate service workers and manifests. It helps you set up and run tests, do CSS processing. And when you're ready to deploy to something like Firebase hosting that supports HTTPS, the CLI has integration for that too. It really lives with you throughout the development process.
So this is the thing that is very kind of interesting and kind of crazy to explain, and I love talking about it. So again, we've done a huge amount of work. We've optimized everything that we can in Angular 2, right? But we are still kind of at this disadvantage to native apps that they have the ability to take advantage of the whole application kind of power, right? They've got multiple processors and mobile devices now. And as a web developers, we're used to working in this world. We have this single thread that we can work with, right? We've got one thread, and we're actually sharing it with all the work the browser has to do, painting, rendering, all that stuff, right? And so this idea of multi-threaded web apps is kind of crazy, right? And we've had this thing called web workers for a long, long time. But you've probably never used them. Some people do, but very, very few people actually take advantage of web workers in their applications, right? And this is because they're really, really hard to work with, right? You have to kind of start up a script in the background. And then you're sort of you're remote controlling your application over this little tiny pipe, right? It's really hard to work with. Nobody uses them. And it's kind of a shame because we have all this power waiting just kind of to be unlocked, right? So again, in Angular 2, we wanted to take advantage of this. And so the same tech that lets us do server-side rendering and application shell and all these things where we're rendering in different contexts actually allows us to do something really interesting. So we can take your Angular application, we can move the whole thing, all of your code and Angular, into a web worker. And then we run a very, very lightweight rendering thread, basically. So your main DOM thread basically just has a really tiny listener. And all it does is talk to the DOM and listen to events, and then transfer everything to Angular running effectively in the background. And so rather than your application's lifecycle looking like this, where your app code is doing work, and then sharing and kind of competing for resources with the rest of the browser, we can split it up. And this means your application kind of gets to work freeform in the background, and then that main UI thread is kept really, really clean just for render and paint and all the things the browser needs to do. This gives you really, really incredible performance. This is experimental, right? Like, this may not be right for every app, but really, I think the point of this for us is that we want to be sure that for the next 5 or 10 years, whatever comes down the pipeline in the browser, we're flexible, right? And I think that this is the beginning of something very, very interesting from Angular. And so this is kind of close to the end of our talk, right? But I think the point that we want to get across is that this is really just the beginning for Angular 2, right? We're just coming into our release candidate. Go try it out. We want to see what you guys build with it. I think it's going to be really, really exciting. This whole progressive idea, right, there's been a lot of talk about it. I think that it's a really, really amazing concept generally for the web, and we just want to make that as easy as possible for everybody to get started.
Yeah, one of the things I've heard people say is that progressive web apps are like really good normal web apps that get superpowers in browsers that have all of this functionality. And Angular is the super heroic JavaScript framework, so we think they go perfect together.
Cool.
So if you want to check out our code, issue 0 is open source. We have the GitHub repo here. If you want to learn more about like their service worker and application shell integrations, mobile.angular.io has all of this content. And tomorrow, there is a talk by Jules and Kara from the Angular team, who are going to tell you more generally about Angular 2. That's at 4 p.m. tomorrow in Crater, so make sure to check it out.
So we'll hang around for questions if anybody has any. So
yeah,
feel free to step up. No questions? No questions?
Where are we actually?
Okay, glad you asked, because I did think a little bit further than you, since you've started driving and you've no idea where you're going. I thought since we went to the Boozer in England, we could this time continue the trend, but go to a vineyard.
Ooh,
Yes.
that's...
Keep it classy. See now, look at this, right? I kind of feel like, yeah, all right, like we did the pub before back in England, but I do think this is a slightly better view.
How qualified do you feel?
Not at all.
Yeah,
I know you're going through this. I know it's red or it's clearish kind of colour.
It's nice and it's not nice. It's one of those
It's-
very binary with my wine tasting.
And I have an upper limit of about £5 or $8, and if it's more than that, it's probably not worth it.
Anyway,
right. So I want, since we're here,
Yes.
we tend to talk about the web,
Mhm.
and today I think is no different. I want to talk about libraries and frameworks.
Ah, yes, because you're not big on the frameworks, are you?
No, and neither are you.
And
actually.
on the other hand, I am not big on the frameworks. Yeah.
Yes, I don't think there's going to be much of an argument, but I do want to talk about it because it bothers me that I perceive that the default state of developers is, I've got a blank page here, how am I going to fill it out? I need a framework. Which one do I use?
That is a problem I have with frameworks, that they have a way of starting projects. Like there's a kind of expectation to use them from the offset. And
Yeah.
I think if you're thinking, what combination of frameworks should I use to render this blank page, then I think something has sort of gone wrong. Yeah. For me, it's entirely from a performance point of view. Well, no, it's not actually. But okay, step one, performance. If your page has to load a ton of JavaScript in order to make a request for the actual data it's going to display, you've lost performance.
Yes.
And you can sort of say, oh, but next time it's going to be cached. It might not be. You might have changed the code, busted the cache.
And it's an assumption that somebody's going to come back again. Right?
Well, it's your goal, I would say.
It's your goal, but you don't know that somebody's going to. It's like paying a big, fat, hefty tax on the assumption you're going to get a repeat view. And
That's
you
true.
might not.
That is
you
true.
might not.
Yep.
And
stuff falls out the cache all the time.
Yeah, exactly. So
not the service worker cache, though.
Oh, you and service worker. Here we go again.
Service worker!
Da, da, da. One trick pony, Jake Archibald.
Come on, but it's got a cache, you can rely on it.
All right. Okay, performance that notwithstanding, I think for me, it's about code ownership somehow. It's about a level of trust that I don't necessarily feel. And what I want to do is I want to be able to feel like my application code is the thing that's running, that I'm not running through something else that I don't necessarily understand.
Running through something else is fine, because that's what a library is, right? That you've got
No,
you've got hold both ends, and you're running through bits of library that you don't understand.
Yeah.
But that's fine, because if one of them starts misbehaving, rip it out, either
Hotspot.
code it yourself or find a replacement
Yes,
library.
but when you're going through something else, to
Well, you're
kind of
in
get-
something else, I think,
Yeah,
with the
okay.
framework. And the framework will vend you little bits of, it'll give you scraps, and then you do something.
some more? I'd like to work with this application.
Can you please send this data over
More! Get out.
But then the frameworks, you're sat in a tiny bubble of the overall application with a framework. And I feel like to get the most out of a framework, you need to understand how the framework is built. And these frameworks are huge, so it's
They
really
are.
difficult to do
I
that.
actually feel maybe this is wrong, but it feels to me like it's a kind of, the decision is an ergonomics one. Like a developer's saying, my ergonomics trumps the user's requirements. I want to feel like, my job is easy, and what the user gets is what the user gets. And my whole approach is very much the other way. I'd rather go the extra mile, and all my users benefit, than my life is a bit easier, and I'll take some of the bad performance or the tax of using that framework. So I don't think that frameworks are inherently evil and to be avoided, but I think you want to be able to transition to one and say, yeah, now it feels like we're getting to the point where we're going to reinvent that. And I think you can only do that when you've got to a certain point with the build.
So for you, it's start light, start with libraries as when you need them, and then make the jump to frameworks only if you have to.
Agreed.
Dion, how you doing?
Hey, how's it going, Timothy?
I'm screaming to the IO gods. You want to try it with me?
Okay, let's do it.
Ah! We're here at the ground floor of Google I/O 2016. I'm here with Dion Almer. Dion, how are you doing?
I'm doing really well. Yourself?
I'm doing fantastic.
It's go time.
We are T-minus 2 days.
Yes.
As you can tell from the forklifts and the array of things yet to be put in their place.
We're going to make it, right?
I think we're going to make it.
Okay,
I'm
good.
told we're going to make it.
Good.
We're going to sneak around and take a look at the I/O grounds right before it gets done, so you get a behind-the-scenes look at how I/O 2016 came together.
Let's do it.
Oh, now this is a completely different microenvironment. It's cool. It's very nice, and it's huge too. I think there's going to be a lot of Android and some Firebase talks in here.
Yeah, even some improv comedy.
Is that in here too? Okay, let's go find some people. Okay, so Chet Haas is here to tell us about the cool stuff that's getting set up. Have you had a chance to walk around at all?
I walked into the tent where I was supposed to be.
And did you get set up?
I did for 3 different sessions that I'm involved in this week.
Excellent. Is there anything that you're going to announce that you don't want to tell our audience right now?
Yeah, we're going to need to bleep out the following phrase and this next one too.
Android.
Not yet.
Okay. What do you hope for this I/O outside of your sessions?
Really good developer engagement. Was that the phrase you were looking for?
Yes, thank you.
Excellent.
And how are you going to achieve that engagement?
So there's actually tons and tons of really good technical sessions that are going to be presented live in rooms where we can fit a bunch of people, as well as streamed live, most of them, as well as recorded. So they're available usually every year within about 24 hours of doing the talks, which is pretty amazing. So the thing I'm looking forward to is tons and tons of sessions and content out there.
Yeah. And you are doing your usual session this year again. What's new in Android?
Yes, I am, with Romain Guy and Dan Sandler.
And any surprises there that we can look forward to?
We're going to talk about Android and let me see. I'll try to build suspense for it, but no, I think you know generally what the kind of thing it's going to be in there.
All the new stuff.
Most of it. As much as we can fit in 45 minutes.
Tell me about the dinosaur.
Yeah, so have you used Chrome before? It's a web browser?
Yes, I've used Chrome before.
Have you ever been offline before?
once in 1998.
Nice.
Yeah.
So there's this fun little feature of Chrome where if you're offline, a little dinosaur comes up, and there's actually a game that's in there, and you start hitting the spacebar and it jumps around. And this year, we want to kill this dinosaur. We want to kill it.
But no, I totally know what you're saying, though. It's like every time I'm on my mobile device and the service cuts out and my experience stops because of it, it's a bummer.
Yeah, exactly.
And it doesn't have to.
It doesn't have to. And like, we always think of the offline use case of like, oh, what if we make it so when Timothy's on a plane, it still works? But in reality, with cell networks and the like, it's going up and down all the time. Yeah. So you don't want to just be in that second where you've got poor network capability, oh, it stops responding. Now you can take ownership of that.
I think, we're going to explore this in some detail again later, too. But the cool thing is it's got an NFC, and you can just tap your Android phone, and it keeps score for you.
So what would the score be right now if we'd...
You'd be winning. Decisively.
I'm British, so, table football is in my blood. Thanks for hanging out, man.
Hey, Dion, thanks for hanging out with me as well. It was really fun to explore behind the scenes at Google I/O 2016 with you.
Yeah, I hope the developers have a great time this year.
I think that they will.
Firebase makes authentication easy for end users and developers. Most applications need to know the identity of a user so they can provide a customized experience and keep their data secure. Firebase supports lots of different ways for your users to authenticate. If your users want to authenticate with their email address, you can build that for them. Firebase Auth has built-in functionality for third-party providers such as Facebook, Twitter, GitHub, and Google. It can also integrate with your existing account system if you have one. You're given the choice about how to present login to the user. You can build your own interface, or you can take advantage of our open source UI, which is fully customizable and incorporates years of Google's experience in building simple sign-in UX. No matter which one you use, once a user authenticates, 3 things happen. Information about the user is returned to the device via callbacks. This allows you to personalize your app's user experience for that specific user. The user information contains a unique ID which is guaranteed to be distinct across all providers, never changing for a specific authenticated user. This unique ID is used to identify your user and what parts of your backend system they're authorized to access. Firebase will also manage your user's session so that users will remain logged in after the browser or application restarts. And of course, it works on Android, iOS, and the web. That's Firebase Auth, allowing you to focus on your users and not the sign-in infrastructure to support them.
Hey there, Polycasters, Rob here. Welcome back to the show. As we've been working on Polymer, one of the probably biggest requests that comes in from developers is when are we going to get a CDN for Polymer and for web components? Because it's kind of a pain in the butt every time you want to sort of like hack on an idea and you've got to use Bower and install a bunch of packages and wait for everything to download just so you can, play with stuff. So recently, the Polymer team has put out a brand new project, which is called PolyGit. It is a development CDN, which I'll talk about what that word means in just a second. But basically, it is a CDN that includes Polymer, all the Polymer elements, and the web components polyfill. So if you want to hack around using something like JSBin and Polymer, you can totally do that. So if you go to the website polygit.org, you see that it bills itself as the Polymer Magic Server. And what it's actually doing under the hood is it's just using GitHub's RawGit CDN and extracting things from there and pulling them into, JSBin or wherever you want to use the CDN. So what I want to do here is just sort of like show you some examples of how you can use the CDN, how you can configure it to actually pull in your own packages as well, and basically just get hacking really quick. So over on jsbin.com, I've already set up this little sample bin. And the main thing to notice here is I'm using this base tag right here. And if you're not familiar with a base tag, in HTML, a base tag or a base element, it just allows you to set a URL. And then any sort of subsequent URLs that you use, like for script tags or imports, they will all be relative to that base. So what we're saying here is we want the base URL to be polygit.org/components. This components directory is where Polymer and all the Polymer elements and all that good stuff lives. And from here on out, if we have any relative URLs, it'll just pull stuff from that directory. So I'm pulling in web components.js. It's coming from that directory. I can import polymer.html. That'll also come from that directory. And so since we've got all this working off of our CDN, now we can actually sit here if we want. We can just create our own Polymer element right on JSBin. So I'm going to do that right out of DOM module here. I'll give it an ID of like xfoo. And I'll give it a template that just says like hello from xfoo. And I'll also give it a little script tag. And inside of here, we will call the Polymer constructor. And we're going to say it is an xfoo element. And then the last thing we want to do is we want to just make sure that we use our xfoo tag somewhere in the page. And now you can see it showing up over there in our output. So this is really great if you're hanging out on the Polymer Slack channel, you run into a bug or some issue, and you're not quite sure how to explain it to folks. You can just go throw together a JSBin using polygit and then share that JSBin with people so they can help you get unstuck. Now, I also mentioned that all the Polymer elements that we built are included in this CDN as well. So what you can also do if you find maybe a bug or an issue with something like paper tabs is you can go over here and you can just write an HTML import for paper tabs. So instead of just Polymer, I'll also pull in paper tabs. And then you can just start using that element in your page here. So I'll say I want a set of paper tabs. And then inside of here, I will write out maybe like 2 or 3 paper tabs. So we'll say this first tab is called foo. Second one is going to be called bar. And the last one will be baz. Foo, bar, baz. And there we go. Now over here in our output, I've got these 3 paper tabs working just as I was expecting. And if I had some issue, I could then take this. I could save this JSBin. I could go file a GitHub issue and point the engineer at this particular JSBin. And that way, it's going to help them triage that issue a lot faster and help them debug the actual problem that you're running into and hopefully get things fixed. Now, one of the coolest things about polygit is that it is configurable. So not only does it pull in Polymer and the elements that team has created, but you can add your own GitHub repos to it as well. So if you go back to the polygit.org website, you scroll down here to the bottom, you can see that there is this sort of interesting configuration syntax. And it might look a little weird when you first see it. It took me a few times kind of working through it to understand what it's doing. But basically, what you want to do is when you are defining that base URL, you can configure it by saying, oh, I would also like to include this component. And this component might live like inside of some particular org. And maybe you want a particular version, like version 1.2.3. Or maybe you want a branch, right? Maybe you want like the master branch. That's some good handwriting right there. Or maybe you want just the latest tag. So if you include an asterisk, instead of pulling a particular version or a branch, it'll just give you whatever the latest tag happens to be. So to show you an example of that, I've again got a little JSBin here. And I'm just going to paste in a better URL here. So what I've done is I've configured polygit to pull in 2 additional dependencies. The first is the markdown.js library, which is in the chjj org on GitHub. And I've told it to grab the latest tag. And I've also told it to pull in the mark-down element, which is something that I wrote myself. That lives in the Rob Dodson org on GitHub. And again, I've just told it to pull in the latest tag there. So now both of those are available in that CDN components directory. So I can just go ahead and write an HTML import to pull in the markdown element. And then over in my body, I can just start using it. So I can have a markdown tag. And we'll just drop in like a hello world for the header there. And we can see we're getting this sort of like huge H1 rendering over there in the output. So if you're working on an element or a project or something like that, and you want to show that to folks on JSBin, you can absolutely do that using polygit as well. The one caveat there is that it has to have been published for at least 1 hour for it to be picked up by the rawgit caching CDN. But once it's been published for about an hour, it should be available to you on polygit. Now, the last thing I want to mention here is at the very beginning of the show, we said that this is a sort of development time CDN. And what I mean by that is it's not a CDN that you want to use for production. And the reason is because we're not doing any sort of like vulcanization or anything like that to optimize the elements that we're sending down. Instead, you're getting an individual dependency for everything that you import, which is actually pretty expensive in terms of HTTP requests. So it's great for development time. It's great for hacking on ideas. But when you get to the point where you want to launch something into production, you still want to use a package manager like Bower. You still want to use a process like Vulcanize to make sure you're sending down the absolute smallest payload possible. But if you just want to mess around with some ideas, it's perfect for that. So that about covers it for today. If you have any questions, please leave them for me down in the comments. Or you can always hit me up on a social network of your choosing at #AskPolymer. As always, thank you so much for watching, and I'll see you next time.
Welcome back. We've covered a lot of ground already, so today I want to review and reinforce concepts. To do that, we'll explore two things. First, we'll code up a basic pipeline for supervised learning. I'll show you how multiple classifiers can solve the same problem. Next, we'll build up a little more intuition for what it means for an algorithm to learn something from data. Because that sounds kind of magical, but it's not. To kick things off, let's look at a common experiment you might want to do. Imagine you're building a spam classifier. That's just a function that labels an incoming email as spam or not spam. Now say you've already collected a dataset and you're ready to train a model. But before you put it into production, there's a question you need to answer first. How accurate will it be when you use it to classify emails that weren't in your training data? As best we can, we want to verify our models work well before we deploy them. And we can do an experiment to help us figure that out. One approach is to partition our dataset into two parts. We'll call these train and test. We'll use train to train our model, and test to see how accurate it is on new data. That's a common pattern, so let's see how it looks in code. To kick things off, let's import a dataset into Scikit. We'll use Iris again because it's handily included. Now we already saw Iris in episode 2, but what we haven't seen before is that I'm calling the features X and the labels Y. Why is that? Well, that's because one way to think of a classifier is as a function. At a high level, you can think of X as the input and Y as the output. I'll talk more about that in the second half of this episode. After we import the dataset, the first thing we want to do is partition it into train and test. And to do that, we can import a handy utility, and it makes the syntax clear. We're taking our X's and our Y's, or our features and labels, and partitioning them into two sets. Xtrain and Ytrain are the features and labels for the training set, and Xtest and Ytest are the features and labels for the testing set. Here I'm just saying that I want half the data to be used for testing. So if we have 150 examples in Iris, 75 will be in train and 75 will be in test. Now we'll create our classifier. I'll use two different types here to show you how they accomplish the same task. Let's start with the decision tree we've already seen. Note there's only 2 lines of code that are classifier specific. Now let's train the classifier using our training data. At this point, it's ready to be used to classify data. And next we'll call the predict method and use it to classify our testing data. If you print out the predictions, you'll see there are a list of numbers. These correspond to the type of iris the classifier predicts for each row in the testing data. Now let's see how accurate our classifier was on the testing set. Recall that up top we have the true labels for the testing data. To calculate our accuracy, we can compare the predicted labels to the true labels and tally up the score. There's a convenience method in Scikit we can import to do that. Notice here our accuracy was over 90%. If you try this on your own, it might be a little bit different because of some randomness in how the trained test data is partitioned. Now here's something interesting. By replacing these two lines, we can use a different classifier to accomplish the same task. Instead of using a decision tree, we'll use one called k-nearest-neighbors. If we run our experiment, we'll see that the code works in exactly the same way. The accuracy may be different when you run it because this classifier works a little bit differently, and because of the randomness in the train test split. Likewise, if we wanted to use a more sophisticated classifier, we could just import it and change these two lines. Otherwise, our code is the same. The takeaway here is that while there are many different types of classifiers, at a high level, they have a similar interface. Now let's talk a little bit more about what it means to learn from data. Earlier I said we called the features X and the labels Y because they were the input and output of a function. Now, of course, a function is something we already know from programming. Def classify, there's our function. As we already know in supervised learning, we don't want to write this ourselves. We want an algorithm to learn it from training data. So what does it mean to learn a function? Well, a function is just a mapping from input to output values. Here's a function you might have seen before, y equals mx plus b. That's the equation for a line, and there are two parameters, m, which gives the slope, and b, which gives the y-intercept. Given these parameters, of course, we can plot the function for different values of x. Now, in supervised learning, our classify function might have some parameters as well, but the input x are the features for an example we want to classify, and the output y is a label, like spam or not spam, or a type of flower. So what could the body of the function look like? Well, that's the part we want to write algorithmically, or in other words, learn. The important thing to understand here is we're not starting from scratch and pulling the body of the function out of thin air. Instead, we start with a model, and you can think of a model as the prototype for or the rules that define the body of our function. Typically, a model has parameters that we can adjust with our training data, and here's a high-level example of how this process works. Let's look at a toy dataset and think about what kind of model we could use as a classifier. Pretend we're interested in distinguishing between red dots and green dots, some of which I've drawn here on a graph. To do that, we'll use just two features, the x and y coordinates of a dot. Now let's think about how we could classify this data. We want a function that considers a new dot it's never seen before and classifies it as red or green. In fact, there might be a lot of data we want to classify. Here I've drawn our testing examples in light green and light red. These are dots that weren't in our training data. The classifier has never seen them before, so how can it predict the right label? Well, imagine if we could somehow draw a line across the data, like this. Then we could say that dots to the left of the line are green, and dots to the right of the line are red. And this line can serve as our classifier. So how can we learn this line? Well, one way is to use the training data to adjust the parameters of a model. And let's say the model we use is a simple straight line like we saw before. That means we have two parameters to adjust, m and b. And by changing them, we can change where the line appears. So how could we learn the right parameters? Well, one idea is that we can iteratively adjust them using our training data. For example, we might start with a random line and use it to classify the first training example. If it gets it right, we don't need to change our line, so we move on to the next one. But on the other hand, if it gets it wrong, we could slightly adjust the parameters of our model to make it more accurate. The takeaway here is this. One way to think of learning is using training data to adjust the parameters of a model. Now here's something really special. It's called TensorFlow Playground. This is a beautiful example of a neural network you can run and experiment with right in your browser. Now this deserves its own episode for sure, but for now, go ahead and play with it. It's awesome. The playground comes with different data sets you can try out. Some are very simple. For example, we could use our line to classify this one. Some data sets are much more complex. This data set is especially hard, and see if you can build a network to classify it. Now you can think of a neural network as a more sophisticated type of classifier, like a decision tree or a simple line. But in principle, the idea is similar. Okay, hope that was helpful. I just created a Twitter that you can follow to be notified of new episodes, and the next one should be out in a couple of weeks, depending on how much work I'm doing for Google I/O. Thanks as always for watching, and I'll see you next time.
So in a previous video, you learned that you can use GCM to send notifications through APNS to iOS devices. But to many developers, APNS is a bit of a black box. And come to think of it, so is GCM. Put them together and you've got a black rectangle, I guess. Well, personally, I find having a little background on how things work underneath the hood can help out a lot when stuff goes wrong. So let's shine a light on half of this big old rectangle on this episode of Route 85. So APNS is a service that sends notifications to iOS devices, whether the target app is in the foreground or in the background. So how does it work? Well, for starters, you need two important configuration bits to make this happen. First off, the device token. You can basically think of this as the address of the device you want to talk to, but one that's unique for your app. It's also not really the address of the device. You know how when rock stars check into a hotel, they use a fake name? Well, the device token is kind of like having that fake name. It lets the hotel manager know that, hey, it's cool for you to visit your rock star friend because you know the alias that they're checked in under. Is that Matt and Kim? Kind of looks like them, right? Yeah. So when your app gets permission from your user to receive notifications, iOS talks to APNS and requests a device token, basically a fake rockstar name, which is then given to your app. Now, if you were just building an iOS app using nothing but APNS, you'd need to pass this token back to your server somehow. We'll get into what GCM does at a later point. When your server passes this device token back to APNS, it's your way of both identifying the device you want to talk to, as well as proving to APNS that you're allowed to notify that device in the first place. The next bit you need is the APNS certificate. This basically allows your server to talk to APNS securely. And hang on, we've got some massively oversimplified explanations coming your way. One common way for two devices to talk to each other securely is to use public and private key encryption. Alice encrypts messages using Bob's public key, which only he can decode on his side using his private key, and then, vice versa. So let's imagine your server is Alice in this scenario. And if you want to talk back and forth to APNS, you're going to need
All right, this is going to be something that you will remember, I think. Okay, hello everybody. My name is Ron, and I work in developer relations at Google. I spend most of my time on Launchpad. Launchpad is Google Developers' global startup program. Today, I'd like to share with you some of the things that we've learned working with startups globally. Mainly common challenges related to the never-ending question of what should we build next. I will also share with you some best practices that we know that are working for startups and how you can leverage Firebase to use them. Let's take a quick look at Launchpad. So today we operate in more than 30 countries. We worked in 2015, we worked with 6,000 startups worldwide, and we provided more than 50,000 hours of one-on-one mentorship. Now, through those 50,000 hours of mentorship, we've learned what drives startup success and what doesn't, what works and what doesn't work. Now, we know that startups are not the same. Okay, you can't say that all startups are the same, but there are some common challenges and problems that every startup needs to solve. First, there is the technical challenge. Can we build it? Next, there is the product challenge. All right, we can build it. Do people need it? Will they use it? Next, there is the market challenge. All right, we've built it. There are some people who need it. They want to use it. Can we reach them? It's not that trivial. First challenge is the scale challenge. When you think about it, startup scales in almost any aspects, from users to number of employees to operations. How do you do that and still maintain your insanity? And last but not least, the financial challenge. How do you make that profitable? How do you make money out of your app or your business? Today, I'm going to focus mainly on the product challenge, or the way I like to call it, how to build products that people need, that people actually use. Now, usually, when I talk about the product challenge, people automatically think that it's related only to early-stage startups, to teams that didn't release the product yet, that are seeking product market fit. Those three guys with a Mac and a hoodie walking down University Avenue in Palo Alto. But the truth is that product challenge is a never-ending challenge. And you live it every single day in this amazing journey of building successful products that drives successful businesses. It doesn't matter if you have 0 users, 10K users, or 10 million users. You keep asking yourself, what should I build now? And I'd like to start and sharing a story with you. It's a story about a good friend of mine. She was supposed to be here, but she couldn't make it. I'd like to introduce you to Ronnie. Now, Ronnie is awesome. She's super smart. She writes Android code. She writes iOS code. And she has this lovely dog named Nala. And Nala loves Android. She also likes to run outside, to go on long walks, hang out in the park. And Nala is a very playful dog and very super friendly dog. She likes to play with other dogs as well. So one day, Ronnie thought, hey, why don't I build these hyper-local social networks for dogs and their owners? And you know what? Being this super awesome girl, that's exactly what she did. She sat down over a weekend and came up with this app that basically lets you see other dog owners walking out their dogs around you. So you can know when to walk the dog and potentially make new friends for you and your pet. And she released this, what you might call MVP, and suddenly, boom, she tweets about it. Some bloggers picks that up, and suddenly Ronnie has 20,000 installs, 5,000 daily active users, people who use her product, use this MVP every single day. She lends herself $200,000 in seed money, quits her job, and focuses on adding features. In other words, building her product. Now, Ronnie is smart. I've said that, and I can't say that too many times. And she knows everything about Lean Startup. and she knows she needs to validate things. She knows she needs to do user research, and that's exactly the very first thing that she is doing. She builds this amazing landing page, again, featuring Nala, telling people about the product that she's about to release, and allowing them to leave their email address if they're interested to hear more about it or join the private beta. And of course, she checks conversion rate. Then she sends out some push notifications to her loyal users, asking them, hey, would you like to get vet recommendations based on user ratings? Would you like to see that or that in the app? And users can say yes or no, and of course, she checks conversion rates. Lastly, just to be extra sure, she went out and she speaks with her users, like in the real world, speaking with them. She buys them coffee, she shows them her mock-ups, and she asks them 3 questions. Would you use it? Would you pay for it? And how much will you pay for it? Based on her user research, she builds what she thinks is a great product. She publishes it on App Store and Google Play. She's ready to take off, but unfortunately, she crashes. She didn't get the traction that she wants. Now let's see, and let's take a look at what went wrong here. The very first thing Ronnie did was using a landing page. She used it in order to figure out if people want such an app, if people need it. But in fact, landing page can answer only one single question. Are people interested enough to give me their email address? It doesn't say anything about do people need it and will people use it. The second thing that Ronnie did is listening to her users, either in person or via push notifications. But the very first rule in user research is never listen to users. I know it sounds funny, but bear with me for a moment. Never listen to your users. Instead, watch and observe their behavior. The reason is that we, human beings, we're very bad at predicting our own behavior. There's almost zero correlation between what we say we will do and what we actually do. Psychologists know that, user researchers know that, developers don't. So, I'm here to help. Let's see what Ronnie could have done differently. I'd like to introduce you to a methodology proved to be working. Build, experiment, optimize. Now, being an engineer, I feel very comfortable with the build stuff. To me, writing code is not a job, it's a hobby. It's something that I like to do, and that's my sweet spot. And I'm pretty sure I'm not the only one in the room. So let's move to experiment. What is a good experiment? What do I want? What am I looking for in my experiments? A good experiment is fast. I want to get results quickly. I don't want to wait forever to figure out what my next move is. A good experiment is efficient. I'd like to be able to run experiments without investing a lot of manpower. I'd like to run experiments. It doesn't matter if we're talking about a small team or a big team. Ideally, one person will be able to run multiple and manage multiple experiments simultaneously. And last but not least, good experiments provide me with real data. Watch your users. Remember, observe their behavior. We act upon real data and not gut feeling. I need a system that will allow me to track data, analyze it, and act upon it all in one place. Make data-driven decisions. Now, unfortunately, if you wanted to run experiments, you'd have to use multiple products, from analytics to A/B systems to push analytics to whatnot. That means that you need to integrate multiple SDKs into your apps, Android and iOS. That means that you need to write some code in your server side. That means that you need to face some data integration issue and deal with data discrepancies between systems. It means that you don't have one single place with all the data. Well, that was the situation until we announced Firebase today. So if you've been to the keynote today, you've probably heard about Firebase. If you haven't been to the keynote, I suggest you get up, go outside, find a time travel machine, go back in time to watch the keynote, because the keynote was awesome. And for the keynote, there's a t-shirt here. All right. You know what? Can I get a hell yeah for the keynote? Yeah! All right, let's do A/B testing. This side, can I get a hell yeah? Yeah! What about that side? Yeah! T-shirt goes there. What? All right. Firebase. Firebase is a suite of integrated products designed to help you build your app, grow your user base, and earn money. It helps developers build better apps and grow successful businesses. And Firebase is cross-platform because we know and we understand that there is more than one platform out there. So Firebase has all these great features that you can see here. And obviously, I will not go over all of them. I will focus mainly on what makes Firebase such a great experimental framework, Firebase Analytics and Remote Config. So let's start with Firebase Analytics. Firebase Analytics is the heart of the Firebase platform. First, it's free and unlimited. Now you can learn and understand everything that your users are doing without compromising. 100% free. That means no hits limits, no quotas, no sampling, 100% pure data for free. It also has automatic event reporting, which means that as soon as you integrate Firebase Analytics into your product, without adding any lines of code, we automatically track some key events like app opens, etc., and in-app purchases and other stuff. And you get out of the box key metrics that are important to you. Things like monthly active users, average revenue per user, average revenue per paying user, and some more. Firebase Analytics is so powerful because it is tightly integrated with Firebase and with Google. Now you can take the data, make some insights, and immediately turn those insights into action items. And we'll see how you do that later. And last, it's your data. All the data that we track and collect in Firebase Analytics is your data. With very few clicks, you can export all your data to BigQuery, connect it to whatever tables that you have, and run anything from queries to machine learning to prediction APIs. It's your data. Now let's take a look what it takes to add Firebase Analytics into your product. You started the Firebase console. And you get this lovely screen when you can add either Android app, iOS app, or web app. You go, small configuration phase, you get a config file that you download and add to your project. And then it is a single line of code in iOS, grabbing Firebase from CocoaPods, and a single line of change in your build Gradle file. That's it. You do that, you log into Firebase console, and you immediately get the analytic dashboard right out of the box. Here you can see so many things from active users, 1 day, 1, 7, 30 days, to retention cohort, to ARPUs, and demographics, and so much more. I don't have time to go through all of it. I will focus on the things that matter to us. All right. Remember our goal? We want to watch and observe our users' behavior. So let's take a closer look at how Firebase Analytics helps us do that. And like many other analytics systems, Firebase Analytics is an event-centric system. It means that it tracks and collects event. And logging event is super, super easy. First, you grab a reference to a Firebase Analytics object and initialize it. Then, you can use the log event API. Here is a short example how I would use it when a user clicks on some item in my app to view more details about it. As you can see, the API is pretty straightforward. You build a bundle, and you call log event with that bundle. Now, deciding what to log and when can sometimes be a bit tricky. And that's why we came up with some suggested schemas, like you see here. Item ID, item name, and content type. But of course, you can use whatever schemas if you want, just in case you don't like ours. Once you do that, you can go back to the console, and you immediately see all the events, and you can drill down an event to see more information about it. Now, thing is that we want to track users' flow. We don't want to track single interaction. We want to track a whole interaction with what the user is doing, and that's where funnels come to help. Funnels come to help. Great. So a funnel is a series of events that are important to us, that we're interested in. As soon as you define a funnel, let's say user browse through some items, add an item to a cart, and purchase it. That's a series of events that we're interested in. As soon as we define this funnel, Firebase Analytics will track users that go through this journey and will tell us at any given stage what's the conversion rate, how many users moved from one stage to another, how many added an item to the cart, how many actually made the purchase. It's a great tool to check where you're losing users and where you need to improve. Now, I've said a minute ago that Firebase Analytics is an event-centric system, and that's true. But Firebase Analytics is also a user-centric system. And that's what makes it so unique, being both event-centric and user-centric. We all know that users are not the same, okay? And different users behave differently. So in order to really understand our users and what they're doing, we need to be able to define different groups of users. We call those groups audiences. And we need to break down every single report based on those groups or audiences. Everything from funnels to event to ARPUs to active users to retention, everything. And Firebase Analytics does all that. Now, when you think of an audience, you immediately think of males versus females, different age groups, maybe some geolocation, language, or some other common attributes like device, OS type, OS version, app version, etc. Firebase Analytics obviously has all that, but it also lets you define your own user properties, like, I don't know, users that shared an item at least once, or users that reached level 5 in my game. Now, remember what we need from our experiment framework? Firebase Analytics takes care of providing us with real data and data that we can act upon. But we still need to be able to make quick and fast changes in our apps and the way our app behaves. And this is exactly why we've built Remote Config. As a matter of fact, Remote Config started as an internal system we used at Google. First, we used it in the framework, GMS, and then we opened it to internal Google apps like Gmail, Play, and it saved us so many times, and it proved to be so valuable to us that we said, all right, maybe other developers can benefit it, and we're opening it today on Android and iOS. Remote Config lets you store key and value pairs in the server and change them remotely. You can change them to all users or a specific demographic like language, device, app version, OS version, etc. You can also do stage rollouts like change values to 10% of the users in North America. And since everything is so integrated with analytics, you can target different audiences with Remote Config. For example, let's say that I'm building this great game, and I'm not sure how hard I need to make this game. So I set up with Remote Config the game difficulty level. And I can change it remotely. But I can do even more. All right? Let's say I can make the game harder for people who reached level 5 in less than 2 days. And I can make the game easier for people who are struggling with level 1 for more than 2 hours, so they won't get frustrated. You know what? Let's see how I would do that. First, I initialize Remote Config and set some default values to it. So just in case I don't have any network or something, I do have the default values. Then I call fetch and activate fetch to grab the new values from the server. And then anywhere in my app, I can use these values in my code simply by calling get int, get long, get string, etc. As simple as that. Pretty straightforward. Now, don't worry about calling multiple fetches and stuff. We have under the hood, we have a caching mechanism, and we know how to turn, in case the cache is valid, to make fetch a no-op. And there is a good remote config talk, I think, tomorrow. All right, back to our game plan. So with Firebase Analytics and remote config, I can run experiments. And I can change my game difficulty level pretty easily. But I still don't know what is the right difficulty level that I should stick with. In other words, what am I trying to optimize here? Now, everything that you optimize, everything that you change, every feature that you add, every little thing in your app needs to show significant improvement in one out of the three. Conversion from free to paid, actual users that are paying for your app, are paying for your service. Time spent in app, increase the time that users are using your product. And retention, make your users use your product or app more often. So I'd like to show you how App in the Air use this framework, a very similar framework, and Firebase to run those experiments, learn, and optimize their product and their business. So App in the Air is basically a personal travel assistant that gives you consistency and all the resources and the information that you need about your flight and travel, regardless of what airline you're using and where you fly. They also released an SDK recently, so other developers can plug into it. What I like about App in the Air, it provides some additional features that can actually save you time and money, like airport trips and the queue for security in the airport. I really like that. Let's see how App in the Air used Firebase to validate things that they're doing. First thing that they did, they defined a funnel that represents the main goal of the app, or their main KPI, if you wish, which is user opens the app, adds a flight, and makes a purchase. That's the core metric of the business. They defined a funnel, and this is what they got. You can see that 29% of the users added a flight, and 7.2% of those users actually made a purchase. But that is across all users. So they started filtering this funnel based on different demographics and other parameters. Actually, they used about 18 different properties and attributes to filter and take a deeper look at what their users are doing. And here are some interesting things that they've learned. Users between age 18 and 24 have 2 times, they have 2 times add flight conversion. They add more flights. And they have 1.5 times purchase conversion. They looked at other user properties and also found out that users that are running Marshmallow also convert better. Almost 2 times add flight and 1.4 times make a purchase. So just by looking at Firebase Analytics with audiences, breaking out what users are doing, they immediately got some very interesting and crucial action items. First, we need to investigate why we have this difference in performance. Second, let's check issues on bad OS versions. Maybe users with KitKat, the app doesn't crash on KitKat, but maybe there's a problem there. Maybe we're slow, maybe we're laggy, maybe there's a glitch in the UI. I don't know, but it makes sense to experiment that. And it also allows them to know which users to engage that are more likely to make a purchase. So one of the things that they decided to check was the onboarding process of the app. So they used remote config, as you can see here, to define a quick experiment. 50% of the users will get a welcome screen explaining what the app is doing, and they will get 1 free credit to get Flight Alert, to actually test the service before they buy. And the other 50% of the users will not get a welcome screen, they will not get the free credit for flight alerts. And they compared the conversion rate based on those groups. And when they compared, this is what they saw. So add flight conversion is pretty similar. Okay? The welcome screen, having a welcome screen and a free credit, or not having a welcome screen, a free credit, didn't change the conversion for add flights. But one group actually purchased 2 times more than the other group. Now here's a question for you guys and girls. Which group purchased more? The group that got a welcome screen. Nice welcome screen. Hello, welcome to Up in the Air. This is what we do. Here's a free credit you can try before you buy. Or the group that installed the app, opened it, and they were immediately in the screen. They needed to figure out what to do. Who thinks it's the group with the welcome screen? Who thinks it's the group with the no welcome screen? Who doesn't think? All right, yeah, it doesn't, it doesn't add up. All right, good. That's exactly why you need to make data-driven decision and not gut feeling. Apparently, having a welcome screen and offering a free credit made people buy less. So the very first call to action that Up in the Air did was going back to remote config and change that group that doesn't get a welcome screen from 50% to 100%. And the result? 2 times purchase across both iOS and Android. Actually, if you studied, Tim, who actually implemented all of that, is sitting here. Another thing that they did, which is very interesting. So Up in the Air, they run their application server on App Engine. And obviously in their server, in their backend, they have lots of data about the users, like preferences and history of purchases, and tons of other stuff. But now with Firebase Analytics, Firebase Analytics also stores data about users' behavior. So Up in the Air linked the two. And they started running some secret sauce of prediction APIs and some crazy queries. And they found out something very, very interesting. They found out that there is a group of users that you can define based on multiple parameters, which is more likely, 3 times more likely, to fly business. Okay? Immediately as the user opens the app, you can predict that this user may fly business. Okay? That means that those users, they value convenience over price. So immediately, as soon as a user in that group opens the app for the first time, before they do anything, Up in the Air can customize the suggestions and the ads that those users sees, because they know that maybe they like luxury hotels, or better cars, or better flights. And this is what I call a win-win-win. Actually, the result from this thing was a significant increase, not only in the conversion rate of how many people actually purchased, but also in the average revenue per paying users, because they purchased more expensive items. Again, win-win-win, just by looking at data and make data-driven decisions. So, back to Ronnie. She starts using Firebase to validate her ideas, and now she's super, super happy. This is a picture from today, actually, that she sent me. She's super, super happy with new friends for her and for her dog, Nala. So For more information about Firebase Analytics and remote config and how you can start using it today to validate your ideas, to run experiments, and to optimize everything in your app, please go to our docs, our support, and their office hours. Today, we just ran out of them, but there are office hours tomorrow and on Friday. Look for the people with the yellow shirts that are hanging around here. They will be more than happy to help you integrate Firebase today. Thank you, everybody. And now, if you have questions, we have some time. We have some time. Now what? Not for this side. Questions? So either nobody listened or everybody understood everything. Okay, great.
Hello, I'm Timothy Jordan, and you're watching the Google I/O 2016 live stream. It's been a great day so far, and there's lots more to come. Stay tuned on all 4 live stream channels for sessions throughout the day. We'll also be on the ground and behind the scenes, finding the coolest and most innovative things to share with you right here on the live stream between sessions. And if you want us to track down somebody with your question, use the hashtag AskDevShow. Hello and welcome to the Developer Show. I'm Timothy Jordan, and I'm standing here with Mary Grove, Director of Google for Entrepreneurs.
Hi, Timothy.
Hi, Mary. How are you?
I'm great. Thanks for having me.
Thanks for being here.
Absolutely.
Okay, let me jump to a question about Google for Entrepreneurs. It's been on my mind for a little while because developers ask it, and I think it's fair, and I think we should give them an answer. Why is Google doing this?
It's a great question. I'm glad you asked. So there's 2 ways that I look at that. One is if you look at Google's own history, our own journey as a company, entrepreneurship is such a core part of our DNA, right? Google began as a startup in a garage now almost 20 years ago. We are a company founded by entrepreneurs, built by entrepreneurial people, and then it makes sense that we are passionate about empowering the next generation of startups like Google to become successful, to launch, to use the internet to grow their business. So that's the first reason.
Mm-hmm.
The second reason, though, is actually an economic one, right? We believe that by investing in communities, long-term investing in startup communities, these are the next set of companies who are going to come online, use the internet, leverage Google's products as well. So really it's this notion that all boats rise, and long-term it's also going to benefit our own business too.
Now, before you were the director of this huge, amazing thing, you were a BD principal at Google. And I'm curious, what did you learn doing those global partnerships that brought you into this new job?
Sure. So my personal story with entrepreneurship begins with my parents. So my parents are both immigrants from Thailand, and they moved to America, sort of personify the quintessential American dream. They were entrepreneurs and really showed me firsthand that you can really, create whatever future you dream for yourself.
Mm-hmm.
So at Google, fast forward many years later, I was working in new business development, as you said, looking at emerging markets for Google. And everywhere we worked, we looked for 3 things. One is how can we increase access, so internet and mobile penetration. 2 is how can we increase content created from these regions. And the third bucket, which was my personal sort of passion, was entrepreneurship. So how can we work with students, developers, any emerging entrepreneur ecosystem to really help them create the next generation of companies and really create and grow their own economies.
So let's say you're a budding entrepreneur out there with an early stage startup. What's your first step getting help from Google?
There's many ways to look at that, right? There's so many amazing groups and networks that Google has. Of course, Google Developer Groups being one of them, Women Tech Makers being another great example. We, at the heart of it, are a technology company, so we hope that our products, our platforms can help you be successful. Beyond that, in the Google for Entrepreneurs umbrella, our mission is really about bringing together startup communities. So working with partners of all types, whether that's physical space, co-working, tech hubs, to accelerators and educational curricula. We try to knit together this global partner community of about 50 organizations who are supporting entrepreneurs. So we encourage you to get involved with one of them. For example, Techstars is a global accelerator running all sorts of programs ranging from Startup Weekend to their vertical accelerators. And you can find all these resources on our website, which is google.com/entrepreneurs.
Awesome. Is there anything else that you'd like to say about the program that you don't often get to talk about?
You know, I think that we're based here in Silicon Valley, but Google is truly a global company. The internet has really democratized access to entrepreneurship, right? You can launch a company from Sao Paulo, Brazil, and have users in Seoul, South Korea instantly. And so what I would say is we passionately believe that entrepreneurship's thriving all over the world. It's about getting more access, getting more opportunity, and helping companies really go global from day one and think about their market opportunity as not just their city or their country, but really the whole world.
Mary, thanks for joining me today.
Thanks, Timothy. Thanks for having me.
For more information about Google for Entrepreneurs, make sure to check out the show notes for all the links that you need. I'm Timothy Jordan, and I'll see you next time.
We all know from experience that people love to share things about themselves, such as photos, videos, and GIFs that express their feelings. So what do you do to let them store and share these files through your app? That's where Firebase Storage can help. Our storage API lets you upload your users' files to our cloud so they can be shared with anyone else. And if you have specific rules for sharing files with certain users, you can protect this content for users logged in with Firebase authentication. Security, of course, is our first concern. All transfers are performed over a secure connection. Also, all transfers with our API are robust and will automatically resume in case the connection is broken. This is essential for transferring large files over slow or unreliable mobile connections. And finally, our storage, backed by Google Cloud Storage, scales to petabytes. That's billions of photos to meet your app's needs, so you will never be out of space when you need it. So give your users space to share their lives with Firebase Storage, available right now for iOS, Android, and web applications. And to learn more about Firebase Storage, check out the documentation available right here.
So service workers are powerful for offline caching, but they're also really good for giving you instant loading performance benefits when it comes to repeat visits.
Yep.
Right. And you can achieve that using an application shell architecture.
Yeah.
Now,
so that's kind of the idea of kind of separating content from the actual visual UI. So in my head, it's kind of like native apps. You always have the banner, you've got the navigation drawer at the side, you might have some other bits. That could be common through like 90% of your app.
Yeah.
You always want it there.
So when we talk about the shell, we're talking about the HTML, the CSS, and the JavaScript that's making up the bulk of your UI.
Yeah,
Stuff that, you know, if you cache that, you can still just like load up content in the very middle.
Yeah.
And save yourself having to constantly reload that stuff, right?
Yeah, and it's super nice when it comes to like, let's say they're visiting a page they've never been to before. If you know the layout's always going to be the same, you can still load that while you go and get the content in the background.
And it just makes sure that your user has like really good perceived performance.
Yeah.
So the first time your app loads, you're going to have to render the shell itself. You'll cache that in your service worker, and you might show like a toast just to let them know, hey, this application now works offline.
Yep.
And that means that when they come back another time, like let's say they're in airplane mode, that shell will load up really, really quickly, and then it might go to the network to fetch the rest of the content. You can then cache that content so that that entire view is then available whenever they try accessing it without a network connection.
Yeah, exactly. Spot on.
We've got some performance testing we've done with the application shell model. This is using web page tests. So on first visit, we've got a relatively fast time to first meaningful paint.
And this is super important because I think that there can be scenarios where someone might take advantage of service worker to be like, don't worry about your first load, but I'm just going to serve up like megabytes of stuff that I'm going to cache. Afterwards, you'll be super fast. But that first load, if that takes so long to the point where the service worker doesn't even get registered, that's pointless. And plus, for other browsers that don't support service worker, you're then kind of just damaging yourself.
Yeah, that's going to make your users go and cry in a corner.
Exactly.
You don't want that.
So you still want to be serving up just that static render of your site, just so then it just loads up as fast as humanly possible, and then progressively enhance with Service Worker to then use the App Shell model.
And if you are using the App Shell model, as you can see here, we've got really good, we've actually slashed our load times for first meaningful paint on repeat visits. Speaking of like actually taking a look at what impact server-side rendering has on this, you don't have to use Service Worker to actually be able to get good gains. If you're building with the App Shell model in mind, with server-side rendering in mind, you will get like a really good first paint, even in like Safari and like mobile Safari on iOS.
Yeah, all the other browsers that just don't have Service Worker.
Yeah. Now, if you're wondering, okay, well, should I be using the application shell model on all of my applications? There are going to be types of apps, like super simple apps. This might be overkill.
Yeah.
But if you're building something that's a little bit more complex, a little bit more dynamic, this type of model makes a ton of sense. At Google, we're using it for things like Inbox, and it's working really well there.
Yeah, I think it's one of those things you end up falling into the sit there and figure out whether it makes sense for your site or not. But I think it's a good overall model that works for a lot of different scenarios.
There's a whole ton behind this model that we way too much to explain in just one video, but we wrote up a pretty amazing article on this, if we do say so ourselves.
Well, you wrote it up and I just read it. So
you just added your name to the end of it.
Yeah, that's how I
pretty
roll.
much. Impact. That's worth checking out.
That's the format of this
It's a
show,
mediocre
Andy.
article at best, but it's got pretty graphics.
Yes, it does.
People should go check that out.
Yep.
Learn more about App Shell.
And then there's also the Getting Started guide for your first progressive web app, where it actually talks about the application shell model, how you can take advantage of it, as well as how it applies to the demo app that you can build in this lovely code lab.
And in that article, we also link out to tools that can help you get started with the application model like really quickly that we're working on. So check that out.
Yeah, build a weather app.
So what if I told you there was a way you could compress nearly any stream of data by a factor of 10x or more? Wouldn't that be something you'd be interested in? Yeah, I thought so. Let's find out more on this episode of Route 85. So I want you to take a look at this array of numbers here. Imagine that we wanted to send this array of integers from a server to your user's device. Looks like just a bunch of random numbers, right? Well, that word random is actually the key to compressing these in an incredibly efficient manner. As you probably know, a random number generator isn't truly random. Supply a random number generator with the same seed, and you'll get the same results out every time. And we can take advantage of that fact to recreate that list of integers using a random number generator. You see, all I need to do to regenerate that array on a device is to supply 3 parameters: the seed for an agreed upon random number generator, an upper bound to apply to these results, and the length of the list. I simply supply those numbers to a method that looks a little like this, and I can recreate that original number stream. Just like that, I've built my array of 30 integers using just 2 integers and an int 32. That's a 92% compression rate. Now granted, finding that initial seed did take some work, but you know what? That work can happen in the cloud, so it doesn't really matter. What's important is that on the device, I'm able to decompress that number stream in order and time. And then of course, once you start looking around, you can see that there's a ton of data you can compress this way. I mean, need to compress a text string? Well, what's a string but a stream of encoded integers? Once I have my stream of integers, I simply figure out what seed I need to generate them, and voila, I've compressed my string down into just 3 numbers. It's a pretty amazing savings, right? Anybody with the username of stidjexmisdizixgoodquibpubpa will be singing your praises in their reviews. And my gosh, if you think about it, an image is really just a stream of numbers broken out into several channels. Take a look at this image here, and you can see how, using our random number generator, I've been able to replace it with just 3 sets of integers for the red, green, and blue channels, respectively. Now, once again, finding the right seed can take some time, and I haven't found the perfect seed just yet. So if you look at the results carefully, you can see that this is not quite a lossless compression scheme. But I think you'll agree that for this kind of savings, these trade-offs just might be worth it. Anyway, I hope you consider using this technique the next time you have data that needs to be compressed. Remember, the more efficient you are with your users' data, the more they'll love you. Thanks again for watching. Be sure to check out other episodes of Route 85. And remember that, as my coworkers on the Android team like to say, perf matters. All right, thanks guys. I think we're done.
Who let him into the studio again?
I couldn't say no to Elijah Wood.
But that's...
Elijah Wood.
Last episode, we used a decision tree as our classifier. Today, we'll add code to visualize it so we can see how it works under the hood. There are many types of classifiers you may have heard of before, things like neural nets or support vector machines. So why did we use a decision tree to start? Well, they have a very unique property. They're easy to read and understand. In fact, they're one of the few models that are interpretable, where you can understand exactly why the classifier makes a decision. That's amazingly useful in practice. To get started, I'll introduce you to a real dataset we'll work with today. It's called Iris. Iris is a classic machine learning problem. In it, you want to identify what type of flower you have based on different measurements, like the length and width of the petal. The dataset includes 3 different types of flowers. They're all species of iris: Setosa, versicolor, and virginica. Scrolling down, you can see we're given 50 examples of each type, so 150 examples total. Notice there are 4 features that are used to describe each example. These are the length and width of the sepal and petal. And just like in our apples and oranges problem, the first 4 columns give the features, and the last column gives the labels, which is the type of flower in each row. Our goal is to use this dataset to train a classifier. Then we can use that classifier to predict what species of flower we have if we're given a new flower that we've never seen before. Knowing how to work with an existing dataset is a good skill, so let's import Iris into scikit-learn and see what it looks like in code. Conveniently, the friendly folks at Scikit provided a bunch of sample datasets, including Iris, as well as utilities to make them easy to import. We can import Iris into our code like this. The dataset includes both the table from Wikipedia as well as some metadata. The metadata tells you the names of the features and the names of different types of flowers. The features and examples themselves are contained in the data variable. For example, if I print out the first entry, you can see the measurements for this flower. These index to the feature names, so the first value refers to the sepal length and the second to sepal width, and so on. The target variable contains the labels. Likewise, these index to the target names. Let's print out the first one. A label of 0 means it's a Setosa. If you look at the table from Wikipedia, you'll notice that we just printed out the first row. Now, both the data and target variables have 150 entries. If you want, you can iterate over them to print out the entire dataset like this. Now that we know how to work with the dataset, we're ready to train a classifier. But before we do that, first we need to split up the data. I'm going to remove several of the examples and put them aside for later. We'll call the examples I'm putting aside our testing data. We'll keep these separate from our training data. And later on, we'll use our testing examples to test how accurate the classifier is on data it's never seen before. Testing is actually a really important part of doing machine learning well in practice, and we'll cover it in more detail in a future episode. Just for this exercise, I'll remove one example of each type of flower. And as it happens, the data set is ordered so the first Setosa is at index 0, and the first versicolor is at 50, and so on. The syntax looks a little bit complicated, but all I'm doing is removing 3 entries from the data and target variables. Then I'll create 2 new sets of variables, one for training and one for testing. Training will have the majority of our data, and testing will have just the examples I removed. Now, just as before, we can create a decision tree classifier and train it on our training data. Before we visualize it, let's use the tree to classify our testing data. We know we have one flower of each type, and we can print out the labels we expect. Now let's see what the tree predicts. We'll give it the features for our testing data, and we'll get back labels. You can see the predicted labels match our testing data. That means it got them all right. Now keep in mind this was a very simple test, and we'll go into more detail down the road. Now let's visualize the tree so we can see how the classifier works. To do that, I'm going to copy-paste some code in from Scikit's tutorials, and because this code is for visualization and not machine learning concepts, I won't cover the details here. Note that I'm combining the code from these 2 examples to create an easy-to-read PDF. I can run our script and open up the PDF, and we can see the tree. To use it to classify data, you start by reading from the top. Each node asks a yes or no question about one of the features. For example, this node asks if the petal width is less than 0.8 centimeters. If it's true for the example you're classifying, go left, otherwise go right. Now let's use this tree to classify an example from our testing data. Here are the features and label for our first testing flower. Remember, you can find the feature names by looking at the metadata. We know this flower is a setosa, so let's see what the tree predicts. I'll resize the windows to make this easier to see. And the first question the tree asks is whether the petal width is less than 0.8 centimeters. That's the fourth feature. The answer is true, so we proceed left. At this point, we're already at a leaf node. There are no other questions to ask, so the tree gives us a prediction, setosa, and it's right. Notice the label is 0, which indexes to that type of flower. Now let's try our second testing example. This one is a versicolor. Let's see what the tree predicts. Again, we read from the top, and this time the petal width is greater than 0.8 centimeters. The answer to the tree's question is false, so we go right. The next question the tree asks is whether the petal width is less than 1.75. It's trying to narrow it down. That's true, so we go left. Now it asks if the petal length is less than 4.95. That's true, so we go left again. And finally, the tree asks if the petal width is less than 1.65. That's true, so left it is. And now we have our prediction. It's a versicolor, and that's right again. You can try the last one on your own as an exercise, and remember the way we're using the tree is the same way it works in code. So that's how you quickly visualize and read a decision tree. There's a lot more to learn here, especially how they're built automatically from examples. We'll get to that in a future episode, but for now let's close with an essential point. Every question the tree asks must be about one of your features. That means the better your features are, the better a tree you can build. And in the next episode, we'll start looking at what makes a good feature. Thanks very much for watching, and I'll see you next time.
So constraints. They're a great way for you as a developer to deal with the ever-expanding number of screen sizes, device rotations, and new form factors like slide over in the iOS world. But one unfortunate casualty in this brave new world of alignment has been the way we animate views. See, it used to be we could go around setting a UI view's position or frame with a fun little UI view animate with duration method and watch our view scoot around the screen. Oh, that was fun. But that's harder to do in a world full of constraints. Constraints don't necessarily play nicely with a view whose frame you're setting explicitly, as you can see here. Well, that leads us to this episode's quick tip sent in by Jacob Cho, a fan of Route 85 and a software engineer at Ensemble, a mobile app developer located in beautiful Vancouver, British Columbia. Jacob notes that many iOS developers forget that in addition to the old way of animating a view's position, you can also animate constraints in iOS. Let's look at how you might do that. Here's my storyboard, and as you can see here, I've got everything set up nicely using constraints. Now to move my UI image view on and off screen, I'm going to want to change this constraint here, the one that sets my image's leading edge to the leading edge of my super view. Right now it's set to -180, so it's off screen. So first I'm going to control drag from this constraint into my view controller to make it an IB outlet of type NSLayout constraint. This allows me to access it in my code. Now I can adjust it with a standard UI view animate with duration call. In this case, I'll change the constant of the constraint from -180 to 0 so that it appears on screen, and now we can give it a try. Well, that's weird. The constant definitely changed, but what happened to my animation? Well, it turns out to get this constant to animate nicely, I need to call layout if needed on my view controller's view within this animation block. We'll give it one more try, and that's much better. I now have a constraint that I can change within an animation block, and everything animates smoothly to its final position, except in cases where I want to adjust something besides my constraint's constant. Let's take a look at another example. Here I want to adjust this center square to expand or shrink to be either twice or half the width of its neighbors. Now I could do that in theory by adjusting the multiplier on the center view's width constraint. But it turns out that changing that multiplier in code doesn't work. See, constraint multipliers are a get-only property, and Xcode will give me an error. So how do I change it? Well, the answer is I don't. Instead, I create two completely different constraints and enable or disable either one as necessary. As long as I'm still calling layout if needed in my animation block, this kind of change will still animate. Now, there are two ways I can accomplish this constraint swapping. One way is to create both constraints in Interface Builder, like so. Now, Xcode will complain that these are incompatible, and it's right. So first step, we'll uninstall one of them by checking this box here. Next, we'll control drag both of these constraints into our code to make them IB outlets. And then I can enable or disable these as necessary in my animation block, like this. Once again, you'll notice I make sure we're calling layout if needed in our animation block, and we end up with a nice smooth looking animation. Look at that. The other way to accomplish this would be to create a completely new constraint in code. This is useful when I don't know in advance what I'm going to want this multiplier to be, and I need to create it dynamically. So let's see that in action. This time in my animation block, I'll first remove the old constraint. Next up, I can create a new multiplier. Let's make it slightly random just for fun. Ooh, hey, that is fun. OK, next I'll create a brand new constraint with this new multiplier and assign it to my center view width property. And then I can add it back in again to my view. Finally, I call layout if needed on the super view in the animation block, and I once again have some nicely animating views that use this new constraint that I've created. And because this is all done using constraints, you'll notice this works as intended on an iPhone in landscape mode, or even, say, a slide over view on an iPad. And once you understand that this trick simply involves removing an old constraint and adding a new one, you might discover a whole new world of animation is available to you simply by turning on and off various constraints. For example, on this screen, I can change all my views to be either left aligned or right aligned simply by adding and removing two different groups of constraints and then calling our now familiar layout if needed method. Pretty neat, huh? Oh, by the way, one fun little quirk about all this, if you add your new constraints before you remove the old ones, iOS will complain about all the incompatible constraints it has to deal with in those few milliseconds. So always make sure you remove the old ones first before adding the new ones. So thanks to Jacob for the quick tip. Jacob, you're going to get a very stylish Google t-shirt in the mail. But hang on, we're not done yet. You see, now that you know all about constraint animation, I have a couple more quick tips from one of Google's engineers about more efficient ways to implement it. So follow me on to the next video, because we're not done learning just yet. Click here, and otherwise, I'll see you on Route 85. Bye.
People love to use different mobile devices in different ways that suit their situation and lifestyle. Michael uses a phone to play games on the go, while Tony enjoys using a large tablet as he relaxes on the sofa. And Jen carries a small tablet in her purse for reading on the bus. But they all want to use your app on the devices they prefer. So you'll want to make sure they each have a great experience, regardless of screen size, OS version, and the features of the app they use the most. It can be taxing to test each one of these situations so that all your users can be happy. We know you'd rather not have to buy and store stacks of devices and test your app in all these circumstances. That's why we built Firebase Test Lab for Android to make it easy and affordable for you to test your app with a variety of devices and be sure it works great for all your users. Our device lab, hosted in the cloud, offers a variety of physical devices ready to test your app. The selection of devices is always growing, so your tests will stay current with the latest hardware and operating systems. The easiest way to use Firebase Test Lab is to run a robo-test. This is an intelligent, automated test that crawls your app to discover and exercise its features. You won't need to write any additional code to make use of a robo-test. For more advanced testing, you can also script the interactions with your app to simulate specific use cases and verify that everything works as expected. Test results include a detailed report for each device used, including screenshots, device logs, and any crashes that may have occurred during the test. This allows you to verify that your app is working correctly on the variety of devices and configurations you selected. It's easy to make Firebase Test Lab a part of your daily development routine, and we have multiple ways to help you test regularly and spot errors early. First, you can use the Firebase console to upload and test your app. There is also a command line interface for testing with continuous integration servers, so you can automatically test every build. During Android development, you can deploy your app directly to Firebase Test Lab using Android Studio 2.0. And finally, in the Play Store Developer Console, there is a special automated launch test that will run for Android apps published to an alpha or beta channel. To get started using Firebase Test Lab and learn how to regularly test your app on different devices and configurations, you can start with the documentation available right here. Happy testing!